Welcome to Angular 2 Web Development with TypeScript, a video course by Pact. My name is Sergey Barsky. I've been working with TypeScript since version 0.4 for over 2 years. I have used Angular for over 2 years as well. I'm a Microsoft MVP in ASP.NET web development stack. I have presented at many local and national conferences on many topics, including both Angular and TypeScript. I'm also a published author with 20 years of industry experience. I have a bachelor's degree in computer science from Georgia State University. In this course, we will learn how to build applications in TypeScript. We will gain insight into Angular 2, discussing key concepts of the second evolution of this web development framework. We will see that these two technologies will allow us to build web applications better and faster. We will build this content management application as an illustration of the knowledge we will gain from this course. Although this application is not very large, it will allow us to use key features of Angular 2. We will build all the layers of the application, starting with user interface written in Angular and ending with data using Entity Framework and SQL Server. The goal of this course is to learn TypeScript and use it to build Angular 2 applications using key components of this web framework. We will start by learning TypeScript. We will see the big benefits it has over JavaScript, the language TypeScript compiles to. We will learn all the key language concepts of TypeScript. We will implement strong types, we will create classes and properties and methods, and use inheritance. We will learn more advanced concepts of TypeScript like generics and learn how to create constructors with automatic properties. We will see how we can use static methods and how they help to solve scoping issues. We will work on creating a new Angular 2 application. We will briefly discuss differences between Angular 1 and Angular 2. We will then create a shell application, our first Angular 2 component. After that, we will briefly discuss the Entity Framework and Web API to create a small service layer for our application. We will confirm that this process works by creating a test. Then we will create our first Angular 2 component that uses a template and presents the data. After that, we will see how we can implement a menu and navigate between various sections of our application. Once we get our first component out of the way, it is time to work with forms. We will learn about data validation and binding as part of this exercise. Angular 2 has many built-in components. We will discuss the common ones that allow us to show or hide information based on various conditions, add CSS styles based on data, and present information in list form. We cannot forget about our server data. We will discuss HTTP requests next. We will talk about reactive extensions library and how to use it to listen to HTTP requests. Finally, we will discuss the next steps in continuing to learn Angular 2. As we discuss all the topics of TypeScript and Angular 2, we will gain a lot of knowledge and understanding how to use these technologies together to build web applications. We will see huge benefits that TypeScript brings to application development. We will use our knowledge to build a sample application to prove that we understand the features of both technologies. Prerequisites. Some familiarity with HTML and JavaScript is certainly a prerequisite for this course. Knowledge of C# is very beneficial for following the section on data access. We will use Visual Studio 2015 Community Edition, can be used, which is free. You can, of course, use your favorite editor instead. SQL Server Database Express is free for use, and we will only use it when building web services. We will use ASP.NET Core as our project framework. We will need internet access to download all the necessary components and frameworks. We are ready to begin our journey into exciting new world of TypeScript and Angular. Our excursion will lead to a deeper understanding of web development. let's not forget that our broadened skills can help us build other applications on the same technology stack. For example, mobile applications. I am looking forward to talking to you in the next video. Hi, and welcome to Section 1. This section is our first introduction to the language called TypeScript. Why do we need another language to write web applications in? We need it because JavaScript has a number of drawbacks that impact developer productivity and quality of applications. TypeScript was designed from the ground up to enable developers to write better code than in JavaScript alone. In this section, we will be introduced to TypeScript as a language. We will talk about TypeScript features, uses, and benefits. We will see the advantages that TypeScript has over JavaScript. We will set up an environment and write our first TypeScript file. Finally, we will run our first demo applications to verify that TypeScript code works. Now that we move on to our first video in this section that discusses features, uses, and benefits of TypeScript, we will answer the key questions why TypeScript is a compelling choice for all developers that write their applications in JavaScript today. In this video, we're going to make a case for the use of TypeScript instead of JavaScript. We will take a look at the key language features such as strong typing and object orientation. We will discuss the benefits TypeScript has to offer over JavaScript, in part via compilation process. Finally, we will talk about what types of applications can be written in TypeScript. JavaScript has been the language of the web for 2 decades. It is an older language, and although it has many cool features, it obviously lags behind any modern language such as C# or Java. It lacks compilation, common error checking, and strong typing. It is close to impossible to replace it, however, because of its wide adoption and a myriad of applications written in it. TypeScript, at its core, seeks to smooth out rough edges of JavaScript by introducing higher language features and enabling much better tooling through those features. It seeks to correct common mistakes that developers make and enables them to use future JavaScript features today. TypeScript is a higher level language and brings object orientation into JavaScript world. Although modern specifications of JavaScript, such as ECMAScript 2015 and ECMAScript 7, have classes, not all browsers support all the new JavaScript features today. TypeScript offers strong typing as a #1 feature, bringing it with comprehensive error checking. It offers key features from object-oriented language such as classes and interfaces. It provides features for enabling modular applications. TypeScript also brings strong typing to JavaScript arrays via generics. There are many more features that TypeScript has, but we will stop at these 2 for now. How does TypeScript benefits realized? #1 is through compilation, sometimes called transpilation process. This process converts TypeScript files to JavaScript files. This is a key point we need to stress yet again. TypeScript does not have runtime. It is a design time language. Features-wise, TypeScript is a superset of JavaScript language. As a result, we could change an extension of our script file from JS to TS, and everything should work just like it did before. In version 1.8, TypeScript compiler can also handle JS files. When all said and done, our applications that are written in TypeScript will execute using JavaScript that TypeScript compiler will produce. Besides this conversion process, compilation has one additional huge benefit. It has error checking to ensure that common errors that are possible in JavaScript are not made. Both typing and object orientation of TypeScript enables tool developers to create much better developer experience than raw JavaScript. Because we are more explicit and precise when we write TypeScript than JavaScript, much better metadata can be extracted from TypeScript code. As a result, much better tooling is enabled. What about existing libraries, you ask? How can I integrate my existing code or third-party libraries when I start writing my applications in TypeScript? I am glad you asked. One other feature of TypeScript is definition files. Definition files, typically with .d, .ts extensions, can be created for any library written in JavaScript, providing the same metadata as any file written in TypeScript has. Hence, any existing library such as Angular 1.x can be used to code against with the presence of its definition file in TypeScript. Such files exist for all commonly used JavaScript frameworks and libraries already on GitHub. For example, you can go to GitHub page definitely type to see all the common libraries. As you can see, this list is quite extensive, and you can find all familiar libraries that we use day in and day out. What applications can be written in TypeScript? Any that can be written in JavaScript, of course. You can write web applications or Node.js applications. You can also write mobile applications that use Cordova or PhoneGap in TypeScript as well. Essentially, any app you can write in JavaScript, you can instead write in TypeScript. Excellent! We're at the end of this video. We went over the reasons why we want to use TypeScript over JavaScript. In the next video, we're going to set up our environment in Visual Studio and write our first TypeScript file. We will then run our demo app to see the results in the browser. In the previous video, we learned the benefits of using TypeScript over JavaScript. Now that we know that TypeScript can help us write better code, we need to pick an environment that allows us to create TypeScript files. We will use Visual Studio 2015 in this course, but other options are available. Once we get the tooling installed, we can create our first project and first TypeScript file. We will then run the sample to confirm the tooling works as expected. In this video, we're going to review the list of editors that support TypeScript. We're going to use Visual Studio 2015 and create new ASP.NET Core solution. We will configure the project to properly compile TypeScript files. We will add static file support, then we will create an HTML page and a TypeScript file. We will add the generated JavaScript to our sample page. Finally, we will test our solution in the browser. There are many editors and interactive development environments that now have TypeScript support. TypeScript support is provided via a web service that hosts TypeScript language service. The solution was entirely developed by Microsoft, but all the plugins for editors were developed by either corresponding companies or open source developers. As you can see, the list is quite extensive, and likely your favorite editor or IDE are supported. Of these, Visual Studio Code is a Microsoft-written open source editor, in contrast with Visual Studio, which is a full-blown IDE. In this course, we will stick to Visual Studio for all the sample code, but we will see how to set up an environment that also supports and works with other editors. Visual Studio itself has 3 editions. One of them, called Community Edition, is free for individual developers and small teams. Paid Edition provides many advanced features and target large professional organizations. ASP.NET Core is evolution of Microsoft Web Development Framework, ASP.NET. Its features include, for example, multi-platform support, whereby web applications written in it can run on macOS and Linux in addition to Windows. It also has much smaller memory footprint and better performance. TypeScript has compilation options that can be set up via tsconfig.json file that contains all the compilation options for TypeScript compile. Let's now create our first solution. We already started Visual Studio 2015. We will create a new project and we will pick ASP.NET Core Web Application. We will call the project Section 1 Code. We will pick an empty ASP.NET Core application and click OK to finish creating the solution. It takes Visual Studio just a minute to create a brand new solution. Now we need to add TypeScript configuration file. TypeScript compiler looks at this file from the folder in which the project is run all the way up to the root of the drive in such directory. Typically, we would keep the file within the project folder in order to ensure that different projects can have different configuration. To add the file, we right-click on the project, select Add New Item, and pick Configuration File under .NET Core folder. And go ahead and click Add. For now, we will put all of our files under www root folder, the root folder of our application. So just for this demo, we will remove the compiler exclusion for www root folder from the JSON node. In order to compile files on the fly, we need to add one more option, compile and save, and we set it to true. Now let's add a web page to our www root folder. We will add new item again. We will pick HTML page, and we'll just simply call it index.html. It is time to add our first TypeScript file. We click Add again, new item. This time we're looking for TypeScript template. We will add file and we'll keep name as just file.ts. Now we're going to add a few lines of code as a proof that our code works. We are simply creating a new div element, setting its text to hello world and appending it to the body. Now we need to add this file to our page. To do so, we simply drag the file in the Project Explorer onto the OpenHTML page. This will create the proper reference. Let's save the file. As you can see, the compiler compiled the file to file.js. It also created map file. What is the map file? This uses source maps features that many browsers support. This feature enables browser tools to step through source code while that source code is written in non-JavaScript language, such as TypeScript. Now we need to add static files functionality to our application. This will allow the application server to serve HTML, JS, and CSS files. What we need to do is add the proper NuGet package. We will right-click on the project, select Manage NuGet Packages, look for static files, and add the package called Microsoft.ASP.NET Core Static Files to our project. NuGet is Visual Studio's way to distribute runtime assemblies with various functionality, in this case, static files. Now we need to enable static file support in our startup endpoint of the application. In order to do that, we simply add app, use static files, and now we can go ahead and compile our project. We will build our solution. It's time to run the solution. In order to do so, we simply can click on the green button that runs the solution in IIS Express. Let's do so. This navigates to the root of our page, and we simply need to add index.html to our page. And as we can see, hello world comes up. Great! Our first TypeScript has been run successfully. In this section, we were introduced to TypeScript as a language. We set up the environment and wrote our first runnable TypeScript file. In the next section, we will start learning key concepts of TypeScript language. We will discuss classes, methods, and properties and inheritance, and also talk about debugging TypeScript using browser. Hello, and welcome to section 2, which covers key TypeScript concepts. In the previous section, we were introduced to TypeScript as a language, and we ran our first TypeScript demo. This section is our introduction to the basic yet important features of TypeScript, number one being type safety. Why is it important? It helps us avoid many trivial mistakes that JavaScript developers make at times. We will go over the basic building blocks of TypeScript, which is an object-oriented language. Let's get started. In this section, we will get acquainted with TypeScript's primitive types that are built into the language. We will use them to implement basic type safety in our code. We will extend those types with our own classes that will contain properties and methods. We will go beyond basic void functions by specifying parameters and return types. We will take a look at advanced object-oriented features of TypeScript, specifically interfaces and inheritance. Finally, we will debug TypeScript using Chrome's browser developer tools. Now we move on to the first video of this section that deals with built-in types. We will learn how to use primitive types to declare variables in our web application code. We will build on that knowledge and see how we can save some keystrokes by relying on type inference. This will give a solid foundation and insights into type safety, a key mistakes-limiting feature of TypeScript. In this video, we're going to take a look at the built-in types, such as string and number. Using types is how type safety programming feature is implemented in TypeScript. This is what JavaScript lacks. We will use native primitive types in our code to declare variables. We will see how we can get to avoid common problems with type declarations by going through type inference and casting operator. Let's get started by creating a new web project. Let's start by clicking New Project, selecting Core Web Application. We're going to call it Section 2 Code. From the template, we will pick an empty template to keep our things simple. And we'll click OK and let Visual Studio create our project structure with default files. Now, what we want to do is add a basic web page to our application. We will add it to www root folder. We'll right-click, select New Item, and pick an HTML page as our page, and we'll give it a name index. This will add the page to our www root folder. Next, we need to enable static file support for our project. We do that by right-clicking on the project, selecting Manage NuGet packages for the solution, and then picking static files from the search box. Static files. And we pick in Microsoft ASP.NET Core static files and we click Install. Now that the static files NuGet package is installed, we need to enable it in a startup.cs file. And we will delete default code and add use static files support. Now we open our page and we add a title so we know that the page is working okay. Now in this section we will learn how to use Kestrel, which is ASP.NET Core web server, to run our code in a browser directly instead of having to continuously click on this green Run in IS button in Visual Studio. In order to do that, we have to switch to command prompt, Visual Studio command prompt. Now that we are in Visual Studio command prompt and we're in a folder where our project is contained, we need to type .NET run. This runs command line tool interface that comes with ASP.NET Core. Run command will compile and run our project. As we can see, it will be available at localhost 5000 Pro. Now let's switch to Chrome. Let's run our Chrome browser and switch to that URL. And as we can see, the title says section 2. So now we know that our browser is working, and now we can continue to type our TypeScript code. Let's go ahead and add our tsconfig.json file. We add a new item and narrow down the choices by typing config, and we're looking for TypeScript configuration file. And we need to add another option, compile and save, and we will set it to true. This will allow us to edit our files and have them immediately compiled so that we can run them. Now let's add a new TypeScript file. Before we do that, let's remove the exclusion for www root folder, since that's where we're going to create the file. We're going to add a new file. We're going to narrow down choices again to TypeScript file and click add. Now let's declare our first variable of type string. We're going to call it string variable. And in order to declare type, we type colon, and then the type name. Now let's see if we can see how the TypeScript language will enforce the rules. Let's try to set our string variable to number 12. As we can see, there is an error that comes up, and we cannot compile our code because of the obvious error that says type number is not assignable to type string. There we go. This is one of the key features of TypeScript in action. Now let's take a look at the built-in types. These are the types that built into TypeScript. I am certain that they are all familiar to you. We're going to skip enumeration and function-related types or void for now. We'll take a closer look at the arrays as well when we go and cover generics in the next section. Let's declare some more variables to take a look at other primitive types or built-in types in action. This is how the feature works in practice. If we try to assign the wrong type to previously declared variable, we will get a compile time error and not runtime error. Let's declare a bool variable first, and the boolean type is just called boolean with a small b. Now let's declare a date variable, and this one is of type date. Finally, let's declare a very special variable. We're going to call it any variable, and this is going to be of type any. Any is an important marker type. Essentially, using any allows us to fall back to untyped nature of JavaScript from within TypeScript. It is crucial not to abuse this feature and only use it when absolutely necessary. Those use cases, in my experience, are fewer and far between, typically coming into play when consuming JavaScript without type definition files. Any numeric value in TypeScript is represented by just simply number type, same number type that is available in JavaScript. This will cover integer, double, and all other types. Now let's take another look at tsconfig.json file. You can see another option called no implicit any. This option allows us to omit the keyword any when declaring variables. Ordinarily, I would recommend to turn this option on by setting its value to true. Now let's take a look how this option manifests itself. We can just declare a variable as such, and if we try to compile, we will see an error that says variable, let's give it a different name right quick, dh implicit has any type. That's to fix that issue, we simply need to explicitly say that this specific variable is of type any. Type inference is the feature of TypeScript that allows us to combine variable declaration and a first assignment into a single statement. In this case, TypeScript compiler is smart enough to infer what type we want to use and save us a few keystrokes. In this case, if we move our mouse over string var2, we see that its type was inferred as string. At times, we need an ability to specify what variable or parameters is of specific type. This is where casting operator comes in. It is represented by angle bracket. Let's first declare a variable of type any, and we're going to assign it to simply an object literal with a single property called item, and we're going to give it some value. Now, we know that item is a string, but because the string literal, the object literal is of type any, TypeScript obviously doesn't know. So if we're going to say some var is of type string and would be equal to an item dot item, and we obviously lost IntelliSense because if it's of type any. In order to tell TypeScript compiler what type it is without explicit type, what we need to do is use casting operator and explicitly cast a value to a string. Now if we move our mouse over some var, we see that it is of type string. Casting operators, you see, is represented by angle brackets with a type that is contained within those brackets. And it allows us to jump in and out of tenets of type safety. Now let's take a look at the generated JavaScript file to see that our safety features only exist in TypeScript. So if we look at the compile file, we see that no types are obviously available. Awesome! In this video, we have got acquainted with TypeScript built-in types and learned the type safety syntax. In the next video, we will create our first class. Classes are basic building blocks of TypeScript code. In the previous video, we looked at how to use strong typing features of TypeScript to write better code with fewer mistakes. This laid a foundation for us to create the basic building blocks of TypeScript classes. In this video, we're going to take a look at creating our first TypeScript class. We will learn the basic structure and syntax of class declarations in TypeScript. We will add properties to our class to hold its state at all times. We will add methods to it so that it can perform many functions, optionally using information stored in properties. Let's get started. We're going to pick up where we left off in the previous video with a project. We're just going to empty out the contents of our last file, and we're going to keep tsconfig.json as is. So now that we have a new TypeScript file, let's add our first class. We use keyword class to declare it, and just as it is in languages such as C# and Java, you see the syntax. Well, you will find syntax quite familiar. It is time to add properties to our class to hold its state when an instance of the class is created. We will use built-in types in order to declare those properties. So we're going to start by declaring first name property, which is a string. Let's also add a last name, which will also be a string. And since we'll learn many types, let's add a numeric type as well. And while we're at it, let's add date of birth date property as well. And this time we're going to use date type. Let's see our class in action. Let's create an instance of this class. And this syntax will look quite familiar. We see that IntelliSense works, and we got IntelliSense to prompt for a type. Now let's set some properties. I'm going to set p.firstname, set that to John, And then let's add the last name as well. So we added a handful of properties. Let's set the age 21. And finally, let's add the birth date. And we're simply going to set it to new date of the JavaScript. Now, we should be able to run the code. So how can we tell what is going on? We're just going to add the alert dialog. And we're going to use JSON.stringify so we can see our instance as a string in a browser, specifically in the alert dialog. We see an error, and that's because instead of an equal sign, I put a colon, and now we're ready to run our application. If you remember, our Kestrel browser was already running, so we're going to switch. Kestrel server, is already running, so we're going to switch to Chrome, refresh the page, and as you can see, an instance of our class, which is a plain JavaScript object, you can see that it works completely well. Great. Now let's add a simple method to our class that uses the class's properties internally. We're going to be introduced to a new type in TypeScript called void. Void is used to signify that a function or a method does not produce a return value. In this example, we'll convert the last bit of our code, which is alert function, into a method on a person class. It will consist of a number of statements. So we're going to call our function showMe, and the return value is put after the function name with a parentheses, similarly to how we declare types on properties, same way we declare return value type on a method. And instead of doing the alert dialog, we're just going to embed our data onto the page. So we're going to create div element called of div, and we're going to set its inner text to the same value we used inside the alert dialog. So we're going to delete this, but instead of doing what we did last time, we're going to say JSON.stringify, and we're going to say this. In other words, we use an instance of the variable inside its method. And finally, we're going to find a body of the page, and we're going to add a child, which will be our div element. We're going to go ahead and save that. Make sure that the red squiggly goes away, no errors. Let's go back to Chrome, refresh that. All right, well, looks like we got an error. Namely, we simply forgot to call the method. So we're going to say p.showMe. And we're invoking a function or a method on an instance of our class, just like we invoke any other function. Let's try this again. And as you can see, this time it worked, and this variable that we saw in our code inside the function worked just fine. We could have just as easily used that property. So let's add that and simply say, let's just see this dot birthdate, where this refers to the running instance of our class, and this works just as well. Good deal. That's it for this video. We created our first TypeScript class with properties and a method, and we also indeed created our first building block of a prototypical TypeScript application, and we're in that code in browser seeing an instance of our class running in action. In the next video, we will dive deep into methods creation. See you next time. In the previous video, we created our first class with some properties and a method. The code we write is never that simple, right? In this video, we will continue to build on the class creation by learning TypeScript features that allows us to create far more complex methods. We will also take a look at scoping inside TypeScript. We're going to take a look at how scope of properties and methods to control their visibilities outside of classes is implemented. Then we will create a method which has a return value. We will proceed with adding various parameters to our methods. We will take a look at anonymous types that we will use as parameters. We will then wrap up the video by exploring a class's constructors. We will start where we left off, and this time let's add a private member called fullname. We're going to use private keyword to declare this member, and we will still use type safety, and we're going to declare it of type string. Prefixing private members with an underscore is a common naming convention. There are two scoping constructs in TypeScript, private and public. For properties and methods alike, public scope or visibility is assumed. Lack of scoping keywords such as private makes such members public, thus visible from outside the class. Private members are only visible to methods inside the class itself. There is another keyword protected that is commonly used in many languages, and TypeScript will eventually use protected keyword as well. Let's see what would happen if we try to assign a value to full name property on the person class. We will get an error because full name, as the message describes, is private and only accessible within a class person. Now let's write a method with a return value. We're going to call it makeFullName. And in order to provide a return value type, we simply need to add a type after a function name. Now we can set a private variable that we declared previously. Now let's set a value to this variable using a full name, a first name and a last name of this class. We're going to type this dot first name, and of course we can do $, this dot last name. The feature we want to use here is string interpolation, which is designated by using a $, followed by a squiggly bracket, which will at runtime replace any interpolated string with the actual value. We also use ticks instead of standard quotes. You can use ticks in TypeScript today for multi-line string values, even though this feature is not supported yet in TypeScript or ECMAScript 5. We use primitive type here as the return value, but we could have just as easily used a complex type. And finally, we need to return our computed value, which is the full name. If we want to see this code in action, we could add alert, make full name, and then let's run that code to see it in action. Because we did not set the name, it says undefined, and then finally the name, last name, do. So far, our methods did not take any parameters. Let's add a parameter to our method. So let's create a new method called setAge, which will take a single parameter, age, and we're going to declare type, obviously, being a good TypeScript citizens. And we can set the value on a private property by saying this.age equal age. This is quite simple. Let's move on. Sometimes we want our method to accept optional parameters. Let's alter our setAge. Well, actually, let's create a new method called setAge and date. And we're going to add a second parameter called birthdate of type date. In order to make this parameter optional, what we need to do is add a question mark following the parameter name. This question mark designates optional parameter. Keep in mind that it shouldn't have any mandatory parameters if the method signature following optional ones. We can now invoke this method by either supplying or omitting optional parameter name. So let's just see this in code. We can say p.set age and date, and we can give it an age only, and this works just fine. But we can also say age and a date, and we're just simply gonna create a new date, pass that in. And both of these statements compile just fine because we have optional parameter. We could also supply default values for optional parameter. This code would be similar to what we had before. So we create a new method called setNames, and we're gonna have last name, which is of type string. However, instead of doing question mark for purely optional parameters, for optional parameters with default values, we simply going to follow up the type with an equal sign and the default value. How do we invoke this method? Exact same way as we invoke all others. So we can call setNames without any parameters, or we can call it with a parameter that supplies last name in this case. Now let's discuss anonymous types or nameless classes. They're signatures that look like classes and follow similar syntax and can have properties in methods, but they don't have actual class names. It is important not to abuse this feature of the language, but at times it may save some typing for you. For example, let's add a method called setSibling. And in this case, we're going to declare a private variable called sibling. And it's going to be, interesting enough, of the same type as a person. Now we're going to add a parameter to our method setSibling. But instead of declaring a class, we're going to start with squiggly brackets. And we're going to say this will contain age as a number, a last name as a string, and maybe even first name, which is also a string. So what we're saying in this case, that the parameter called sibling should have 3 properties on it. How do we use it? We can say this dot underscore sibling is equal to new person. Then we can say this dot underscore sibling dot first name is equal to sibling, which is our parameter name, dot first name. If you noticed, and let's do one more property, last name. If you noticed, we still get IntelliSense even on anonymous types. How do we assign that? How do we invoke this method? We could say p.set_sibling. And as we discuss it with anonymous types, again, we get IntelliSense that says it should be something that looks as follows. It should have an age. It should have a last name. Again, you see we have IntelliSense. And we hit Control Space in here, we get IntelliSense for the second parameter. Voila! We just invoked this method with an object literal with 3 properties, and this compiled just fine because the signature matches. However, if we made a typo, for example, mistype first name as first name 2, we immediately get an error. Let's fix that, and let's discuss classes constructors. Constructors are just special methods that are responsible for creating an instance of a class. Constructor at its core is invoked to create an instance of a class. As a result, everything we just learned about method creation applies to constructor as well. The method name for constructor is just keyword constructor. Let's create an example. As we see IntelliSense again in action, prompting us to do the constructor work. And in this case, how about we add some default parameters in. So default parameter for last name would be just word last name. Now to create an instance of this class, we can say second person, and we're going to say new person. However, if we open up parentheses, we immediately see what signature is expected. So we could provide last name, or we can omit it, as we do in this line. And in either case, everything works great. Constructors are typically used to initialize the class's instance with some default state. In this case, our default state is the last name. Great work! That brings us to the end of this video. We took a deep dive into creation of methods in it. In the next video, we will build on top of what we know about classes and explore inheritance hierarchies. Then we will see how inheritance and interfaces help us write polymorphic code and start relying on abstractions instead of on concrete types when writing complex applications. In the previous video, we learned how to create many variations of methods, including constructors. In this video, we will learn how to build hierarchies of classes using features like base classes and interfaces. We're going to take a look at TypeScript features that allows us to create base and derived classes. We will use base class constructors if necessary. We will use interfaces to provide polymorphic features and abstract classes to share specific functionality in the hierarchy of classes. Let's get started. We're going to start with brand new TypeScript file, and we're going to create a simple class with some properties and methods. We're going to call this class a person, just as in previous example. And we're going to start with a simple property called name. You will notice a couple of keywords. One keyword is module. Module in this case serves as an isolation level, similarly to assembly in C#. You can akin it to a namespace. It allows us to control visibility of an entire class from outside of a specific TypeScript module that contains that class. We use this export keyword to make class person public outside of module called base. Let's add some more code. This additional code I added in looks quite familiar to you by now. We have a method and a constructor that initializes an instance of a class with some data. Again, we use some string interpolation for some other functionality. Now, let's add a derived class. We're going to start by creating a new module called inherited. And we're going to export yet one more class. We're going to call this class student. So far, looks pretty familiar. We're going to add some college-related functionality to this class. We're going to inherit from our person class, and we use a new keyword called extends. And we fully qualify person class with the module base. It is important to know that it is good not to abuse inheritance in a feature and create very deep hierarchy. The main reason to inherit something is to inherit behavior or methods, not properties. Let's add a constructor to this class and some properties. So first of all, let's add a property called college of type string. Now I'm going to try to set it all using a constructor here. And we're going to start by saying, well, when we set a person, we probably also want to set name and age as well as college. Now we get an error over here. If we move our mouse over, it says for derived classes, we must make a super call. Super means call the base constructor. And in this case, since our parameters match, we can pass the same parameters into a base class constructor. And finally, we can set college by using a student-specific parameter. Now, let's add some code to our main module and see our classes in action on a web page. Let's start by creating an instance of a student by saying new inherited module dot student, and we're going to pass in some parameters here, and a college we're going to say GSU. This gets a little bit verbose, so let's look at another feature of TypeScript called import. Import allows us to alias class names. In this case, we can say from this point on, we can refer to inherited.student as simply student. Now we can delete fully qualified name and have everything still working just fine. Now we're getting an error because we mistyped age. Age supposed to be a number. So let's fix that error. Now let's make sure that this code actually works by displaying the results in a browser by calling stringified as well and passing in a student to that. So let's run this code by flipping to Chrome browser and refreshing our page. And as you can see, we see the student name and the college. Everything so far works as expected. Now let's call some methods on our student class. For example, let's call a base class method. For example, present yourself. Let's take this code out for a minute and rerun our browser. And here's our base class. How about an inherited class? We don't have any methods in the inherited class, so let's add one. We're going to call it change college, and we're going to give it a new college name. And we're going to set the property using this qualifier to the new college name. Now if we look at this code, we can say student dot change college, and we're going to say Georgia Tech. As you can see, we call base class methods and an inherited or derived class methods interchangeably quite seamlessly. It is time to explore another object-oriented feature, interfaces. Interfaces provide us with a contract for our class, specifying properties and methods that a class should have. As a result, we can have multiple implementations of the same interface, affording us an opportunity to implement polymorphism, a core tenet of object-oriented language. Let's create a simple interface that provides some login capability. We're going to declare a new interface in a new interface keyword, and we're going to say logger. And no matter which logger we want to use, we're going to have a log method that has some text that we want to log. And we're just going to make it optional for now. But of course it needs to be of type string. And now we see a method declaration without an implementation. So we have method name, parameters, and a return value, but no implementation, which is what interfaces are all about. Now we can add a property to it as well. We're going to call it default text of type string. And here's our very simple interface. Now it is time for our code, responsible for login, to have some important information. So we're going to start by creating what's called an abstract class for our multiple implementation. So if we have a common functionality that all of our loggers need to have, that should belong in some kind of a another base class, not the final implementation. So let's create that. We're going to call it abstract logger. And of course, it needs to implement our interface. And here comes another keyword that we haven't seen before called implements. So what that means that we have an abstract class which we cannot directly instantiate that implements iLogger. We're going to have the actual log method. We're going to keep it as abstract, which means that each implementation of abstract logger, each derived class, has to provide an implementation. And of course, we need a property. Now we have a full implementation, and our error that we just saw went away. And of course, if we want to do some default instantiation, abstract classes, unlike interfaces, can contain implementation. And in this case, we can just initialize default text to say word none. Just like so. Now we have an abstract class with some functionality that is common to all derived classes. Now we can move on and create some kind of logger. So in first logger, we're going to call it body logger that extends abstract logger. Extends is the same keyword we used already. Now we have an error because it says a logger has to provide an implementation for a log function. And we're going to do so. We're going to create a specific implementation using some familiar code. This code we have seen already a handful of times. So our body logger simply appends the log text to the body of the message. We also could optionally add implements keyword here, even though strictly speaking it's not required because abstract logger already implements the interface. But this simply just to illustrate that you can extend something and implement completely different interface with a single class. Anytime you implement interface, implements keyword is required. Now let's create another logger that simply puts up an alert message. As you can see, this code is just as simple. Now, how do we create those loggers? Same way that we can create any instance of any other class. So we can create new body logger, or we can say log2 is a new alert logger. And then we can call log1 and log, and we're going to say log1.log and just give it some text. And of course, we can do exact same thing for log2. So we invoke in both classes exactly the same way. This, however, does not demonstrate true power interfaces. True power resides in blindly using interfacing without knowing the implementation. How could we do that, you ask? Let's simply create a function, and we're going to call it logfunc, and it's going to be a function that takes some parameters and returns no value. In other words, it's a void function, and say it takes some text, which is a string, and it takes a logger, which is of iLogger, and inside there you can just blindly call logger.log and pass in text. We can simply pass either logger as a parameter, so we can say logfunc stuff, and then we can pass in log1, and that compiles and runs just as well as if we were to pass in log2. We see a little bit of new code in here, a fat arrow function, which is the new syntax that's coming to JavaScript in the future, but you can use it in TypeScript today. And this is a shorthand declaration for a function. We have parentheses, then equal greater than sign, sometimes referred to as fat arrow, and then squiggly brackets to designate body. Awesome. We end 2.4 video here. In this video, we have learned how to use inheritance and share some functionality across multiple classes and use interfaces to create contracts to reduce coupling between parts of the system. In the next video, we will learn how to debug TypeScript user browser tool. Hello. In the previous video, we'll learn how to build class hierarchies in TypeScript and use interfaces to reduce coupling and create polymorphic code. Anytime we write some code, we need an ability to debug it. We will start with setting up a solution to produce debugging information. We will run simple TypeScript code and use browser tools to set breakpoints. Finally, we'll perform the same tasks using Visual Studio, which is one more option to debug TypeScript code. We're going to start with our last project. We're simply going to add debug.demo.ts file to it to save some time. Now let's take a look at tsconfig.json. It has a property called source map, which we set to true. This will produce the map files that would allow us to debug TypeScript files natively in the browser. Most modern browsers support source maps features. We already have an HTML page, so let's write some code. Let's create a new class. We're going to call it clickable. And we're going to have it create a button on a page via a method. So we're going to call method called createButton, and all it's going to do is create a button for us on a page. Just to save time, I typed it all in advance. And all we do, create a new element of type button. We add in a text to it. We also point in the click event of the button to the method of this clickable class. And all this method does is puts up an alert dialog. And we append in that message to our page. Now all we have to do to activate it is to create an instance of the class and call createButton on it, the method we added. Now we should be able to run this in Chrome. I already have my DNX running on port 5000. All I have to do now is switch to Chrome browser and navigate to index.html page. Now if I click the button, the alert window comes up. Now let's take a look at the code that we generated when we compiled our TypeScript file. In debug.demo.js, in the last line we see source mapping URL is debug.demo.js.map. That's the file right here, not humanly readable, but all it does, it establishes the link between debug.demo.js, which is our executable code, and debug.demo.ts, which is our source file. Let's get back to Chrome. Let's pull up the power tools in Chrome by hitting F12. Here's our power tools came up. And under sources, we already see that both debug.demo.ts and debug.demo.js got loaded. We're interested in TS. And what we want to do is put a breakpoint inside the alert window, inside our file. So to see if our breakpoint is hit, let's refresh the page and click on the button. Our debugger got paused on this line of code inside TypeScript file, inside Chrome, which is not even Microsoft tool. And if we look at this variable, local variable, which is our button, and if we add If we switch to console window and we type EV, which is our event arguments, mouse event comes up, we can completely interact with TypeScript file through console window as it is a JavaScript file. And of course, we can use the watch window, set the breakpoints, and perform our typical debugging operations. Let's accomplish the same thing using Internet Explorer and Visual Studio. All we need to do is switch back to TypeScript file, set exact same breakpoint inside the TypeScript file inside Visual Studio. We have to switch to our browser to Internet Explorer. Now let's run in IIS Express, which is a Visual Studio built-in web server. Let's click Run. This should launch our Internet Explorer on default pre-generated port. We're going to navigate to index.html and click the same button. Now the breakpoint got hit inside Visual Studio. We have exact same watch windows we saw inside Chrome, except inside Visual Studio now, and we can examine variables, we can look at event arg, and if we look at the immediate window, we can interact with it just like as we would interact with the console in Chrome. Awesome! This brings us to the end of this section. We accomplished quite a bit in this section. We learned that TypeScript primitive types are essentially the same types as JavaScript has. We extended the type system with our custom types, our classes. Each had properties and methods. We then progressed from simple methods to more complex ones with parameters and return values. We built a complex class hierarchy using interfaces and inheritance. Finally, we ended up debugging our TypeScript code in the browser and in Visual Studio. In the next section, we will advance our knowledge of TypeScript's key coding concepts. In the previous section, we looked at the key concepts of TypeScript language. In this section, we will discuss TypeScript features that are less commonly used but important nonetheless. We will start our discussion with features that improve the readability of our code, enumerations, and constants. Block scope, along with readability, improves the safety of our code. Static methods allow us to run code without creating an instance of a class. Although we cannot create pure static classes as of now in TypeScript, we can create classes with just static methods. We will then look at more property-related features using backend fields and initializers. We further dive into generics, which improve code safety in the use of JavaScript array. Finally, we will look at the ways TypeScript solves inherent problem with this keyword in JavaScript. We now move to the first video of this section that deals with enumeration, constants, and block scope. In this video, we will learn how enumerations and constants allow us to give meaningful names to numbers and strings in TypeScript. We will create block-scoped variables that will keep our code more consistent and safe. I have pre-created the same project structure we used in previous demos. I have also started up the web server, so we're ready to write our code. I've created a file.ts, which is where our sample code will go. We are going to use it just a bit, but first we should also discuss that we can use explicit enumeration values as well as implicit values for each enumeration member. Let's go ahead and create our first enumeration. We're going to call it person type. And we're going to add two values to it, simply active and inactive. As we discussed before, we could also give him explicit values, just like we could in C#. And here's how we would do that. All we need to do is add the value after the equal sign to each name in order to be more explicit. let's go ahead and add a class that will use this enumeration. We're going to call it a person, and we're going to add a property to it, just like we did in previous example. We're going to call it person type, and it's going to be of type person type, which is an enumeration we just defined. Let's go ahead and add a method to this class so we can see what our class looks like when serialized to be sent to the server, for example. We're going to add an alert window, and we'll simply stringify our instance in order to observe the result. Let's go ahead and create a new instance of a person. And now let's switch back to the browser to run our example as soon as we call the show method. While we're at it, let's go ahead and assign new value to person type, which would be, say, inactive. Now we're ready to run our code. Let's refresh it. And as you can see, the person type was given a value of 1. As we can observe, enumerations do not really exist at runtime because JavaScript simply doesn't support them, and at runtime they're replaced with actual numbers behind enumeration members. Nice! So the number 1 that we saw corresponds to inactive type. Now let's move on to constants. Let's define a default person status we were using in the previous example. We'll define constants by simply using a const keyword, and we're going to call it default status. Then, of course, we have to give it a type. And finally, we give it a value, person type dot active. This is how the constants work. As you can see, we have much more readable code. Now let's try to use this constant in our class. We will add the constructor here, and inside the constructor we're going to set default person type dot person type equal to default status. Now we can take this line out for a minute since we observed the default status, and let's go ahead and refresh our demo, and now the person type comes up at 0. It is worth noting that constants are supported even if you target ECMAScript 5, which does not have built-in support for constants. So we can use this feature of JavaScript even though they're not supported by all browsers today. By the way, ECMAScript is the official name used for JavaScript. It is time to learn another safety feature called block scope. Block scope allows us to use the name of the variable inside the block of code. Let's write a new function to demonstrate that. In this example, we're going to print a specific phrase based on the person type. To do so, we're going to say if this dot person type equal to person type dot active. Then we're going to define a block scope variable name. We're going to call it a phrase, and this is going to say I am active. And finally, we can just do an alert of the phrase. And in the else, we can define exact same variable one more time. You certainly cannot do this in ECMAScript 5, but you can when you use TypeScript. I am inactive. So as we observe, we just reused the variable name because let keyword, which defines block scope variables, defines the variable just for the current scope. In this case, it would be the block, that starts with the if statement, in this case would be an else statement. We could also use let keyword anywhere within any block and improve readability as our code improves. That's it for this video. In this video, we have learned how to use enumeration, constants, and let keyword to improve readability and safety of our code. These features become more important as code base grows, which is one of the strong points of TypeScript, and improve the handling of code in very large applications. Sometimes create an instance of a class is not necessary to call a method, but classes provide a nice way to encapsulate code. In the next video, we will discuss how static methods and properties can let us write such code. In the previous video, we learned how to make our code more readable and safe by using enumerations and constants. Sometimes we need to write methods that do not logically belong to a class, and they simply are useful functions that do not need to persist or use a state of a class. We may also want to share data between instances of a class. This is where static properties and methods come into play. We will begin by creating static properties to share data between multiple instances of the same class. We will proceed by creating static methods, which by far is the most common use case for using statics in TypeScript. We will run the code using classes without creating an instance. Finally, we will round off this video by discussing how we can create utility classes by using only static members in any given class. I have pre-created the same project structure we used in previous demos and started a web server. We're going to start by creating a new class with a single static property, and we're going to call it person yet again. And the property is going to count number of instances. We already know how to create property. Created instances, it is equal to 0. So the only new keyword we see here is a static keyword that indicates that this property is going to be shared between all instances of the same class. And what we want to do is count how many times a constructor is called. We're going to create this constructor, and in this case, instead of using this keyword, we will use class name instead, and we're going to increment number of instances of that class. Finally, let's see this in action. We're going to create a couple of instances of the class and one more, and P2 and P1 are simply variable names, and then we're going to count. We're going to see how many times our static property was incremented by creating an instance of a class. Let's flip to browser and refresh browser page, and as we can see, our class was created twice, and because this property was shared between both instances, our counter is 2. Let's move on. It's time to proceed with the same use case for static methods, the most common one, which is utility classes. So we're going to use a new keyword we learned last time called module, and we're going to create a new static class. And again, we're going to make it public by using export keyword, and we're going to call it logger. In this case, the logger will simply handle errors as they occur. We don't need to create an instance of this class just to simply call a static method. We use the familiar static keyword. We're going to say handle error, and it's going to take single parameter called error. And we're simply going to, for now, log it to console. We're going to say console.log, and we're going to say error for now. We don't need to get too fancy. Let's pretend an error might occur in some try-catch block. And we're going to catch this exception that is thrown. And all we want to do is log it by calling our logger. And we're going to say utilities, which is our module name or namespace, handle error, and we're going to pass in our exception. This is all we need to do to use the code. So all we need to do now is simulate the exception, and we can simply call some non-existent property on a window class and some method on it that also non-exists. This should throw an exception, and we may need to also bail out of our type safety just for a minute while we're testing and use our casting operator that says whatever window is, I don't really care, I'm going to assume it has a property on it called something. So as you remember, now we break out of type safety of TypeScript by only doing it for demo purposes. So let's flip back, run our code, pull up the console window, and as you can see, our error got logged because our class got called. Let's expand our example by looking how we can refactor our code to move entire exception handling code into our utilities class. We're going to create another class called runner and put it into the same module. As you can see, we can have any number of classes inside the module. And this is going to be it's going to contain a single method run with exception handling, which will take some function we need to run. And this is going to be of type function. We use the new keyword here, function. This designates really any function in TypeScript regardless of parameters or return values. Inside this method, we can simply call the function in our try catch block, which we could simply just copy from here. And we're going to run a function that is passed into us. To call that, we simply need to create this function as a variable, and we're going to see another syntax we haven't used before, which is the native JavaScript syntax actually. And we can say alert window dot something dot something else. And now we can call runner, which is going to be in our utilities module, utilities dot runner dot run with exception handling, and we simply can pass in our function. This JavaScript code is just a reminder to us that TypeScript is JavaScript extension language. Therefore, it supports all JavaScript syntax natively. In the previous block, we can always create an instance of the runner or logger class. There is no point in doing this, however, because we do not need an instance of a class to call a static method. Let's see how we can keep those classes from serving as means to create an instance. If we try to use static keyword in front of the class name, however, we will get a compilation error because static keyword is only supported on properties and methods. In order to do that, we need to simply throw an error from the constructor of the class that will tell a developer who's erroneously using an instance of our utility class that they're doing something wrong. And all we need to do is in the constructor of such a class, throw new error with some descriptive message such as class creation not supported. In this video, we have used the static keyword to implement code that does not require an instance of the class to run. We were able to successfully create a static property, and a static method, and a static class. In the next video, we will extend our knowledge of properties by creating automatic properties through constructors and by using backing fields. In the previous video, we'll learn how to use static methods and properties to implement utility code in our application. We're going to look at advanced property definitions in this video that will allow us to run code when property is set or retrieved, for example. In this video, we're going to take a look at advanced features of TypeScript that deal with properties. We will create properties on our classes by using constructor declaration syntax. We will then create properties that have private backing fields in order to run code when property is set. Finally, we will learn how to simulate read-only properties in TypeScript. Let's get started. We're starting with the same project structure as in previous examples. Let's start by creating a new class. We're gonna call it person yet again. Let's go ahead and add a constructor to this class. Now, let's say we need to add some public properties for the name and age of a person and also set them in a constructor optionally if the values are passed in. Let's see how we can accomplish this task. Previously, we declared name as a string, and we can even specify a default value of none if we wanted to, and say we want to do the same thing with age, which would be a number in this case, and the value, default value would be of 0. In order to create properties using TypeScript, automatically, based on variables or parameters passed into the constructor, all we need to do is add a familiar modifier, public or private, scoping keywords to signify the constructor parameters need to be turned into properties. Another thing we could do is add useStrict. As we can see, TypeScript natively supports useStrict phrase that JavaScript allows. This turns our running JavaScript using strict mode, which for example does not allow us to use undeclared variable. Let's see this code in action. Let's create an instance of a person class by creating a new person. Now to set the property, we can type p dot, and we see that our IntelliSense reflects the case that our parameters to constructor got turned into properties. So we can set name, for example, to Jane, and we can set the age to 20, for example. Now we can say alert, and we're gonna use the same example we used before to ensure that our code works as expected. Now let's flip to our browser and run our code. And as you can see, the code worked as expected. We got our property set to the values that we specified in the constructor. Now let's add a new property to our class that will allow us to write some code when a property is set. And what we're going to do is declare a property backing field that's going to be private. First, we're gonna say full name, and this is going to be a string. Now we need to declare a property that's gonna use this field, and we're gonna call the property full name. And even though it's a property, you can see that we're using a method syntax because the property actually has parentheses after it. And now we need to return this dot underscore full name. And now we have property accessor. Now let's write a property setter. We're gonna use set keyword, the same property name as the method name. Now we need to pass in obviously a value, full name, and this is going to be a string. That method returns nothing. In other words, it's a void method. This void keyword is optional because TypeScript can figure it out. So we could actually delete the void completely out and let TypeScript do that work for us. In here we can say, do some logic. For example, if the full name is not passed in, then we can maybe throw some error like that. Throw new error, name required. Otherwise, we can simply set it by using this keyword to access to the current running instance of the class and setting the backend field to the value that is passed in. This code that we use in property with backend field relies on object.defineProperty JavaScript API, which requires us to set up compilation to use ECMAScript 5. Since all modern browsers have full support for ECMAScript 5, this is the default output mode for TypeScript compiler. We can use person.js file that was generated for us to verify that that's indeed happened. And as you can see, object.defineProperty API was indeed used. If we want to know for sure which features of JavaScript we can use many helpful websites. For example, we can go to caniuse.com to see what specific features are supported by various browsers. Let's say that I do not want to have a setter. I truly want to have a read-only property. For example, we're going to call it year born, and this is going to be a numeric property, which is signified by having a number in it. And we're just going to write some pseudocode in it that is using the age property, which we're gonna add, which already exists. So now we can return new date. New date dot get full year, and we're going to subtract this dot age. So this truly is a read-only property. We could have it as a method, but property seems much more useful. How can we use this code? We can simply say alert person.yearborn, which shows up indeed as a property, as we can see from IntelliSense, and not a method. What would happen if we try to set that property to some value? As you can see, the compiler ignores it. So there is a shortcoming with implementation of read-only properties. In this case, TypeScript follows JavaScript standards which allow getters without setters, whereby the setter does nothing instead of throwing an error, which would really be more clear for developers who make mistake in using the API. Still, there is a lot of value in read-only properties because they describe our intent very, very clearly. In this video, we built on top of previous property declaration knowledge and looked at the advanced property syntax. In the next video, we will generate generic classes. We will also see how we can create strongly typed arrays. In the previous video, we learned how to set up automatic properties via constructors. We used properties with backend fields in order to embed custom logic into property setting code. We also created read-only properties. In this video, we're going to take a look at generics in TypeScript. Generics is the functionality that exists in many modern languages that allows developers to create various type-safe data structures. We will start with the most common and powerful use for generics in TypeScript, strongly typed arrays or collections. We will then proceed by defining common generic interfaces and classes that can be used in multiple places in our code. Then we will explore generic parameters and return values with our functions. Finally, we will see how we can constrain our generics. Let's jump right in and add an array of parents to our person class. It's going to be a parents property, and it's going to be an array of person object. As you can see, the syntax is similar to arrays in JavaScript. We just need to add a type in front of the array brackets. There is also an alternative syntax that's using the actual word array, and this is how we would do that. We would use an array and then the angle bracket and then a person type. And this is how we would define a property for grandparents, which is also an array of a person. You can use whichever syntax you like. I prefer the simpler one as it allows us to type less and it looks much closer to array syntax in JavaScript. It is time to use our new structure and add some parents to an instance of our class. First, we're going to create new person. Then we can add some parents to it. So we can say var mom was going to be new person as well. And then we can say p.parents.push mom. As you noticed, TypeScript does not invent new syntax for JavaScript array, and we can still use the same push and pop methods. Let's run our code and see what happens. So if we run that, nothing really happens. So let's pull up browser tool and look at the console, and we see an error that says cannot read property push of undefined. So we missed something. Let's see what that is. We did not define an array. We defined a property, but we didn't initialize. So the best way to do that would be in a constructor. So we can say this.parents is a new array. We can do it this way, new array of person. So this is one thing. Oh, let's better use grandparents here. Or we can say this.parents, and we can simply use JavaScript array initializer. Let's make sure that this code works by adding an alert dialog here. And see what our person looks like right now. Let's refresh that. And now we see the name. Now both of our parents and grandparents got initialized. And we see the instance of our class, although we didn't specify any names, so it's a little bit hard to judge. As I mentioned, whichever syntax works for you, the one you want to pick. It is time to create our first generic class. Let's add a class. And we're gonna say we want to represent some kind of a result returned by a service along with data and success flow. So let's define a result class of T. As you noticed, the syntax that we use is similar to array syntax in here, where we specify a type that we want to use. However, we don't specify a concrete type. We just say at some point we're going to specify the type later. Now we can add a property to it, such as success, which would be our success flag, and this would be a boolean. And now the result itself. What type would the result itself be? It would of course be type T. So we use T as the type marker without specific value. We can even use a constructor in our generic classes, just like in any other class, and say by default we want to say that success would be set to true. T in a type definition is the generic type parameter, which specifies that this is substituted with the actual type definition when a class is instantiated. How would we create an instance of this class? We could, for example, say var result would be new result of person. And this is how we could instantiate an instance of the class. Now let's try to use generic type in function call. So we're going to create yet another class. We're going to call it storage processor, regardless what that storage is. Now we can say get person result. Say we want to get some kind of a person result based on a name. What would our return value be if we wanted this to be a result of a person? It would be a result of person. That's how easy that would be. Now we can say var return value would be a new result of a person. And then we can simply return that return value from our function call. And now our storage processor returns that. Of course, we could also set the actual t value, which in our case is the person. So we can say return value dot result would be a new person. And this code compiles and runs just fine. In this case, t in a result becomes a person. How would we want to do that? We could actually go a step further and say return dot result dot name is equal to the name that we passed in. So if we were to run it, we could say var storage new storage processor. Now we can call storage dot get person result. We're going to pass in the name of John, and we can simply put an alert on it. And again, we can just use JSON.stringify, so we can observe exactly what is happening here. Let's run this code. As you can see, we get the class structure, which, as we mentioned, doesn't exist in JavaScript, but it returns exactly what we would expect, which is the person by the name John and the success flag set to true. There is something I want to mention. As you probably noticed, the angle bracket has multiple usages in TypeScript. Generics is probably one of the primary ones. Just as we use generics for classes, we could just as easily use them for interfaces. So let's say we want to extract an interface from the result. We're going to call it iResult because we need to remove the constructor. And now our result class can implement iResult of t. This gives us even more flexibility with interface use, as we can use it for multiple purposes. I also want to call out the fact that the function returns a generic type of person, just to make it clear that we expanded the result or use of generics from classes to functions. Just like in other languages that support generic, we're not limited to single generic type, and we can use multiple ones. For example, we can use two generics in another function that we're going to call getPerson based on input, for example, where one of those values is our input. So we can have an input of type t, for example, and then a return value would be iResult of type v. And for now, just to get it to compile, we're going to return null. This code is kind of messy and not super useful. What improves generic functionality is in TypeScript is a feature called generic constraints. Let's add constraint to a generic parameter type. For example, let's say that t must be a person. We have another use for keyword extends. In this case, we say that T must extend a person, and we can say V must maybe extend person as well. These constraints don't have to be the same types, but they provide us an ability to constrain our inputs and outputs in order to make fewer errors. This code does look quite a bit complicated at a first look. The purpose for this video is to acquaint us with powerful feature that TypeScript has when it comes to generic, and enable us with the possibility to recognize when generics are called for based on our use cases and use them as we see fit. That's it for this video. In this video, we dived deep into the world of generics. In the next video, we will see how TypeScript helps us solve an issue with this pointer in JavaScript. Hello, and welcome to Solving This Problem video. In the previous video, we have learned how to define strongly typed collection. We then proceeded by creating generic classes. Finally, we created generic functions and added constraints to generic parameters. In this video, we're going to take a close look at this pointer problem in JavaScript. We will solve this problem in two different ways. First, we will resort to fat arrow functions, which are part of upcoming JavaScript standards. Then, we will use constructors and local functions to address the same problem. Again, we have pre-created the same project structure as in previous demos. Take a few minutes and do the same if you'd like to follow along with this video. Let's first demonstrate the problem with this keyword we're trying to solve when this pointer does not refer to our class instance when a method on this instance is invoked. The most common way to create this issue is to respond to events. Let's create a class that adds a button to the page and wires up an event that will show an information about this class. Here's, for example, such class. Write-up button simply creates a button and then wires up the click event pointing to a method of our class and adds the button to the body as a child. Now, what if we want to show the person's name when a button is clicked? So we can do an alert. We're going to use the tick syntax again for multi-line variables along with string interpolation. And we can say hello from, then our $sign and squiggly brackets, and we're going to say this dot name. And we're going to add a constructor to our class. And we're going to declare a property, a public property in that constructor of type string. And this time, we're going to make it mandatory, not having an optional parameter. Now, let's create an instance of this class, a person class. First thing we want to do is wire up a button, p.writeUp button. Oh, now we're getting an error because we didn't specify a mandatory parameter. Let's do that. We're going to wire up button, and then we're going to wait for somebody to click, and we should see the message with a person's name. Let's flip to our browser, refresh that, click the button, and as we observe, hello from doesn't have the name we provide. Let's pull up browser tools. Let's use our debugging skills to set up a breakpoint on the alert window, and then click it again. As we can see, this pointer, in this case, points to the actual button, not an instance of our person class. It is time to address this issue. Typically, in JavaScript, if an object raises an event, then the scope of the event handler will be the object that raised the event. It's just a prime example of JavaScript deficiencies. There is a feature in the upcoming JavaScript or ECMAScript 2015, formerly known as ECMAScript 6, which is called a fat arrow function, or sometimes it's called just simply arrow function. Let's see if we can solve this problem. Let's use the new syntax. Instead of overriding this function, we're going to simply create a new one. And we're going to give it a name with an arrow, say hi arrow function. And it's still going to take the same parameter as the mouse event as it did before. However, the syntax is going to be slightly different. We're going to assign a member a value which is already a function, and this time we're going to use the fat arrow syntax, and by fat arrow we call the equal sign followed by greater than sign or a right hand angle bracket, and the code inside the function stays the same. Now we're going to assign a new function as our handler. And if we move my mouse over the definition of that function, you will see the definition is still the same. It's a function that takes an event, single parameter, and returns void. It's going to be the same thing here. It's a function that has a single parameter and returns void. Let's run our code this time. Let's reload. Put a breakpoint on the alert here. And now, even though that this says button still in our watch window, however, the things still work as we expected them to. And the system says hello from John. This happens because TypeScript inserts some code. Even though we compile to ECMAScript 5, it inserts a magical code that fixes the problem with the this pointer. If we want to see this code, we can simply open the compiled JavaScript variable, and we'll see how TypeScript does it. It declares behind the scene variable underscore this in the constructor of our person class, which turns into a function when compiled, and points to itself. At that point, set hi arrow func is, instead of using this pointer, it's using underscore this, which points to itself established in the constructor. And the one unfortunate outcome of this, that the function is not put on the prototype, but instead put on an instance, whereas write up button is put on a person prototype. This is a very slight issue because the only side effect of that, of not using prototype, is slightly higher memory usage, because each instance of a person class will have its own instance of the function. Another way of solving the same problem is to use the same trick that TypeScript is using. We're going to declare a function without, this time, without the actual implementation. And we're going to call it signature only. And all we say that it's a function that takes one parameter. And so we declare a member that takes a single parameter and it returns void. In other words, this declaration is quite similar to the one we use in the interface, where instead of the full member, we simply declare the signature. Now, in a constructor, we can capture this variable into, in our case, self-local variable, and then we can say this dot say hi signature only is going to be a function that is in fact quite similar to what we already typed previously. In this case, we simply assign function inline similarly to how TypeScript compiler does it, and if we repoint our code, it still compiles and runs just fine. The only difference is from compile TypeScript and what we just wrote is that we declare a signature of the function in the class definition, but the implementation we set up in the constructor. If we flip back to the Chrome browser and refresh it, everything still works as expected, and hello from John showed up. This code demonstrates a common technique used in both JavaScript and TypeScript, capturing this pointer in the constructor and preserving it for future use. Personally, I feel that first syntax is much cleaner, but sometimes the second version of syntax allows us to write more streamlined code, especially when we do not have properties, but instead use constructor parameters inside functions. That is it for this section. Awesome! In this video, we'll learn how TypeScript comes to our rescue and helps us address this pointer problem in JavaScript. In this section, we have learned enumeration and constants and how they help us write more readable and maintainable code. We saw how statics can be used to write utility functions and classes. It is important to only use statics when appropriate. We'll learn how to define properties in the constructor to write less code. We use generics to add type safety to our collections. Finally, we solved this problem using TypeScript. In the next section, we will start writing our first Angular 2 application in TypeScript. See you next time. Hi, and welcome to section 4, Start an Angular 2 application. In the previous section, we looked at advanced TypeScript concepts. In this section, we will get started with Angular 2 by creating our first Angular 2 project. The first step would be to understand key Angular 2 concepts. Then we will set up our first project in Visual Studio. We will go over the key Angular 2 building blocks required for us to learn and conclude this section by writing our first Angular 2 component. Now we move on to the first video of this section that deals with understanding Angular 2. In this video, we're going to take a look at Angular 2 framework. We will learn the differences between Angular 1 and Angular 2. We will briefly discuss Angular 1 because key concepts are carried over to Angular 2. We will talk about the new features in Angular 2. What is Angular? Angular JavaScript framework has been around for years. It is described by the authors as MVW framework, model, view, whatever. It removes the need for us to manually wire events and data in web applications, which was the mainstream approach in jQuery and similar frameworks. Angular is sponsored by Google, and the key staff are full-time Google employees working only on Angular. At the same time, it is open sourced, hosted on GitHub, and accepts community contributions. All these facts combined have made Angular a huge success with over 1 million developers using it. It is time to jump into architectural pattern behind Angular framework. MVC or MVVM or model view model patterns. Angular stays out of exact pattern details, building on top of separation between view and model primarily. Models are pure JavaScript objects. Views are pure HTML pages or page fragments. W stands for whatever, or simply the glue that holds model and view together. There are some key features that made Angular a resounding success story. Data binding is probably number one feature. It helps developers eliminate a ton of jQuery style and JavaScript that listens to event and pulls or pushes the data into user interface based on HTML. In Angular 1, controller and scope played a key role in data binding, which automatically keeps user interface in sync with underlying models or POJOs or plain old JavaScript objects. HTML DOM manipulation via directives in Angular 1 allows developers to extend DOM as described by HTML standard. Dependency injection is at heart of the application that is composed from views and models. It allows dynamic construction of reusable JavaScript components such as services and controllers. Forms and user input validation also play a key role in Angular. There is, of course, HTTP functionality, which is responsible for communication with the server in order to get the data. Finally, there is another part of the framework, navigation and routing, that listens to URL changes and starts and processes of presenting the user with the appropriate views tied to the specific URL. The entire framework is very extensible, proven in addition to built-in directives and services and ability to create user components. Most parts of these key features are shared between all Angular versions. There are two versions that exist in Angular world. Angular 1.apps are primarily composed of controllers, services, and directives. Angular 2, which went beta in late 2015 and went RTM in September 2016, is drastically different from developers' perspective, but shares many key features we just discussed. Primarily building block of Angular 2 is a component. Why Angular 2, of course? Angular 2 is not an evolution of Angular 1, but a revolution. It is a complete rewrite with the new code base written in TypeScript. In part, it is drastically improves performance of Angular apps. Depending on its functionality, performance improvements in key areas result in 2 to 4 times better performance. It is also at the same time more memory efficient from the user perspective, hence it has smaller memory footprint. It is much smaller code base, therefore with fewer problems. Awesome new framework we'll look forward to using. Let's talk about what is new in Angular 2 and how it is different from Angular 1. Data binding, of course, is still there. This includes two-way data binding in style of Angular 1. It also supports one-way data binding of complex structures. Unlike Angular 1, Angular 2 applications consist of components. Components are akin to a combination of controllers and a template-based directive. A component typically consists of code and HTML template that can contain bindings to data, exposed by a component as TypeScript properties and methods. Although Angular code base itself is written in TypeScript, developers are not limited to writing apps in TypeScript in Angular 2. They can also write Angular 2 applications using JavaScript. However, we already saw the benefits of TypeScript in previous sections. There are new tools written specifically for Angular 2. If you used to use Batarang to troubleshoot Angular 1 in the browsers, Batarang allows you to do the same with Angular 2. Angular will ship with a command line interface or CLI utility that will allow developers to do things like composing HTML-based components on the server instead of doing it on the client. All key browsers, of course, support Angular 2. No support for Internet Explorer 8 or earlier, though. And it can integrate with Angular 1 via ng upgrade. In this video, we briefly discussed the history of Angular and its version. We looked at key features that Angular offers to developers and how Angular 2 is different from Angular 1. In the next video, we will create a new project and add all the necessary scripts to power Angular 2. In the previous video, we learned the key developer features in Angular. We talked about Angular 1 and 2 moving parts and components and discussed how Angular 2 is different from Angular 1. In this video, we're going to set up a new project we will be using for the remainder of the course. We will set up MVC6 to be used with it and also set up the rest of the environment to make it easy to develop using Gulp and ASP.NET Core watcher. Let's start by creating a new ASP.NET Core project. We will click on New Project link. From .NET Core, we pick ASP.NET Core Web Application. We're going to name our project Contact Manager. On the next screen, we'll pick an empty template. And we'll click OK. And it will take Visual Studio just a second to create our new project. Now, we need to add NuGet packages necessary to support certain static files such as JavaScript, CSS, and other files. We will open up our project.json, which is where all of our NuGet packages reside, and then we will add necessary files for static file support, and we'll go ahead and add MVC support as well. We will save this file, and it will take Visual Studio just a second to restore all the packages. In addition to that, we need to add support for .NET Core Watcher. We will add the additional package under Tools, and we will save our file. We could just as easily add this functionality using Manage NuGet Packager for the solution window. Now we're ready to create tsconfig.json file to support all of our TypeScript configuration. We will add a new item, and from the item template, we will pick tsconfig.json file. It'll take Studio just a second, and then from .NET Core, we will type config to narrow down the search criteria, and we'll pick tsconfig.json file. In order to support Angular, we would need to add a couple more things to this. We would need to add a module. We're going to pick system as the module loader, and we're going to add module resolution to node. And we will leave the rest of the settings as is and go ahead and save this file. Next step, we need to create a homepage controller and MVC view. Well, we'll go ahead and add views folder under Contact Manager, and we just go ahead and add a folder. We're going to call it views, and then we're going to create a handful of views. One is going to be called home. Under home folder, we're going to create index.cs.html, which is not going to have a whole lot of code in it. We just want to confirm that the project is set up. And under shared, we will have our default layout, which currently is virtually empty. And we create a view start to specify the default layout we're going to use for our views. So at this point, our views folder is done. Now we need to create a default MVC controller. We're going to put them by convention into controllers folder. And now we're going to create a new class inside there. And to correspond with our home's views folder, we're going to call it home controller. It has to be named the same as the folder in order to use this index.cs.html view, and it's going to have just a single default method that returns the default view. In the next step, we need to wire up the startup class to enable MVC and static files functionality. So we're going to open our startup.cs, and in configure services function, we need to add services.add MVC service, which will add all default MVC services. Then we're going to delete this pre-generated code, and we're going to add use static files call in order to enable static files function. Now we also need to use MVC functionality, and this time we're gonna pick MVC with default route. Use static file functionality will help us serve JavaScript and HTML and CSS files. Great! It is time to test what we have done. The easiest way to monitor MVC code is to use Watcher. We already added Watcher command. Now we need to switch to command line window. It is very easy to start the Watcher. We simply type .NET, which is the command for .NET runtime, and we're gonna say .NET watch run. This will spin up the runtime, compile our contact manager project. We see compilation has succeeded, and it says that it's ready to listen on port 5000. It is time to flip to the browser window and test to see if our page is served up. We should see a title of our homepage. So far, so good. It is time to set up Angular 2 script files. Let's switch back to the Visual Studio. First, we need to add npm package.json file to our project. Again, we're going to add a new item, and this time is going to be configuration file for Angular that we're going to add to npm. So let's go ahead and do that. Because this list is quite long, I went ahead and copied it in. This includes all the necessary Angular files, which is broken into module, but it also has some supporting files that Angular 2 relies on, such as reflect metadata, RxJS, and zone. I went ahead and put in the Bootstrap framework that we're going to use down the road. I also added typings, which will enable us to pull in TypeScript definitions file for any necessary libraries. And I went ahead and put gulp here as well. As you can see, packages are being restored. Alternatively, we could jump to node prompt and use npm directly to include the packages. We can also monitor this install from the output window if we want to. We also added this core.js in a library, which could be used to import the necessary things like promises. All these dependencies are part of core Angular. It is time to decide how we're going to handle our TypeScript file. We're going to write them in the app folder right now. So let's go ahead and create this folder. We're going to add new folder, app. The root of our application is this www root folder. We're going to copy the files once they're compiled into that www root folder. We will set up a simple gulp script to do so. So we're going to create a new gulp file in this same folder. And I pre-built it a little bit because there's quite a bit of code in here. But most of it is simple. We have a task for third party that copies all Angular and all the supporting libraries from node modules folder into www root, and I kept the destination for third party just node modules. Then I have a copy task that copies all my files from the app folder into www root app folder. And that folder is where all of our custom files will reside. And I have a watch task that watches this app folder for any changes and fires the copy command to move them to www root folder. This will enable us to quickly develop our application. When we do production build, we can skip TypeScript and map files, which will be generating copies by default. And finally, the default task, when I run it from command prompt, will simply fire all the necessary scripts to clean out the folder if it already exists and copy whatever files have been generated already. Let's make sure that our setup works as expected. let's create in the app folder, let's create a new file. Before we do that, however, let's jump back to the command prompt and let's start gulp. So far, everything works. So now let's add a new file, a new item, and this is going to be a TypeScript file. We're going to call it main.ts. And we're just simply going to export a single file called main. And we're simply going to have a single test method in it of type void. And we're simply going to do an alert in here. Let's correct the typo. Now if everything worked right, let's flip back to the command prompt. Let's restart gulp here. And it'll run through the application. Now let's edit main.ts. Let's change something in the file. Make sure that it gets properly compiled and then gets copied into app folder. Okay, this time as I'm saving the file, I can see that it's not compiling. So let's open up our tsconfig.json. And I forgot one thing. Compile on save needs to be turned to true to enable the integration inside Visual Studio. So let's resave this file again, and we should see it compile just fine. If that still doesn't work, we can go ahead and restart Visual Studio. Let's go ahead and make a small change. And as you can see now, file is compiled and both map file and the JavaScript file were generated. And if we look at www root folder, we can see that our main got copied over. We should see that the watch command did its job. Alright, in this video we have set up new project that is using both ASP.NET Core and TypeScript. We set up all the command line tools to enable us to easily develop our web application. In the next video, we will go over the key concepts of Angular 2 that we will be using in our application. In the previous video, we'll learn how to set up new project that uses both ASP.NET Core and TypeScript. We set up all the command line tools that will enable us to easily develop our application. In this video, we're going to take a look at key concepts of Angular 2. We will discuss components, services, and directives. We will learn how to package our application artifacts into modules. We will understand how dependency injection works. And finally, we will discuss the types of directives that Angular supports. Components are at the heart of any Angular 2 application. They are, at the core, they're just TypeScript classes. They contain properties and methods and any business logic you might need. Even Angular 2 application is also a component, topmost root component specifically. There is something required to be added to all these classes to make them components. We need to add metadata which tells Angular how the component needs to be used. Let's use addComponent decorator for this purpose. This decorator itself is a class. It has a number of properties. The key ones are selector, template, and dependencies. Services will be injected based on provider's property of the component decorator. Components themselves can depend on other components. In other words, in a template of one component, you may reference other components by their own select. Think of your application as a tree of components. Also, components can optionally be grouped into modules. By default, we can import each individual file as a module. They, of course, can communicate with one another via inputs, outputs, and events. Here's an example of a component. It is a class called example, tied to an element with a tag of my example, replacing it with the content of a template located inside app/example.html file. Alternatively, we can use an inline template using template property instead of template URL property. Inside of our templates, we can use one of the most important features of Angular, data binding. Data binding allows us to specify how data flows between properties and methods of our class or component to and or from HTML elements in the DOM. There are a number of data binding syntaxes that Angular 2 supports. Interpolation is the simplest type. The interpolation data inside double brackets is replaced with the value of the property or a method specified in the name. It does not technically need to be a property. It can be any valid Angular expression, such a function called or a complex JavaScript evaluatable expression. Property binding is the most commonly used with input controls and should refer directly to a plain property on our component or any class in its object graph. Event binding allows us not to create a directive per event in DOM any longer. We can also raise and consume our own custom events in the same fashion. Finally, there is a two-way data binding where data flows back and forth between DOM and our component bidirectionally. That is really a nice feature. At a high level, we see modularity represented by ngModule decorator as a basic unit of packaging of your application. In terms of C#, it is very similar to a namespace or an assembly in .NET. There are some hard rules to ngModule, which is in itself a TypeScript class. You must package all of your artifacts. One artifact can only belong to one module. In order to use any components that belong to one module in a different module, we must import them first. ngModule, here's an example of ngModule with its properties. It's defined by contact module class and decorated with @ngModule decorator. ngModule decorator has the following key properties. Imports. Those are your dependencies, typically other modules or route declarations that your module relies upon. Declarations are the components, pipes, and directives and directives that belong to that module. Provider contains services typically that are used inside this module. They're all injectables. Exports are the components that are visible outside of this module, so they could be imported into any other module. Entry components are typically used inside the navigation. In other words, they're starting points of screens. And finally, Bootstrap is typically used in a root module, in a root components to bootstrap your application. Services are also simply TypeScript classes. They're used to help us separate concerns in our application. This will also help us keep our components from getting excessively large and keep them from doing too much work. Commonly, services are used to address some cross-cutting application concerns, but they can service other purposes such as handling data. Here is an example of a service. The only difference from a plain vanilla TypeScript class is the @injectable decorator that sits on top of the class declaration. Directives in Angular 2 serve the same purpose as they do in Angular 1. They are responsible for DOM manipulations, and they address UI concerns. There are two big types of directives. One is a structural directive that changes DOM in a significant way. There are some built-in structural directives such as ngIf and ngFor, where ngFor is loosely equivalent to ngRepeat in Angular 1. We're probably not going to write many structural directives, if any. Second is an attribute directive. They're to enhance DOM in some fashion, not to change it to a large degree. Component itself is also a directive. Here's an example of an attribute directive. As you can see, we added @directive decorator to a TypeScript class. We can also see that our constructor takes some parameters via dependency injection. ElementRef and renderer are playing similar role to what was played in JQLite or jQuery in Angular 1. Dependency injection is at heart of Angular 2. We have seen decorators on many of our Angular TypeScript classes. They specify in part the dependencies that any given class has. Angular 2 uses dependency injection throughout its own application to compose objects, and decorators specify how components are injected and/or constructor. Dependency injection is explicit. It can be specified in the decorator or during the bootstrapping process. Here's a simple example how injector class works, responsible for dependency injection. We specify the dependencies that our class might need. Then we can inject those dependencies into a constructor of a configured class. That is true power of dependency injection. That's awesome. In this video, we have reviewed key parts of Angular 2 framework. We know that our apps are composed of components and are also comprised of services and directives. In the next video, we will create our shell page that will house all of our Angular components of our Angular application. In the previous video, we learned how key components of Angular 2 work. In this video, we're going to build on top of that last project we created by finalizing the starting page. We will start by adding required Angular 2 dependencies. Then we configure module loader and inject server-side information into our page. And we will finish by running what we created in preparation for right now first Angular 2 component. Angular 2 is the client-side single-page application framework. As such, it requires a way to start running the application code. At times, the starting point is called a shell page. This is the name we're going to use. In order to create a shell page, a few steps are necessary. First of all, we need to add required Angular 2 dependencies into our page. Angular 2 requires a number of libraries, and we'll add all of them. We need to perform other configuration steps, such as necessary server-side configuration variables, and we will create a module loader. Finally, we need to bootstrap our initial TypeScript class. Let's get started. We will pick up the project where we left off in video 4.2. We will open layout CSHTML file and add the necessary dependencies for Angular 2. Layout page is essentially a page that hosts our initial page inside the render body section. In our case, this is just an outer frame for all the pages inside ASP.NET Core. We can easily just use plain HTML page instead of a compilable CSHTML page. There are 4 key scripts we need to make Angular work. First of all, for support for the older browsers, we're going to load the older browser shim. Then we need to load the zone loader, then reactive extensions, and reflect metadata, which is just reflect.js. Then we need to load our module loader, which is a system.js. Finally, we will load our bootstrapping file, which is simply system.config.js. This tilde slash in ASP.NET Core simply points to the root of the web application or www root folder. Let's edit our main.js file and add a couple of lines of code to ensure that everything is working. But we'll simply create an instance of our class and call the test method to see if the alert dialog comes up. That's all we're going to do here. Now we need to configure the module loader. So let's take a look at our bootstrapping file for system.js. I pre-typed because it requires quite a bit of code, so let's walk through it right quick. We have a couple of modules here. So one is our application module, which is bootstrapped from the app folder. Then we have our Angular module. And I'm not renaming node modules, but some people prefer to call this folder vendor. And it's going to go under our www root folder. And there it resides at Angular. And finally, our React.js resides in node modules, our React.js. Then we define our packages here, and we define our starting point, which is our main file we just edited, as well as default extension, which is JS for all of our files. Then we have some boilerplate code that lists all Angular package names. And finally, we create the config folder where we map out our application and Angular parts. And finally, we bootstrap it by calling system.config. So essentially, our starting point for our app is going to be main.ts file. Now we simply need to import our starting point of the application. And we're going to go back into our shell page. And we import our initial module, the system.js module to be specific, called app, and we already specified that the starting point for it is going to be main.js file, and we're simply catching errors here. So if an error comes up, it'll echo to the console, and if everything was successful, we will see that echo to the console as well. Again, I'm going to simply copy and paste this code in because it's a bit of code. So we see simply executing IFI or immediate executing function in JavaScript in this case, and we simply creating a variable on a main window app called my Angular app. And what we're doing, we're simply injecting root application URL as an example. Essentially, if in IIS we're running stuff running our application virtual directory, where we need to know what that virtual directory is, versus running from the root of the server. There could be a use case for other components as well, and we might need this setting down the road. So let's go ahead and save that. And again, we see that our configuration data is injected. Let's flip back to our browser and let's refresh our page. And as we can see, our data got loaded, and we also see that gulp is working and our changes got copied over to the root of the web app. And configuration data is a single JavaScript object where root URL in our case points to a slash, which is the root of localhost port 5000. Good deal. So in this video we added a shell page with all the necessary script to house our Angular 2 application. In the next video, we will create our very first Angular component that will serve as a welcome page for our application. Excellent work! Hi, and welcome to the last video of this section, creating our first component. In the previous video, we'll learn how to create a shell page. Now we're ready to plug in our first component. In this video, we're going to create our first component class designated as such by the use of the component decorator. We will specify the selector and a template. We will explore data bindings, see them in action, and finally see how to create server-side template as well as an inside template. Let's get started. We briefly talked about component directive previously. As we start creating our first component, we need to create our TypeScript class first. We just need to add a property and a method. Then we need to add a component decorator after we import the necessary modules. In order to do so, we import the core module that contains the component decorator. Next, we need to specify an inline template in this case and an HTML tag based selector. This tag will be replaced in the DOM with our template. Then we will add the tag that we specify to our shell page. We will create a module that will contain our component, and finally we will add bootstrapping code. Let's get started. We'll pick up where we left off in the previous example in our main class. Let's add the new component. We're going to add a new item again. It's going to be a TypeScript file. And we're going to call it app. And this is going to be our root component for the application. At the end, it is just a class. We will call it simply app. And we will add a couple of properties. Really, we can add just one property to it. We're going to have a name of this person, and this is just something to validate that everything is working right. And we're going to add a method as well. I'm going to call method say, and here we're simply going to add the alert dialog. We also could be explicit and specify that our method returns void. Now we could specify a message that we're going to show, and we're going to use string interpolation here to say hello from, and we're going to say, whoever the person is, which is going to be our this.name property. We will go ahead and add a constructor so that we can initialize our name. And we're going to simply say this.name is equal Angular2developer, because this is who we are. And this, for the most part, concludes our code necessary to test our main application. It is time to annotate our class with a component decorator. First of all, we have to import that. So we're going to add the import statement. We're going to import the component decorator. And we're going to import it from a core Angular 2 module, which is denoted by @Angular namespace and then core. Now we should be able to use our component decorator. And to do so, we use it just like we use attributes in, say, C#. We're going to say @component, where @symbol, as we learned before, is the symbol that designates a decorator. And now we just need to specify the property in the object literal that defines the shape of our component decorator. We could even hit Control space to see all the available properties. In this case, we're going to specify selector. And selector is just like an HTML DOM element. It's simply which tag, in our case, is going to be replaced with this component. And we're going to call it app-shell using one of the conventions to use two-word based DOM element name or additional DOM elements to keep them separate, but even by accident, by colliding with the built-in HTML DOM elements. And then we need to specify a template. And in a template, again, we're going to use a simple code, which is just a demo code. I'll go ahead and paste it in instead of typing it all in. As you can see, we want to show the name, and we have a basic event binding to a click event of a button, and it should call our say method. We see a warning here, and what it is that we need to set some settings on our TypeScript configuration file to enable the decorators. In order to do so, we go back to tsconfig.json file, and we're going to add a couple of properties. We're going to set experimental decorator parameter to true. In addition to that, we want to emit the decorators, and we do that by setting emit decorator metadata to true as well. And now we can flip back to our app file, and our warning should go away after those settings take effect. Now let's try to build our project. If we build it, we will see some errors coming in. And those are errors from TypeScript, meaning that it cannot find some of the new feature in JavaScript, such as promise. In order to fix that error, what we have to do is drop to our command prompt for a minute and type the command line to install typins. Typins, install, and what we're installing is core.js, which doesn't have any executable code, and neither does the rest of the typins functionality. All it does is installs necessary dictionary file with the extension .d.ts files that we mentioned when we talked about TypeScript earlier in the sections. And we want to save it to the typins configuration file, and we want to install it globally. DT is the central default registry for typins for the typins and PM module. As you can see, it was created and core.js was installed. Let's build the project one more time to see if the error is resolved. And in just a second, now it says build succeeded, meaning that our error went away. The next step is to update our shell page to use our new component. Since we use MVC home controller to output index CSHTML inside underscore layout CSHTML, we need to alter index HTML to add our selector, app shell selector, to our index page. We will open it, right click, it says home page, and right below we will need to add app shell tag, which denotes our first initial component. And tag can just stay empty in this case. And here's our resulting page. There is not much in it. Now we need to create a module that we talked about earlier to house our initial component. Again, module is just a TypeScript class that is decorated again with a specific decorator called a gmodule. Again, we will add a new TypeScript file, and we will call it app module. You can use whatever naming convention suits you. A lot of people use just lowercase letters. My personal preference is to use camel case. And I call it app module. And when all said and done, app module, in my case, or in our case, is just a class. So first of all, we need to declare and export it. Export class and we're just gonna call it app module. It doesn't really have any code in it. The critical part is to use ng module. We will import ng module decorator the same way we imported the component decorator. Again, it lives in @angular/core, or the same Angular module. We need to also import browser module. Browser module contains all the critical part of the application that allows Angular to be bootstrapped. We only need to specify just our module in the ng module decorator. So let's add ng module. Again, we will use object literal to specify the properties that we need. In this case, we will use the imports property that we talked about before, and we only need to import browser module in this case. Browser module should only be imported one time in the application during the bootstrapping. Now the next step is declarations, which is all of our components. In this case, we only have one component called app component. In order to use it though, we need to import this as well, but this time from our file. We need to also specify the destination for browser module as well, and we're going to import that from browser platform @Angular. And now we need to import app. An app is located in our own file, which means we need to use a relative path in order to import it. And our relative path is really the same folder. So we're going to say // and it's the app file. And now, as you can see, our errors go away. We can actually click on app and hit F12 and it'll navigate to our app class, just to confirm that everything is working right. And finally, we need to bootstrap our component, which, since app is our starting component, we simply repeat the same component we had before. Time to bootstrap our application. Now we just need to start our application by changing the code in main.ts file, which we use simply as a convention. All we need to do is bootstrap our starting or main module. Now we need to import our own class again. So let's delete the test code, and we're going to import some of the same things that we imported in our app module. We need to import platform module, which is platform browser dynamic. And this is imported from platform-browser-dynamic. What dynamic really means is the fact that we're going to do compilation of our application inside the browser. By compilation, I mean Angular compiling templates and components together. And again, we need to import our app. And now we just need to bootstrap it by calling platform browser dynamic function. And we need to bootstrap our starting module, which is going to be our app module. So let's change that. And let's change our import code to import, instead of app, import our app module. As you can see, the syntax for importing our own code is slightly different, using relative path comparing to the imports for Angular, which use simply module names. Just a reminder that all we needed to do is change our main or starting point. It is time to run our application. In order to run our application, we just need to flip to the browser window, navigate to port 5000 where we host in our app. And as we can see, our code came in, our component got instantiated, and since we see our name here, Angular 2 developer, that means data binding is working. Just to confirm, let's click on the button, and as you can see, our component got successfully invoked, and a name got substituted, which means everything we've done so far in our component is working as designed. Great work. We used an inline template in the demo, but we can use server-side templates as well. Those could be plain HTML or, in case of ASP.NET Core, MVC pages. Let's create both. Let's start with just HTML. All we need to do is create simply a new file, and we're going to create it in the same folder. So we simply add new file. We're going to call it, just give it a name. In this case, we're going to call it simply shell.html. We're going to leave it in the same folder. The template that we need is essentially the same code that we specified in the inline template. So we're going to replace the default code with this. We need to reconfigure our component to use the external template. What we need to do is simply comment out the code that's using template and specify, instead of a template URL. And a template URL is going to be our shell HTML page. Our template is located in the app folder. We'll start there, and it's called shell.html file. And this is really all we need to do. So let's flip back to the browser, refresh our page, and make sure it still comes up okay, and it does. If we wanted to, we could just change something in this file just to confirm, and we could change the title to say external template. Now let's flip back to our browser, refresh it, and make sure that a message comes up. As we can see, it says external template, which is great, because our template is now working. External template is working as expected. Of course, what's the main advantage, you say, of internal versus external template? So one advantage is that you deal with HTML editor, which makes it a little bit easier to write HTML. The disadvantage could be that anytime you make a change, you technically have to edit both files. If template gets really, really large, it takes you a long time to scroll before you get to the code in your component. So really, it's up to developer to decide what we need to do. So now let's proceed to create an MVC template. All we need to do is flip back to the same folder, and we're going to create a new item, in this case MVC page, and we're going to call it _shell. Underscore is just a convention for partial views or partial templates. What goes into that template? Exactly the same code as we had before, and we're going to change the title to say MVC template. Now we need to add the invocation to our home controller, and we're going to add another method to it. We're going to call it shell, and it's going to return a partial view instead of a full view, and a partial view is going to be located in the views folder, and then it's going to be in our home controller or home folder for home controller, and it's going to be called _shell.cshtml file. We do need to build the project since we just made .NET side code change. The code inside the template pretty much stays the same. Now we need to update our component and point the URL. We got a little error because we have a background compiler running as well, and I forgot about that. So now we need to update our component, our root component, and get a new URL going in there. And because it's a home controller, URL is going to be home. And since our method in a controller was called shell, that translates to home/shell URL. Let's go ahead and save that. And now it's time to run our app. So we flipping back to the browser. We're refreshing the page again. And if everything worked right, in just a second, we should see our view that says MVC template. And the button, of course, still works, which means everything's working. Great. We are done with our first component. And we created the template for our first component using all three available sources. In this video, we created our first Angular 2 component with a property and a method. We saw our data binding in action and learned two ways, or more specifically 3 ways, we could deliver templates as an inline template or 2 types of server-side templates. In this section, we'll learn what key Angular 2 components we can develop. We also learn the differences between Angular 1 and Angular 2 and learn the benefits of Angular 2. We set up the new project using ASP.NET Core. We studied some of the key Angular 2 concepts. Then we set up our first project in the studio and created our first component. In the next section, we will create Web API web services with Entity Framework code to supply the data to our Angular 2 application. Hi, and welcome to Section 5, Creating Web API Web Services. In the previous section, we saw how to start our first Angular 2 application. We will start this section with a brief overview of Entity Framework and Web API technologies. We will then create data access layer with Entity Framework. We will consume this layer from our Web API controllers that serve as web services. We will configure controllers and Entity Framework at our application startup. We now move to the first video of this section that gets us acquainted with Web API Framework. Our Angular application needs to communicate with the server in order to get or process data. We need to understand how to use Web API for this purpose. In this video, we're going to take a look at the Web API and how it can be used to build web services. We will see how controllers are at the center of the framework. We will learn how to use routing to map URLs to methods. We will take a quick glance at filters that address cross-cutting concerns that need to be satisfied at all requests. HTTP is the great protocol for building web-based APIs that expose operations and data. HTTP is everywhere, and it is simple. In our case, it is great for building web services that our Angular application can consume. Prior to MVC 6 or MVC Core, Web API was a separate framework. Now it is part of ASP.NET Core along with MVC 6, framework for building server-side heavy web applications. We already saw how we can use MVC to create HTML pages on the server. MVC 6 or MVC Core is cross-platform and can be run on Windows or Linux. At the end, we'll just create classes with properties and methods. Each public method maps to a specific URL and an HTTP verb, such as post or get. Let's create our new API project to see some sample code. To do so, we start new project. We'll give it a name. We'll give it any name. We'll pick an ASP.NET Web application. Click OK. And on the second page, we pick Web API. Let's take a look at the controller that was created. In this sample default example, we use HTTP GET to get an array of strings. HTTP verb is specified as an attribute inside square bracket. Web API is an abstraction on top of HTTP. It can listen to HTTP requests sent to the server, then locate a class that is responsible for handling the request. Web API does context, negotiation, serialization, deserialization, and other mundane tasks transparently to developer. Web API fully supports dependency injection at its core. You can inject all necessary components into your controller, into a property, or on the constructor. We just saw a controller class. It is a critical focal moving part of Web API framework. Controllers do all the work of handling web requests and responses. A controller method is written to handle one specific web request. It has to be mapped to web request's properties. It typically does some work, then returns a result that is converted to HTTP response. A method can contain parameters and return values. Parameters could come from body of the requests by post verb. They can come from the query string, typically for GET requests. You can explicitly map a parameter to a query string or body, or go with web verb-based default. Complex parameters are of course supported and are returned, as so are return values. Most commonly both are JSON-based. Controller methods can be synchronous or asynchronous. Asynchronous methods are all about scalability, not speed. They carry inherent overhead, but they allow the server to handle more requests. We can attach routes to both controller classes and methods. Routes support keyword controller. This way, if we ever rename controller, we do not have to rename the route. Alternatively, we can put any string into a route. Just remember to try to stick to REST standards. Here's an example of a route that contains ID in it, which is converted to a parameter. We can omit routes altogether and follow straight naming conventions. For example, if a method starts with the word get, it will be mapped to HTTP get verb. In the code we just saw, we use explicit route. We're going to stick to explicit routes in this course. As you saw, methods can be decorated with HTTP verb attributes instead of rely on naming conventions. We are going to stick to this practice as well. Filters are an important part of Web API. They are designed to address cross-cutting application concerns, such as authentication or error handling or logging. They can be run on all requests. They can be attached to actions and controllers or be global. Great! We're at the end of this video. In this video, we have been acquainted with the Web API framework, the tool we're going to use to build web services for our Angular application. In the next video, we will talk about Entity Framework, technology that is used to build data access layer on top of a database. In the previous video, we learned high-level goals and design of the Web API Web Services Framework. In this video, we're going to learn how Entity Framework allows us to easily talk to the databases. We're going to look at what Entity Framework is and how it works. Then we'll look at how the code will be structured. Finally, we will see how databases move forward along with the application code. Entity Framework is an example of an ORM, or Object Relational Mapping category of technologies. As the name implies, these tools are making it easier to convert the data between a relational database and in-memory objects or object graphs. Entity Framework has been around for years. We will be using Entity Framework 7, which is a significant rewrite of the software. It's Microsoft answers to developers' demand for an ORM on Microsoft technology stack. It is built on Microsoft core framework, which is streamlined, performant, and cross-platform. It can run on Linux or Windows. Entity Framework is built on provider model, whereby a single provider is responsible for implementing database engine-specific code. Entity Framework ships out of the box with SQL Server support, but other providers will surely be forthcoming. Such providers already exist for Entity Framework prior to version 7, for example, Oracle, DB2, or MySQL. In Entity Framework world, similarly to other ORMs, individual objects are referred to as entities. Entities, at simplest level, represent rows in a database table. Entity Framework allows us to write them as POCO or plain old CLR objects. Entity Framework has abstractions that turn plain objects into entities, enabling features like querying and persistence. Chief class that converts individual entities to table representation is dbSet of T, where T is a generic type parameter or just an entity type. dbSet is a table abstraction. Of course, types in .NET do not care about things such as how long a string must be to be persisted in a database. To accomplish this task, we need to be able to configure persistence. This can be done via conventions, attributes, or decorators, or via explicit Fluent API. One could mix and match these strategies. We will stick to Fluent API in our examples, thus making everything explicit and easy to follow and maintain. Database consists of tables. We need to have a database abstraction that exposes table abstractions. This class in Entity Framework is called dbContext. dbContext exposes tables through generic collections of dbSet of entity type. Entity Framework supports dependency injection. dbContext was designed to be injectable with an ability to be configured before or after injection process. Certain moving parts of Entity Framework itself could also be replaced via dependency injection, such as connection factory. Of course, configuring database is not enough. We have to evolve database structure as our code evolves. This technology is called database migrations in Entity Framework world. In other words, as we write C# code that represents entities, we create migrations to change the database as part of the next version of software deployment. Of course, migrations themselves can be easily created by scaffolding entity classes. As a result, the effort of creating migrations is pretty small. Well, that's all about in this video. We have briefly discussed key moving parts of Entity Framework, an object relational mapping tool that we will use to query and persist the data. We will call Entity Framework objects from our Web API-based services. In the next video, we will put the knowledge from this chapter to work by creating necessary classes to access the data. In the previous video, we learned how Entity Framework allows us to easily talk to the databases. In this video, we're going to learn how Entity Framework allows us to create classes and configuration in order to model and talk to database. We will model relationships in code. We will use configuration code to fine-tune the database structures. We will create and deploy migrations to evolve the database schema in code. Classes or entities in Entity Framework most often are written to model tables, whereby each instance of such class represents a row in a corresponding table. As a result, we mostly need to know what type in .NET corresponds to what type in the database system. Each property in our class maps to a column in a database. We are going to start building our contact management application now. Let's start by creating a simple class corresponding to our person type. Person type is defined by name, but also needs a property corresponding to the primary key column. In our case, is a number. In this case, we only have two properties. We need to discuss optional or nullable columns in a database. In simplest terms, all nullable types in .NET will correspond to nullable columns in a database. String type supports null, so string properties by default will translate to nullable column. We will see how to control this behavior later. Let's take a look at more complex example, a person class. You can see how birth date is defined using nullable date. This will allow the column in a database to be nullable. By contrast, active flag is just Boolean, which will translate to a non-nullable column. It is time to dive into configuration for our classes. Configuration allows us to control data structures more precisely. There are a number of ways we could use to accomplish this goal. One of those ways is data annotations. Those are just attributes or annotations that we can use to decorate our properties in classes to give Entity Framework more hints as to how database needs to look. For example, in our previous sample, we needed person type name to be non-nullable. We can decorate the property with the required flag or attribute. There are other annotations that support column lengths or range of values as well as many others. For example, here's how maximum length annotation looks. That specifies that type name has to be no more than 30 characters long. In a sense, our classes are no longer POCO classes because they carry additional information not relevant to business logic in .NET, but specific to persistence details. One common way to avoid this is to use Fluent API instead of data annotations to separate our concerns. On top of that, some Fluent configuration API is not represented as data annotations, so sometimes Fluent API is the only way to go. To stay consistent, we will stick to Fluent API in our app. This API is exposed primarily on the class called Model Builder. In this example, we are achieving the same what we specified with data annotations using Fluent API. We get an instance of Entity Type Builder, which is what our person type is. Then we configure one property at a time. You also see that we specify the key property explicitly. This is not necessary because Entity Framework comes with a number of conventions. One of them is primary key convention. If a property is called ID or class name plus ID, Entity Framework will assume it is a primary key property. There are a number of conventions in Entity Framework. In our demos, we will stick to explicit code for clarity most of the time. Use SQL Server identity column configuration method. Instruct SQL Server to map the property to the column type identity. Let's take a look at relationships. There are a few types of relationships we need to model. The most common ones are one-to-many and many-to-many. One-to-many has a variation of 1 to 0 to many, which we accomplish with nullable types quite easily. There is also one-to-one, which is far less common. Let's look at one-to-many example first. We accomplish relationship modeling by having classes refer to related classes. In person class, we see person type and person type ID properties, whereas person type class would have a collection of persons. We also need to write some configuration code for both classes. Although we can do it in a single method on the context class, we're going to break it down into configuration class per entity. As you can see, we specify that person type has many persons with single person type with foreign key property of person type ID in person class. This is how we tie it all together by specifying what we need to do when a parent record is deleted. In this case, we're going to restrict deletion if there are any child rows. Person class is the other end of the relationship, and the code in it is just a reversal of what we saw in person type map. We see that there is only one person type per person. Many-to-many relationship is implemented at the database level with a junction table that contains foreign keys from both related tables. If this table has no other columns, it could be omitted from the class structure. This, as of Release Candidate 1, has not been implemented in Entity Framework 7, but it can be accomplished in Entity Framework 6. Let's see how Entity Framework 7 code looks right now. This is how we can say that a person can work for many companies, which a company can employ multiple people. Again, we need to write some configuration code. It is akin to configuring multiple one-to-many relationships. We just need to add a collection of company person to both classes. Long-term creation of a junction table class will not be necessary unless you need to carry additional information besides the keys for the related table. This is how we specify that a company can have multiple people. We also noticed that we use virtual keyword for all the navigation or relationship-based properties that point to related data. This is to enable lazy loading feature in Entity Framework. It allows us to load related data on demand when a property is accessed. Although this is a powerful feature, use it with caution to avoid performance issues related to executing too many queries. Finally, we need to add context, a database abstraction. We add a property per table type where a property type is dbSet. Then we override onModel executing our configuration code, one table at a time. Migrations are part of Entity Framework used to create code to roll the database schema forward. This action is performed during upgrades. First of all, we need to add a connection string to appsettings.json file that in this case points to local SQL Server with a database called Contact Manager. Now in startup, we need to read our configuration from appsettings.json into memory and create our configuration object. Then we just need to configure Entity Framework at the startup of our app. We need to enable Entity Framework. We want to use SQL Server, and we want to add our context using the predefined connection string. Now we're ready to create our first migration. First of all, we need to add a migration. In order to do that, we use ef command and subcommand migrations. We want to tell it we want to add a new one. We're going to call it initial migration and store it in project called contactmanager.data. This is what we need to type in our application project folder. We must configure connection string first and perform some basic application level configuration. This creates our first migration. Finally, we can execute migrations in our development environment to create our database. Let's do this. All we need to do is use ef command again and subcommand database and update. We can hit enter to create our database. We can verify that it is created by using SQL Server Management Studio. And if we refresh our database, we see that our database and all the tables were created. We have other classes in our model, such as phone, to demonstrate another example of one-to-many relationship. We're at the end. In this video, we have created our data access layer and executed migrations to create our database. In the next video, we're going to learn how to create our controllers to retrieve and persist data via Entity Framework in our Web Services API. In the previous video, we'll learn how to create and configure Entity Framework classes to persist the data in the database and to retrieve it. In this video, we're going to take a look at creating web services that operates on that data. In order to separate the concerns between controllers and data, we will use business object. In order to cut down the amount of code we need to write, we will use AutoMapper. We will create a controller with CRUD operations. If we think about our application code and data access code, we will notice that there is a mismatch between the classes. Entity Framework classes in most cases contain more data than we need on the screen. Even in the simplest use case, person type, the problem is apparent. We do not need, in our use case, to show people that belong to a type when editing a type. As a result, we're going to create corresponding business objects for our person type. It is a similar class, but it has better error messages and less data. We are using data annotation attributes to implement validation and corresponding error messages. Person class has a little bit more validation. You notice that we use new data annotation that performs checks on a range of values. Since we separated business objects from data, it is apparent that we need to do a lot of typing to move the data between business objects and data entity. To solve this problem, we will use a third-party library called AutoMapper. We can just add AutoMapper support library to our project.json. Then we need to teach AutoMapper what classes we need to move data between. We will add a new class to our project called ContactMapper that we put this code into. It implements iSupport startup interface. We will pull all the implementation of this interface during our application initialization and call each one to perform various initialization tasks. As you can see in this example, we just need to specify a source and a destination for each map, which creates mapping between model and corresponding business object. We can create bidirectional maps by calling reverse map method. We are ready to start on our controller. Controllers are at the heart of Web API. We will use Entity Framework context, we'll create CRUD methods, and we'll talk about error handling. We're going to create a new class, and we're going to inherit from a controller class in order to obtain a number of useful methods. We're going to specify route as well. Keyword controller in the route will tell API to map the controller to the route that contains a class name without the actual word controller, in our case, person types. Now we need to inject the database context. This is how we do it. We could use either controller or property injection. We're going with property injection in this case. The attribute from services will tell MVC to get an instance of the context from the services collection we configured at startup and put it into property called context when our controller is created. There is something important I would like to mention. If we want more separation between controllers and data, we could implement yet another pattern, such as repository pattern. We're not going to do so in this video course for the sake of brevity only. Here's how getAll method looks like. We explicitly specify that it is invoked to correspondence with HTTP verb get issued at the route that the controller specified. Since the action or method specific route is blank, the methods in the controller are called action. This method is flagged as async. We're going to use all async methods in order to scale our application better and be more consistent. We're using link again or language integrated query to query our context as if we were querying the database. This is where power of Entity Framework truly shines, as we convert plain C# code into T-SQL database language. We're using iActionResult to return the values that simply represent an HTTP response. Let's add another method to get just one person type by ID. We are specifying parameter name in the route using squiggly brackets. Again, we see similar code, including even automapper call. This call converts the database entity into business object. Again, we see link in action using first or default method. We're also checking for a valid ID, returning not found HTTP response indicating that ID passed in is not valid. Let's look at the insert method. We see a new attribute that tells the framework that the data for this method comes from the body of the HTTP request. Then we check the model for validity. The model is actual parameter called person type of type person type. Model is valid when the rules that we specified as attributes in person type business object are satisfied. We follow HTTP REST conventions when returning errors or created data using helpful methods in the base controller class, such as created or HTTP bad request. The code in the update method is quite similar. It does have its own verb though, HTTP put. We see a new call here to DB context called update to put submitted data into modified state, including all the dependencies. The bad request uses model state, which contains all the validation errors. The error messages will end up in the body of the response in this case. Finally, let's look at the delete code. Instead of querying the data, we just create an object from thin air, giving it just an ID. This code is far more efficient than code that queries the database, then marks retrieved objects for deletion. We set the state of the object to delete it, to let Entity Framework know what needs to happen when we save, more specifically when we call save changes async. You probably find this code quite intuitive and easy to follow. In case of person controller, we could use something called projections. returning partial person object defined by person info class. This is one more example of differences between data and business object. We do not need to return entire person object to show just first and last name. Again, putting this code into repository instead of controller would provide a bit more separation between layers in our application. To an extent, however, DB context itself is a repository, providing an abstraction on top of our database. Great deal. That finishes this video. We have created business objects and used them to expose data in our Web API controller. In the next video, we will configure the entry point in our application and try out our new controller. Hi, and welcome to Configure Application Startup video. In the previous video, we'll learn how to create Web API controllers that handle our data. In this video, we're going to learn how to perform application startup tasks. We will configure dependency injection for our application. We are going to initialize all the components in our app, such as AutoMapper. Finally, we will test what we have accomplished thus far by exercising our Web API service in a utility called Postman. MVC Core comes with a built-in dependency injection container. It does, however, miss some features that more mature containers have that make our lives a little easier. We're going to swap out the DI container with the one called structure map. You can, of course, use one of many other containers. Structure map has features such as assembly scanning and setting up DI based on conventions. Let's update our application startup code to configure structure map. First of all, we need to add structure map to the reference list of libraries in our project.json. Now let's take a look at the code in our startup project that we added to configure services. First of all, we're configuring our context class by feeding it SQL provider and a connection string. This connects local default instance of SQL Server designated by period that we see in application settings.json file. Then we are returning a root container that we create right here instead of void as we did before. We are creating structure map container. We are scanning current assembly for injection points using default conventions. We're also adding all objects that implement iSupport startup objects. One of those objects, of course, is the AutoMapper configuration class we created in the previous section. We're also adding global settings file. In order to use settings, we need to add a couple more projects to our project.json. We need to add configuration extensions as well as JSON configuration files. These packages provide helper functions to load configuration files in JSON format into a dictionary of settings in memory that we see right here, implementing an interface called iConfigurationRoot. Now we need to actually execute startup code. We can add IIS support at the startup. Right now we only have one such class that uses startup, iSupport startup. Right now we only have one iSupport startup class, but potentially we can have more. We'll run through all of them, calling each one to perform any startup test such as initialize AutoMapper. Now in the next step we're executing database migrations for Entity Framework. Finally, we enabling static files and MVC and potentially any other services down the road. Now we are ready to try our code. First of all, we need to start up our HTTP server by executing the web command that we see in project.json. To do so, we need to flip to the command line again and run the web command. Just type dnx web to execute the web command, which will start up HTTP server on port 5000. There are many tools that we could use to run web requests. We're going to use a tool called Postman, but you could use Fiddler or any other tool. Let's flip to Postman and let's run the get command in a Postman. Type in on the URL 5000/API, which is prefixed to our route, and portion type, if you remember. We send it, and here's our result. It's an array, and it has right now one portion type called friend. Let's post a new request to the person types controller called person type. We're going to use post request, and in the body we have a brand new type with the name of block. Post will create a new entity. Let's execute it. If we look at the response, we see that a person type ID2 was created with a type name block. Now let's update this type using a put request. We put the familiar person type ID into the put, and we want to change type to another. This returns nothing, and if we go back and execute our get request again, we see that the type2 name is now other. Finally, let's execute delete request. In this case, we post in delete request, and the parameter is 2, so we can click send. Again, this returns nothing, and let's go back and fire get again, and as you can see, person type ID2 is now gone. We can also test our error handling by requesting an unknown type. This ID does not exist, and as we can see, it returns nobody and status 404 not found. Awesome! In this video, we configured our application startup and tested our API controller. This is also the end of the section. In this section, we have learned how to create web services that handle data. We learned at a high level that what Web API or MVC controller does. We understood the functions that Entity Framework Provider provides for data handling and database structure management. We created new EF classes to process some data and configure them to properly create the database. We wrote our first Web API controller with CRUD operations: create, read, update, and delete. We configured our application startup code and configured it, and tested all the moving parts of our controller in the Postman. Congratulations! Our web services are complete. In the next section, we will concentrate on creating a fully functional Angular 2 component that calls our web services and displays the retrieved data. Hello, and welcome to section 6, Authoring Angular Components. In the previous section, we saw how to create Web API web services with Entity Framework to supply data to our Angular 2 application. In this section, we will create an injectable service that will use HTTP to obtain that server data. We will add a component using an HTML template and a TypeScript class that uses the service and displays the data. We will then create a directive that alters the DOM. Finally, we will construct a pipe that formats the data. We will run the code and observe the results of our labor. Now, we're moving on to the first video of this section that deals with the creation of a service. We need to get the data from our service to show in our client application. We want to isolate the server communication at the same time. Let's create an injectable component responsible for exposing the server data to the rest of the application. In this video, we're going to take a look at how to set up our application to use Angular HTTP2 functionality. We will see how RxJS observables are used to expose the data. We will proceed to create our new service. We will use getHTTP verb in our call to obtain server data. Let's get started. In the previous section, we saw that we need to add Angular and related scripts to our HTML host page. We use this system config file since we use system.js module loader to do so. HTTP related functionality is contained within its own module and within its own script, and we are including it as one of the packages in our system.js configuration. In the same shell page that we use to inject this configuration in, we also created a JavaScript object and added it to the Windows object. This is the common way to inject server-side variables into JavaScript. Now we need to create a small configuration component that exposes configuration to the rest of the application to isolate the use of Windows global object just to a single page. This gives us some flexibility in managing settings. So let's do that. So we're going to add a new TypeScript file, and we're going to call it simply configuration. And let's find TypeScript, and we're going to call it configuration. First thing we need to do is import an injectable. Import injectable from, we're importing it from Angular core module. So we type @angular/core. This will import the necessary injectable attribute or a decorator. Now we're just simply creating a class called configuration. And we will decorate it with an injectable attribute. This attribute lets Angular know that we'll need to have this class injected into other components. And this is how we use an injectable decorator. Now let's define an interface. Make use of what we learned in TypeScript section, and we're going to create an interface called iConfig. And it will have a single property in it, the same one that we define in our layout CS/HTML called root URL. So let's do that. So we will declare a single property of type string. And in our configuration class, we will add a property as well called config of type iConfig. Now we just need to populate it, and we'll do that in the constructor of our class. And we'll simply have to say this.config equal to the same code that we injected in layout CS/HTML, which is window my Angular app.config. This will generate an error because Angular TypeScript does not know what that window object has a property called my Angular app. So we take advantage of another feature that we learned in TypeScript section, which is casting. And we're going to cast window to any in order to be able to compile our application. Now let's create our service. So we will create a new folder, and we're going to call it contact types. And in contact types folder, we will add all the functionality related to types of context that we're going to have. And now we're going to add a new file there, and we're going to call it context type service. So let's go ahead and add a new file. I'm going to call it context type service.ts. And here what we need to do is import some HTTP related functionality. So let's go ahead and do that. We imported the same injectable attribute. We imported this configuration that we created previously from configuration file. Then we imported an HTTP service and a response object. And finally, we're importing subject, which we'll go over in just a few minutes, from our RxJS module. Now our service returns certain data. So let's go ahead and create a definition for this data. We're going to call folder models, and we're going to create a single file. We're going to call it models.d.ts, and we use the definition style coding .d.ts extension because we're not going to have a compilable functionality here because interfaces don't contain any executable code. And we're going to declare a new module, and we're going to call it app.models. And we're going to export just a single interface out of it, and we're going to call it iPersonType to correspond with the same C# class we defined earlier. And the properties again are going to correspond to the same properties that we defined for our type person file, which will have person type ID as a one property, as a second one type name, which is a string. As you can see, it's very familiar TypeScript code. Now we need to write the rest of the code. Now let's import the model that we created. Remember, a different use of our import keyword is to import the information that we declare in one module into another module. And in this case, it simply saves us a little bit of typing. Now we need to declare our class, and we're going to call it context type service to kind of correspond with our file name. Again, we want this class to be injectable into other components. So we're going to use an injectable decorator. Now we need to declare an event that are going to fire whenever our context types are retrieved from the server. And here we'll make use of subject class from RxJS, which is a way to expose events from within a class. Now we need to inject some data. We're going to declare a constructor, and as you will see, anytime we want to inject something into one component from another, we inject them via constructor. In this case, we want to inject configuration, which is another class that we just wrote that we imported in. And we also want to inject HTTP component, which is of type HTTP. And we make use of inline property declarations using private keyword because we don't want those exposed to the rest of the system. And now we'll write a method that gets all of our data from our web API by making a call to HTTP. And we will use get method. And now we need to construct the URL, which is our root URL. Plus, if you recall, that we expose our data using API prefix, and then person types URL or URL fragment, which is where our data is located. This returns observable from RxJS. Observable essentially is an object that exposes events and data over some period of time. It allows us to query and manipulate events and subscribe and publish them. Once we notify our RxJS that our data is here, we can process the data inside the subscribe function and return the data to a subscribing component. How do we process the data? Let's write a method that processes the response of our data. It's simply, we're going to call it handle response, and it contains a single object called response, which is an abstraction on top of HTTP response. And then we will push this data through our event emitter or subject class to whomever is listening to this event. Now, we simply need to pass in handle response. We also need to handle errors. So we're going to create another method called handle errors, and let's write that method right quick. We will start with the name, which is handle errors, and this is going to be a function that returns nothing, so it would be of type void, and it contains a single parameter, and we're going to call it errors, and it's of type any, as it is declared in the subscribe function. Now that we declared the function, we just need to put some basic code for now, and for now we're just going to say alert, so we will see the error in the UI, and we're just going to display status text from HTTP response object. Awesome. I think we're done, and now we're ready to proceed to use this service inside another component. In this video, we created a service, an injectable service that uses HTTP to get the server data from our web API and expose it to the rest of the application in a generic way via subject, which emits events with our data. In the next video, we will create an Angular 2 component that uses this service to get the data and display it to the user. In the previous video, we created a service that exposes server data to the rest of the application. In this video, we will create components that show this data to the user by consuming our service. In this video, we're going to take a look at creating a component and plugging it into our shell. We will inject our data service into it and use it inside the component. We will learn how to initialize components and how to nest them to keep components from getting excessively large. Let's get started. We saw in our overview that a component is just a TypeScript class that has a component decorator attached to it. Let's create one now that shows person types a list to that user. We will call it contact type list. We will add a file called contact type list, and of course it's going to be a TypeScript file. We need to import our component decorator just like we did in previous examples. Component. And of course, we need to import it from the Angular core module, which is where the core components are located. Now we can just declare a new class. We're going to call it contact type list, and it's just a plain class. And now we can add a component decorator to it. And we need to add some properties to that decorator. In this case, we just need a selector for now. And we declare it just like before. And to keep our data logical, we are going to call it contact types, which is going to be essentially our HTML tag. In general, it is a best practice to use 2 or more words as tag names in order to avoid potential conflicts with standard and even future HTML tag names. Now that we know the tag, we can add it to our new module. We're going to call it contact type module. Again, we're going to add a new file. We're going to call it contact types module. And just like before, it's going to be a class. And we're going to call it contact types module. Just like this. And now all we need to do is import ng module in order to use that ng module decorator. And all we need to do now is decorate our class with ng module. And again, we'll put a bunch of properties on right now. In order to save time, I pasted this code in. As you can see, we are importing contact type list from our file that we just created. We are also adding this component to the declarations in our ng module, and at the same time we're also exporting it for use in other modules. As you will also notice, we added common module to our imports as well as HTTP module. Common module contains some of the core Angular directives such as ngIf and typically needs to be imported into every component. Since we're also going to use HTTP, we will import this module as well. We're also seeing a little error that says that I cannot find contact type list. This is actually a pretty typical error if you forget to export your class from the file in which it is declared. Now this error will go away. Now that we're done with that, we need to add our new module to our root module or the app module. We'll do that by importing this module in a similar fashion as we imported other ones. And what we're going to do is import contact type module, and we'll just copy the name. And we just need to give it a relative path, which is going to be contact types / contact types module. And now that we imported that module, we just need to add it to the list of modules and a list of declarations inside our imports. And we'll just do just that. And now we're ready to add our new component to our application UI. In this case, we have a template here, and we're going to change this template, and we're going to add our new component. And if you remember, we called the tag name contact-types. So we simply need to add contact-type to our user interface. And now we finished plugging in our new contact type list into the root module, which will cause it to show up in the user interface. Now let's get back to our module, to our contact type list component, and finish plugging in the service into that component. Let's start with the module. Before we do anything else, to use contact type service inside our contact type module, we have to add it to the list of services. In this list is called providers, if you recall, and because contact type service is using the configuration component, or configuration service more specifically, we gotta add both of them to the list of providers, which makes it available to all the components declared inside this module. In this case, right now, we only have one component. Now that we're done plugging that in, we can get back to the actual contact type list. Since we know we're going to need a service, we need to import that service into our component. Let's do that. And now we can use this contact type service inside our contact type list component. We need to import that, which we have done. You also notice the pattern of importing dependencies by now. Our custom dependencies are imported by relative path. Now we need to add this contact type service into the constructor of our component because we use constructor injection. So we will simply need to add a constructor, and we need to add contact type service of type contact type service. We're going to change the name here, and because we're going to need to use it inside the component, we use the shortcut for the property, for private properties, adding the private keyword here. Now we can subscribe to its events. In order to subscribe to its events, we need to import RxJS module, which has a class called subscription. Now we can create subscription in our constructor, and this is quite easy to do. First of all, we need to declare a variable that will hold the subscription, and now we just need to create the subscription by saying this.sub would be this.contact type service dot contact types, which is our subject or an event source, and we can call subscribe method on it, and we're gonna give it a method that will process the data. So let's write this method. Method essentially is quite easy, and all it needs to do is populate the list of contact types that our service will return. In order to do that, of course, first we need to declare the property that will hold our contact types inside our components. And we're going to call it contact type. And it will be of type, if you recall, the model that we declared. Now we can write the process data class method, process data method. Let me paste it in right quick. If you recall, the contact types emits the data, which is an array of iPerson type, and all we need to do is simply populate contact types property inside this method. If you can take a look, that we see slightly different syntax for declaring this method because the events are invoked in the context of window object, meaning that if we don't use this syntax, then this is going to be window object, and of course nothing is going to work. Because it returns an array, of course we need to declare our property as an array of contact type. Now let's keep moving. Let's add some code for initialization. What we need to do is import onInit from the core. onInit is an interface that allows Angular to know that our component needs some kind of initialization before being used. And in order to do that, we just simply need to implement onInit interface in our class, which contains just one method called ng-onInit. All this method does for us, it invokes our service in order to get the batch of our data. One of the core ideas of Angular components is to keep them small, build in a tree of them, then each one is responsible for one small part of the app. In this case, let's add a child component that will show just a single person type to the user. Its tag name, say it's going to be contact type item. Let's go ahead and add a template to our contact type list item component. We are using something we have not seen before in this HTML, or ng4 directive. ng4 is a structural directive used to operate on collections or arrays. In our case, it iterates over lists of types, creating a new component that will be based on a lie tag, but in this case creates a contact type item component inside the UL tag. We see another new syntax, square brackets around contact type, which has a value assigned to it, and a value is declared in ng4, which is a local variable that follows that keyword called item. So we're assigning item to contact type property. This is how we manage inputs and outputs inside Angular components. The child component that we're going to build, called contact type item, will have a property on it, or an input more precisely, called contact type. Let's build this child component. Let's take a look at this child component that we wrote. The class name is contact type list type. The template itself is very simple. It's just a button and a span element. We'll work on classes later. So it's just a button, uses some of default bootstrap styles, and it has a span element that contains contact type name using just string interpolation binding. Now if we look at the class itself, we see a new decorator called input that we also imported from core. The input signifies to Angular that this property decorated with this input decorator is going to be populated from a parent component in some way. In our case, by passing a contact type item to it. Because we know it's a full contact type item, we declare this specific property with the appropriate, using the appropriate model interface. In the code inside our list directive, this variable is declared inside ng4. We're also adding a quick method to our component just to verify that everything is working okay. And as you can see, there is a new syntax right here. It's an event binding syntax we saw earlier. And because there are no additional directives, it is simply a click event of the DOM element, and it is bound to a clicked function that takes in our contact type. We could also do simply clicked event without the parameter just as easily. And inside the method, we're simply doing an alert in order to verify that everything is working right. So we could really remove the parameter because we don't really need it, since we know what the contact type is as well. And in this case, we can simply add this. So this is just an alternative way to pass in the information. Okay, great. In this video, we have created nested components. We created one of them to use a service we created previously to obtain the data. And the other one we created that would accept data from the parent component. In the next video, we will create an attribute directive to alter user experience when it comes to how data is displayed. In the previous video, we looked at creating small components to display the data. In this video, we're going to take a look at how to manipulate DOM via directives. We're going to start by looking at the goal of the attribute directives. We are going to create a new directive. We're going to manipulate DOM inside the directive and also respond to DOM events for further manipulation of the user interface. There are three types of directives that exist in Angular. There are components that we are now familiar with, and they are an example of a directive. There are also structural directives that manipulate existing DOM to a very large degree. In the previous video, we saw one example of such a directive as ng4. And finally, there are attribute directives that are designed to sit close to DOM and manipulate it or enhance it in some small ways. Here's an example of a structural directive that we're going to build. We're going to enhance our list of contact types with an individual element that shows the person type displays larger when a mouse is moved over it and also changes its font to some color. Let's get started. Let's create a folder where we put our directives. And it's going to be a new folder, and since this directive may be used in other places, we're going to call it the folder common directive. Then we're going to add a new file, and we're going to call it make large, which is going to be our directive name. What we need to do, first of all, is import the necessary attributes. And we're going to import them as usual from Angular core module. And what we need to do is, actually, let me rename this file right quick, because I didn't give it TypeScript extension, didn't get any IntelliSense. And what we're going to import from Angular core is, first of all, directive attribute, which is a new attribute we have not used before. We also gonna need to manipulate DOM, and there is a element ref class that is designed to be an HTML element abstraction. And there is also a renderer, which is an abstraction up top of CSS at a high level. And what that will allow us to do is manipulate things like styles on elements. Now, what we need to do is create the class next. And we're going to create a class, we're going to export it, and to keep classes consistent, we're going to call it make large. And for now, what we need to do is decorate it with the directive decorator. And it's going to have a handful of properties because component decorator extends directive decorator. We will find very similar properties in it, such as selector. And in this case, the selector is going to be make large, is what we're going to call it. We could also follow different patterns and call it with a dash. It's really up to the user. The selector, the important thing to notice about selector is the brackets, which will tell Angular that in this case, it is an attribute directive, and it will expect to find it as an attribute on top of another HTML element. Now we need to add a constructor where we're going to take an injectable. So we're going to add a constructor method, and the injectables that we need are the same ones that we import. So we're going to import element ref and of type element ref, and we simply just change the letter to small e to keep with best practices. And we're going to add another private variable called renderer, and this is going to be of type renderer. And this is the code we already have seen a number of times, the typical constructor injected. Now we need to move on and see how we can set an element color to blue. To follow this goal, first of all, we need to subscribe to some DOM events in order to know when the mouse is moved over our element. Here's what the syntax for those events look like. We're going to add another property here. We're going to call it host. Host property tells the attribute directive that it needs to look at the host element, meaning the HTML element that the directive is attached to. We see DOM directives just as event names surrounded by parentheses. As you notice, they have the exact same names as DOM element names. What that means that any DOM element event in Angular 2 could be subscribed to by simply adding an event and the event listener, which in our case is just two functions. One is called make larger and the other one called make normal, which means we're going to change the font or the appearance of the element when the mouse enters or leaves the element. Now we need to add the directive to the component. It's just an attribute as we saw before. So what we do, we copy the name. We're going to add it to contact type list item, and we simply add it as an attribute. Right now the attribute has no value. The other thing we need to do is add this directive to our module under declarations. All the components and the directives are essentially declarations inside our module. Now we need to import it, and it's going to be imported from a relative folder, which means we need to go up a level, then to common directives folder, and finally make large is our file name, and our class is called make large. This is the final step that will allow us to use this directive inside other modules. Now let's get back to directive itself and fill in the methods. The methods are make larger and make normal. So we're just going to copy those method names. We could also be explicit and say they don't return anything. And our second method is called make normal. Now what do we want to do? First of all, we want to make the font larger and also change the style. So let's start by setting the font size. In order to do that, we will simply use the renderer. And we're going to say this.renderer. And what we want to do is set the element style. And you can see, you can also set the class or attribute. Tells you that this is you can think of it as a sort of a jQuery-like class that allows us to manipulate DOM in an abstract way. In this case, we're going to set the element style. The style that we want to set it on would be our host element, which is represented by element ref. The style name that we want to set would be the font size. And this is just a plain DOM style. And we're going to change it to be 200% of what it initially was. And this is how we set the style. Now we want to reverse that. We're simply going to set it to, in this case, undefined. in order to set it to previous value. The next thing we want to do is change the color. And what you will notice that the code is quite similar, except the CSS property name that we want would be a color, and we want to set it to blue. On mouse over there. And again, we're going to reverse the change by setting it to the original color, thus resetting the style. Now what we want to do is kind of run this code and see if it works. So let's do that. So let's navigate to our site called on port 5000, and as we can see, our previous contact type list item component, now we can see that it works just fine because we can see a list of 3 types coming from our database. Now if we move mouse over the button, we can see that its color changes to blue, and as we move out, the font and the color changes to the previous value. That's a good step. Directives also support properties with the same input property on the decorator as we saw with person type component earlier. This is how we could pass data from the component in which host element exists down to the directive. Let's see how we can add a custom color to our directive. Let's switch back to our make large file, and we're going to add an input to it called make large. Now we need to add a property to match that input. We also call it make large. So this is the alternative syntax to the one we saw previously, which was add input decorator. We could do it either way. So just to show different ways to accomplish the same task, we're going to do it via a specific input property on a directive. This input could be really anything, but we keep it as a property name because it'll make it much easier to maintain this code. Now we need to add a value when we use make large. And in this case, we're going to add a value, and we're going to call it red. And we should observe the color change from red to blue. Now, what we need to do is use that color inside our code. So let's go ahead and replace our methods with the ones that use the color. And as you can see, the code is essentially the same, except when make large is populated via this input, I'm going to use this color. Otherwise, I'm going to change the color to blue. Let's see this in action. What we're going to do is refresh this page to pick up the changes we just made. And if everything went right, the color should change to red. And this is how we add additional input properties to our directives. Let's switch back to our code. What we noticed when we ran it is the fact that the button is not getting bigger. We can fix that with a custom CSS stuff. Where do we put this stuff? We could add a global style sheet somewhere. However, if only one place is affected, we could add this style onto the component definition itself. This could be an inline style as a string, or we could set the style URL. Just like we could use an inline template URL. So let's add a styles property to our contact type list item, to the decorator. So let's pull up contact type list item, and what styles is just another property, as we mentioned before. And of course it can contain as many styles as you want. In my case, I only have one. I'm editing a button with a label, and I need to just add it to the button itself. And what that allows me to do is inherit the font size. I'm also setting some margin here as well, on a list group item, which is the class of the entire item. Now I should be able to refresh the page and see if everything is working as expected. So let's refresh the page again. And we can see that only button is now getting bigger. So let's flip back to the code. And the mistake that we made is that we put the directive itself on to just the button, not the entire element, which is a li element. What that demonstrates is that we have some flexibility where the directives go and how they're used. So let's refresh this page again, and now we can see that the button is getting bigger and as well as the actual text. So we're making some progress. Now the only thing that isn't working is the font color on the button. So let's fix that as well. So what we also need to do is inherit the color on the button, which by default does not have. So let's add the inherit of the color, flip back to our page, refresh it again, and now what we try to do has been achieved. So the color changes to a custom color, as well as the font in the entire element. This is great. This is great. We have created in this video an attribute directive that manipulates DOM, responds to DOM events, and can even accept data via inputs. That's a great thing. In the next video, we will talk about pipes, constructs in Angular that allow us to manipulate the data on the way from our components into HTML-based user interface. Hi, and welcome to Create Pipe video. In the previous video, we learned how to build a custom directive. In this video, we are going to take a look at how to format the data from our JSON objects differently than just displaying them as is. Pipes serve this exact purpose. We'll look at how pipes are used, the different types of pipes used in Angular, then the built-in pipes, and then finally we'll see how to write a custom pipe. Many technologies, such as WPF or Windows Forms, support a way to format the data differently in user interface. Angular 1 supported this as well via formatters and filters features. In Angular 2, this feature is called pipes. Pipes has a single method that allows us to receive some data, change it, and then return the updated data. Angular 2 comes with two kinds of pipes. Number one is pure function. These are functions that take a parameter, which is a piece of data we want to transform. They also take any number of additional arguments that can customize the transform. These functions are expected to execute synchronously, returning the transformed value. The other type is asynchronous pipe. They take the same parameters but can return a transformed value eventually instead of synchronously, maybe after a promise or a service they call is resolved. A promise is a method that eventually produces a value, and it is now part of JavaScript specifications. To create such pipe, we just need to set pure property of the pipe decorator to false to indicate an asynchronous pipe. When a synchronous pipe completes its work, the value it returns is automatically put into the user interface. This gives us an ability to even make server-side calls to transform the data. We're not limited to just adding a single pipe to our data value. Pipes can be parameterized by adding the parameters to the pipe name following a colon. We can also chain pipes, passing a value transformed by one pipe to the next pipe, and so on. Here's an example of a code that uses pipes. You can see the vertical pipe symbol. Let's take a look at built-in Angular 2 pipes. Currency pipe is used to format a numeric value with the appropriate currency symbol such as $sign. JSON pipe shows JSON string for an object that is being formatted by it. Percent pipe shows decimal value as a percent. Slice pipe extracts a subset of an array based on start and length parameter. Date pipe formats a date based on format string, either custom or predefined. Lower and uppercase pipes do what name describes, converting string to lower or uppercase. Decimal pipe and number pipe show decimal and numeric value based on format specified. Async pipe subscribes to an observable or a promise and displays the last value returned or resolved. In our case, let's create a custom pipe. The use case will be to shorten a string value based on specified number of characters, appending ellipses in their place. Let's create a folder in which we're going to put our pipes. So we're gonna create a new folder. We're going to call it Common Pipes. And now let's create a new pipe. And of course, as usual, it's going to be a TypeScript file. And we're going to call it shorten because that's what our pipe does. It shortens a certain value. First thing we have to do is import the necessary decorator. And again, as a majority of other core components, they come from Angular core module. And this is the module that we're going to use. And in this case, what we need to import is pipe as well as pipe transform. Pipe transform is actually the interface. Now we're going to create a class and we're going to call it shorten. And what the class will do is implement pipe transform. And what we need to do next is decorate our class with a pipe attribute to let Angular know what our class supposed to do, which is serve as a pipe. And in this case, we only need to add one thing, which is the pipe name, which will be resolved as we use the pipe. What we need to do is put word shorten into our HTML, and the Angular will find and create the appropriate pipe. So now we need to implement the single method that pipe transform calls for, which we can hit F12 and take a look at this method. It's really just a single method that takes single parameter, any arguments which are the arguments to the pipe, and it'll return a single value. In this case, I'm going to use the maximum size. If I have any parameters or arguments in this case, I'm going to assume that the first one is the maximum size, and then I'm going to check to see if the value is not null or undefined, and if it's longer than the maximum size, then I'm just simply gonna use the substring to shorten it and add the ellipses to it. Otherwise, I simply return the value. Now it's time to use this in the HTML. Let's say we're going to use that in contact type list item component. And say we want to use it inside our span that displays type name. So as I mentioned, we need to use the type pipe name and then any parameters. In this case, we're going to use number 3 to display only the first 3 characters. Now we need to teach Angular that this pipe is part of one of our modules. since we're using it in contact type module, we have to import that into our module. And we're going to import our shortened pipe, which is our class name, from, in this case, a relative path would be up the directory, then common pipes, and finally shorten, which is the name of our file. The error should go away in a second because it'll recognize the new parameter, and then we have to add it to the declarations. As you notice, declaration consists of all type of components we use in this module. In this case, some are actually Angular components, some are directives, and some are pipes. And then now we're ready to give it a try. So let's flip to the browser and see if our code works as expected. Let's refresh our page. And as you can see, the name of the type got shortened to 3 characters, meaning that our pipe worked as expected. Good work! In this video, we'll learn how we can transform the data as part of data binding on the way to user interface. Well, this covers the entire section. In this section, we created an injectable service that uses HTTP to get the server data. We created components with HTML templates and TypeScript classes that use the service and display the data. We created a custom directive that alters DOM and handles DOM events. We constructed a pipe that formats the data on the way to the user interface. In the next section, we will learn how to navigate from one form to another as part of our Angular 2 application. Hi, and welcome to section 7, Navigation. In the previous section, we created a fully functional Angular 2 component that calls our web services and displays the data. In this section, we're going to study client-side routing with Angular 2. We will create plain and nested routes. We will configure our application for route usage. We will learn how to navigate using routing directives and encode. Now we move on to the first video of this section that deals with the basics of client-side routing. Before we jump into the routing and navigation, we need to understand the basics of the client-side navigation as well as load necessary scripts. In this video, we're going to take a look at how client-side navigation differs from server-side. We will load router script. We will also configure server to handle deep linking into our client application. Browsers understand internet addresses a user types into browser address bar. In a server-side driven web application, in response to a new address, the browser makes a server request retrieving the targeted HTML, CSS, and JavaScript that corresponds to the requested address. In a client-side heavy application, such as Angular application, the client-side JavaScript code handles navigation events and address bar changes, showing the appropriate view without full-page server-side request. This often results in a better user experience because there is no full post back and refresh, which could be a jarring experience for the user. We already are loading a router package from Angular. If we take a look at config.js for our system.js package manager, we will find that a router package name or module is already loaded. Because we will use menus from Twitter Bootstrap, we will also modify our shell page to also load Bootstrap CSS. In addition to that, we will load the Bootstrap JavaScript files as well. Of course, you don't have to use Bootstrap, but whatever menu controls you're using, include them as needed. We also need to set up a base URL location, which is necessary for supporting Angular 2 routing. We're using ASP.NET Core feature where represents the root of our web application. This would be required if we're using, say, virtual directories. Base is required when we use routes free of hashbang or #, which is what we're going to use. If you need to support really older browsers, you would need to resort to use #hashbang navigation. What is important for us to know that in Angular world, Angular 2 router service is responsible for updating browser address bar as the user navigates around the application and for loading appropriate views and components. Even though this is a client-side navigation, URLs are a key part of the navigation, and each unique URL is linked to an Angular component, such as the one we wrote in the previous section. URLs and components together form Angular routes. What happens when a user navigates to a URL shown in the browser address bar? In an application that relies on server-side navigation, we expect the server to serve up the page for the requested URL. In Angular 2 application, we must take care of preserving the URL for the client-side process while asking the server to return a shell page even though non-root URL was requested. In other words, we somehow need to redirect all requests to our shell page, since this is the only server-side page our server renders fully. In ASP.NET Core, we need to add a catch-all MVC route. We can do that in the startup CS file. We still need our default route that maps controller and actions to URL, and we need that for the shell page. If we request, for example, localhost 5000 contact types, we want our server to return exact same shell page that exists at localhost 5000 or at the root, because this request means that someone clicked on a full link in an email or a document or just simply typed it into address bar. Our second route, deep linking route, will catch all requests not explicitly mapped by our first route or our default route that handles the shell page, accomplishing the task of serving up our root shell page. Awesome! That's it for this video. We have learned how client-side navigation is different from server-side. We loaded requested script into our shell page and redirected all of the addresses to the shell page, thus supporting deep linking in our application. In the next video, we will configure our routes, linking components to URLs. In the previous video, we learned the basics of client-side routing. In this video, we're going to define routes that will allow users to navigate between portions of our application. We're going to start by defining minimal viable simple routes. We're going to add routes to our components via modules. We will look at lifecycle hooks that can help us inject code into the route resolution. What is a route definition? In simplest terms, a route is defined by two properties together combined into a class called route. A path or a URL is a string, the path for a specific area of the application. An example would be path where a user can configure contact types or contacts. The path uniquely identifies the route. We also need a component responsible for handling the route. We will simply use the component type. For example, a contact type list. As a result, we will have a route that uniquely identifies the area. There are other route properties in the route definition, such as an ability to pass data or redirect to another route. And here's an example of a route. Here's the class that defines the route in Angular 2. You can see a lot of properties here besides the two that we described. We can, for example, redirect to another route. We can have child routes. We can define route instantiation data that will be passed to the component along with the route. We can define routes for any part of the application by converting them into modules and importing them into our startup application. We do so by defining routes collection that is identified by the routes class, which is simply a collection of the route. Now let's work through an example. So we will start by creating a new file for the entire application, and I'm going to simply call it routes. Routes.ts to be specific, because routes are also TypeScript files. Now I need to import a couple of modules that are necessary to define the routes. In this case, I'm going to import routes class as well as the router module class. Now I can define a constant because it doesn't really change, and these are going to be our application routes, which is an array of routes. And inside there we'll simply use object literal, and we can actually hit Control Space in Studio to invoke IntelliSense. And in this case, I'm going to define an about route, and it's going to be handled by a component called about. And I pre-created this component, so let's take a quick look. There is nothing fancy about it, same old component class with a decorator that defines a selector and a template. Right now it doesn't have any other data in it. So let's define one more, which I also pre-created, and this is going to be our home page, and path is going to be whatever we really want it to be, such as home, and then a component that will handle it is going to be a home page component. And this really defines the areas of our application, in this case just a couple of areas. Now we need to convert our routes collection into the module that we can export out of our application. And we're going to export this as a constant as well, again because it doesn't really change. And we're going to call it app module routes. And the type that we're going to import it as is module with provider. And here's where router module comes into place. We can call router module for root in this case and pass in our routes. And this will create our module. Now we can import this routes module into our application module. All we need to do is simply define it and import it there. So let's open up our app module. What we need to do is import one more thing. This time around we need to import our app module. So we're going to import from the class that we just defined, the file we just defined, which is called routes. And what we're going to import is app module routes. And now we simply need to include it in the imports collection. This way our app module is now going to be aware of the routes that we define that this app module can now handle. Good work. Now let's talk about lifecycle interfaces. Lifecycle hooks enable us to inject code into route resolution process. There are two hooks that we need to be aware of. One is can activate, and the other one is called can deactivate. Can deactivate hook fires before a user navigates from the current route to a new one. The navigation system in Angular 2 will ask currently displayed or active component if it can be safely deactivated by calling the canDeactivate method. The system expects either a Boolean or a promise or an observable that resolves to a Boolean to be returned from this method. This is a very handy hook if we want to, for example, check for any pending changes that could be lost if a user navigates away from the component. CanActivate is the opposite hook. It can ask a component if it can be safely activated. Unlike canDeactivate, canActivate is not a generic interface. Both of these interfaces could be implemented in a separate class, not necessarily in a component that we're trying to control. Now let's implement this interface in one of our components. First of all, we need to import the interfaces. We're going to implement canDeactivate and canActivate interfaces in a single class called contactActivator. First of all, we need to import all the interfaces as well as the injectable attributes that we're gonna need to use here in a minute. Now we're ready to write our class. So we're going to export a new class called contactActivator. And now we just need to implement the interfaces. It's going to implement both canActivate, which is not generic, and canDeactivate, which is of type contact list, because this is going to be our example. Both interfaces just have a single method. So let's start with canActivate implementation. So it's going to be canActivate method, and it's going to take a couple of parameters. It's going to take the activated route snapshot and the current state, which is route state snapshot. And in our case, we're just going to return a Boolean instead of a promise, which will satisfy the implementation. Now for now, we're just simply going to return true, and just to verify that everything is working okay, we're going to add some console.log statements, and we're going to say that canActivate was called. And we're going to take similar approach to canDeactivate, and just going to copy and just change a couple of things here. canDeactivate, on the other hand, because it's a generic type, it actually takes a component as a parameter, and the component type is going to be the same generic parameter. And then it takes the other two parameters are actually the same. So let's copy those in, and then we're going to say that canDeactivate was called. Now we need to hook up this contactActivator into our route definition. And if you haven't noticed, I actually created a new module for experimenting with routes in order to observe how we can navigate from one part of the system to another. So we start with contact types module. This is context module. And if we look at its definition, you see that we are importing contactActivator into provider collection. One thing we need to remember to do is to decorate the class with an injectable attribute. So we add in our activator to provider collection, but we also need to add it to the routes to tell the route infrastructure that we want to use activator and deactivator. In this case, in each route definition, in this case we only have one called contacts, that is handled by contacts component. We're saying that we're going to use canActivate implementation from contactActivator, and the same with canDeactivate. And because we're using context component, not really contact list component, let's go ahead and make this quick change right here. And that kind of concludes our activate and deactivate implementation. As I mentioned before, both can be implemented in any class, essentially are created as its own class, and they don't necessarily have to return Boolean. You can also return promise, which means you can make, for an example, HTTP call with some kind of a route information. We are using activated route snapshot class in here. It is used for each of the two parameters that we saw. While we're on the topic of documentation, it is seamlessly integrated with all TypeScript editor, including Visual Studio. In this case, I can hit F12 and go and take a look at what a route looks like. And route activated snapshot is very similar to a route and contains kind of similar information. In the next video, we will look at nested routes and see how we can pass parameters to components as part of navigation. In the previous video, we learned how to configure basic routes in the routes collection via module. In this video, we're going to take a look at organizing routes using child routes. We will pass and retrieve parameters as part of route definition and as query strings. In the previous example, we put all our routes for app module into a single routes collection. Although we could certainly continue to do this, this approach will result in hard to maintain code with many pages of configuration once we get beyond a handful of routes. Here's how we can organize routes into groups. As we saw before, we can group them into module, which is one level of organization. On top of that, we can organize routes further by adding them to children collection of an individual route, creating a tree of routes. Then we can import those mini module route trees into our root module. You notice that one of our child routes ended with a colon ID. This is how we define routes with predefined parameters. In our case, ID would be the parameter that a route expects. Colon in a route definition simply denotes a parameter. It is going to be absent from the actual URL in the browser address bar. Now that we define route with a parameter, as we see here, we need to learn how to retrieve this parameter when our component that expects this parameter, in this case contact type edit component, is activated. Let's take a look at this code. First of all, we need to import a class called activated route, because this class is what exposes route parameters to the component. Then we need to inject this class into our constructor, and dependency injection will inject the proper activated route that corresponds to this component. We don't want to access the data in the route in the constructor. The idea is that we want to keep the constructor free of side effects, which we'll add in testing. Instead, we're going to use onInit interface with the corresponding method ng-onInit to get the parameter value. The way we do it, we have to subscribe to activated route observable collection of params. Technically, it's not really a collection, but an object. And the class is called params. If we go to this class definition, you will see that it's simply a dictionary, or in more simple JavaScript terms, is an object literal. Once we subscribe to it using our XJS subscription, we can retrieve the ID using ID as the key. And the reason we use this ID as the key is because when we define contact type route, we specify that the name of our parameter is ID. So we retrieve this ID from the dictionary. after which we can simply call the service to get a single individual contact type using the ID that was passed in from the route. If we look at address bar as we navigate to it, we will see that the URL to contact type ID is simply the actual ID. So let's see. So I'm navigated to contact types, and I'm going to contact type edit class, which is we just saw by clicking on the edit button. And if I look at the URL, the $ID parameter is replaced with the actual parameter value, which is 2 in our case. We just saw how we can get a known parameter defined in a route. However, Angular 2 has flexibility to consume arbitrary data in this params object of the activated route. We can also pass arbitrary data as well. We're going to dive a little bit deeper into navigation in the next video, but for now, let's just explore how we can pass dynamic parameters into an object. Let's take a look, for example, at the home page, and we navigate to about component in the about route by passing in simply an object literal with 2 properties, where ID is 1 and there is something called more data, which is a string. Let's run our app and see how that's represented in the browser. We'll navigate back. We're going to go to home page and move to about page. And our object literal got parsed into ID value type query string, where each ID is separated by semicolon. And again, you see semicolon in front of the actual URL that defines our about page route. We also see the parameters that are exposed here on this page as simply JSON object. Let's take a look and see how it's done. We're going to open the about page, and again we see similar code that we just saw in contact type, edit component. We inject activated route, and again on the init we subscribe to the value. And in this case we're also capturing the subscription into a private variable, and in the onDestroy we dispose of it. We'll cover onDestroy in just a minute, but let's concentrate on what we do right now. We simply grab the entire params object and save it into a property on our component. And what we saw, this JSON object, we simply use string interpolation here, so we can quickly look at what was passed in as a route. As a result, we can use completely dynamic routing, pass in a parameter, and we can enumerate all those key value pairs inside our params object once we get it. And this technique is useful when parameters are complex objects and receiving components may not know about their shape in advance. Great! In this video we'll learn how to use parameters and query strings, define child routes in order to provide a better organization for all of our client-side routing. In the next video we will round out our knowledge by learning how we can navigate from one part of our application to another using both code and router directives. Hello, and welcome to Navigate with Directives and in Code video. In the previous video, we'll learn how to pass parameters to components and create child routes. In this video, we're going to take a look at how to navigate to a predefined route via built-in directives and in code, and learn where the views are placed. We will see how to handle missing routes. Finally, we will discuss additional components lifecycle hook called onDestroy. Let's get started. As we define our components that are linked to our routes, it was not obvious where the view associated with the component is displayed. This is defined by a directive included in the router module called router outlet directive. To define it, we just need to place this router outlet tag somewhere in the component templates. In this case, we're looking at the outer shell templates, our app.ts, and we're going to place this router outlet directive inside the container fluid, which is just a bootstrap flag, just below the menu defined by this nav tag. Let's walk at the high level what happens when a component such as app component is displayed. Once a route component is located that matches the route definition that corresponds to a URL, the target component is created, then its template is compiled, and then the final view is put under this route outlet tag that is located inside our view inside our app. Of course, we're not limited to a single router outlet. Child components can have their own outlets. For example, if we look at contact types, which is the root component for contact type module, in its template all we see is the router outlet, which essentially is just a placeholder for all contact type areas route. This can continue on and on, building sort of a tree of nested routes or child routes with our own outlets. The simplest possible way to navigate to a route is to use router link directive. Here's an example inside our menu structure. In our case, we have two routes, contact types and contacts. We define them as using just a simple menu structure provided by Bootstrap, and the anchor tag is decorated with a router link directive, and its value should be matching the route definition. So if we look at contact types, for example, when we define contact type routes, we will see the match. So the path is contact types in this case, and this is what we type in into our router link directive. Let's see this in action. When we click on contact types link, our URL changes to contact types, meaning that router link directive triggered a chain of event that caused the navigation to the route that we specified in our router link directive. Sometimes it's hard to navigate using router link directive, especially when we want to pass some kind of dynamic parameter to it. Router link, of course, does support parameters, and those could even be bound to a component whose template contains this router link. In our example, when a user clicks on contact type edit button, we want to display the details of selected contact type. In order to do so, we need to define detail component first and associate it with the route. We already saw this code when we looked at passing the route parameters inside ng on init. In this case, we simply subscribe to route parameters from the activated route. Then we obtain the ID, which is our parameter, and finally we call our service to get an instance of contact type. How do we pass that parameter, however, from the list component? If we take a look at contact type list, we will see more specifically contact type list item, which is our child component. We will see how we can manually navigate in code. In this case, we need to inject the router class, not the activated route, because all the navigation is done through the router class. Then, as the edit button is clicked, invoking our click method, we simply call the navigate method, and essentially we pass in the same thing as we did before, simply the path that is defined in our route. Any parameters we simply append to that path, creating the final URL. Sometimes we make a mistake and the address we want to navigate to really does not exist, or the user may have typed in the wrong address. If we were to write server-side navigation app, that would return 404 in response to a request to an undefined page. We want to simulate the same behavior in the client-side navigation to provide a clean user experience. This is where wildcard route comes in. In this case, we want to define a new component that's going to handle our wildcard routes. And let's call it page not found component. Let's go ahead and create it. So we're going to add a new file and we're going to call it page not found.ts. And in our case, it's really a very simple component with the same kind of imports that we had before. Now we can simply define a class, and we're going to simply call it page not found. To save some time, let me go ahead and paste in the definition, since this class is quite simple. And all we want to do is simply show the details of the missing route that our page not found is supposed to handle. Again, we see that we injected activated route. Then we simply subscribe to our parameters and we set in a value that's called just simply missing route property to our param class. And we're going to call JSON to stringify to create a string that we're going to display. And if we look at this page, the only thing we're going to see is that we navigated to page not found component, and we want to see what kind of route data led to this missing component. Now the critical part we still have to do is define that our page not found component is supposed to handle missing routes. We're going to open our routes definition for the entire application, and we're going to add one more path to it. This time we're going to use the wildcard in order to signify that any route that falls through is going to be handled by our component. And the only thing we need to do is simply import the definition of our page not found we just created. As a result, as the path in the URL is being compared to each route, eventually there won't be any matches, and then our wildcard will match because that's all we have specified in here. So we already saw how to run this app. So let's run it one more time and test our wildcard routes. To do that, we're going to take a look at our home page. And as we can see, we simply navigate when an invalid button is clicked. Right here, move to invalid page button. We want to navigate to a route that does not exist. And if everything works okay, we should see the details of what was passed in, which would be our component with a value, to our page not found page. So let's run that and see if that works. So as we navigate to our home page and then navigate to try to run our app, we see an error that says component page not found is not part of any module. And this is a pretty common error that some people make, including me, where we simply forget to include a component inside the module. So let's correct this error. We're going to open up our app module and we're simply going to add the same page to the list of the imports, to the list of declarations that is included in that module. Let's try to run it one more time. This time, as you can see, our page loaded successfully, and we're going to click on a button that navigates to invalid route. As we can see that our page not found was intercepted the request because that was our wildcard route, and we even have access to additional route data that we can also see in our URL. Good. So now we know how to simulate 404 status code inside our client-side application. We already saw the usefulness on init interface. Angular 2 provides an opposite interface as well called onDestroy. It can be used to perform any necessary cleanup task when a component is removed from the router outlet because the new component becomes the target of the same outlet. Well, let's take a look at the class that implements onDestroy. In this case, we're looking at contact type list component. And what it does, it subscribes to the services event that tells the consuming component that the data has arrived from HTTP call. As a result, we simply define a subscription inside our component, and being a good citizen, we want to clean up this subscription when a component is destroyed. To do that, we import onDestroy interface, and we make our class implement this onDestroy interface. And there is only one method that is part of this onDestroy, and the method is called ng-onDestroy. And inside this method, all we do is unsubscribe from the subscription. You can perform any other cleanup tasks, of course. Primary reason would be we want to avoid memory leaks, for example, and in those cases we want to clean up all of our subscriptions. Good work! In this video, we learned how to navigate around our application both via directives and in code and display the results in router outlets. We also discussed wildcard routes and learned how to clean up our code using onDestroy event. In this section, we'll learn how to navigate in our application with the client-side routes. We configure routes, handle parameters, and navigate it in code and via router link directives. In the next section, we will discuss how to handle user input with Angular 2 forms. Hello, and welcome to section 8. In the previous section, we saw how to navigate between areas of our application. In this section, we will learn how to collect user input with Angular forms. We will create new forms and use data binding to expose controls data to Angular components. We will use simple validation and write complex forms with control groups. We will monitor changes inside components and provide feedback to our user. Now it's time to move on to the first video of this section, which lays out groundwork for building forms. How do we create forms that collect user input and provide validation? Angular makes this process quite easy while providing the tools for controlling user input and dynamic validation with proper error messages. In this video, we're going to take a look at the typical HTML structure of an Angular form. We will see functionality of ng form directive and control submit functionality. At the end of the day, Angular forms enhance the built-in browser functionality related to collecting and validating user input. Typically, we will enhance HTML tag form with additional functionality to make the processing or validating and submitting user input easier. Here's the typical form structure. We have the form tag, then we use some Bootstrap CSS framework classes to format labels and controls. We have the actual input tag to collect the type name and a button to submit the data to the server. There are two form types that Angular 2 supports. Template-driven forms, which is an example that we just saw above, allow us to bind our data models directly to HTML-based form by using ng-model directive. They're quite similar in their structure to Angular 1 form. Reactive forms give us more control over the form creation, allowing us to create form structure in code inside our component instead of driving it through the template. This approach gives us more power flexibility at the expense of writing a bit more code. Of course, we can use both approaches in the same project, as we are going to do in this section. ng-form directive helps us create template-driven forms. We will cover this approach first. ng-form represents our form structure and consists of individual controls or control groups, each group consisting of one or more controls. This allows us to build a reasonable logical structure that represents HTML controls to collect user input. The next step to start using ng-form directive inside our component template. Let's take a look at that. As you can see, we start by capturing ng-form directive inside of type form variable. We simply use # and a variable name and assign ng-form to it. Capitalization of ng-form is important. We need to match the spelling of the class. We will see camel casing of directives over and over again, starting by small ng in most cases. We also see no validate attribute that helps us to suppress native browser form validation, since we're going to be using Angular validation for this purpose instead. ng-form directive exposes a lot of useful functionality. It gives us an ability to create forms from controls and submit a form. One of more useful things in it is also property of type form group, which inherits from abstract control. In addition to other functionality, ng-form group and ng-model group allow us to, for example, know if a form or any controls within it are valid or dirty, meaning that they have pending changes made by the user. ng-model directive represents a form, an individual form control and its data. In this code, we use ng-model in a single input control and capture it into a local variable called type name. We'll take advantage of the functionality of capturing ng-model into a local variable to support a user validation and validation feedback. We also set the ID field to enable accessibility better. However, Angular itself does not need IDs. As far as form submittal goes, we can do it in a number of ways. We can add a button of type submit and bind its click event to a save method in our component. Alternatively, we can simply add the save method to ng-submit method on the ng-form, and all we need to do is simply add ng-submit event binding and call exact same save method. It is a matter of personal preference which approach you use. Keep in mind we just don't want to use both at the same time to avoid calling our save method twice. In this course, for the most part, we will stick to explicit click events on buttons instead of using ng-submit. All those methods call save method of our component. So let's take a look to see how it is wired up with the web API or web services functionality we wrote earlier, as well as our service, contact type service that controls communication with the server. Here's the save method. In it, we simply check to see if person type ID is 0, meaning that it was a brand new type that we just created, versus the one that we retrieve from the server. This allows us to know if it's a new, if we need to call insert or update. We could alternatively pass the entire form instance into this class, into this save method, However, because we use data binding, we don't really need to do that because we bind the form to an instance of our person type model, and it is always available inside our component with the values updated through user input. Okay, cool. In this video, we saw how to set up a simple template-driven form to control user input in Angular using ngForm directive. In the next video, we will take a look at data binding in our forms. See you next time. Hello, welcome back. In the previous video, we looked at the structure of the Angular form and ngForm directive behind it. When we used to use jQuery, we often found ourselves writing code to move the data between HTML and the models in JavaScript. We will learn now how to use Angular's data binding features to solve this problem. In this video, we're going to take a look at the two-way data binding between our HTML-based views and TypeScript or JavaScript models. We will use ngModel directive to accomplish this task. We will take a look at the common issue with data binding that can cause exceptions. We will also take a look at how we can supplement data binding with control events. Data binding is arguably one of the most important features in Angular or any other MV Star framework out there. This feature cuts down on very large amount of boilerplate code. Data binding, once in place, continuously monitors both sides of the specified binding, view and the model. As a result of our model changes, the data flows into UI and back to the model. In the Angular world, ngModel is the directive that we use to declare our data binding intents. For example, let's take a look how we could bind a property on our person type model's name property with a corresponding input control. The binding keeps the two, view and the model, always in sync. Two-way data binding is one of the binding options and enabled by default. Hence, we use the specific syntax to turn it on. It is definitely needed when either components or user can change the data, and we need bidirectional data flow. The binding syntax with parentheses inside square brackets signifies the data flow. Parentheses are used for event binding. In this case, an event is a user interaction with an input control. Brackets are used for attribute binding, and an attribute in this case is the value from the underlying model, specifically contact type.typename in this case. Let's now take a look at some actual running code. In our case, in case of specifically contact type entry screen, our model is identical to our C# model that is exposed by the server-side web service. TypeScript models need to match this specific class because they have one-to-one relationship. For example, our person type model in TypeScript looks essentially identical with the exception of us using camel casing for type names, which would be the default for Web API transmitting of data from the server to the client. You might ask why we create models as interfaces and not classes, as we do in C# or Java, for example. The answer is that classes are not part. The answer is that classes are part of generated JavaScript, whereas interfaces are not. So we achieve virtually the same functionality, but with a lighter memory footprint. Now that we have our model figured out, we can start working on contact type entry script. Because we're going to use forms, we need to add the module import to our contact types module. And we import form modules from Angular form namespace, and we need to add it to the list of imports. Now, let's implement a simple use case for our new button. We want to create a new instance of our person type model if we navigate to contact type edit screen without specifying an existing contact type by simply saying, hey, I want to create a new contact type. We're going to do this work inside ng on init method and not the constructor for the reasons we specified earlier, which is testing. If we look at the parameter, in this case, it's going to be an ID parameter, which is specified by our route definition for contact type edit. And if ID is 0, now we're going to create a new instance of object literal that matches iPersonType definition. So it has two properties, ID and the name. Now, as we process this data, we assign it to contact type property. And if we look at this property definition, its type is iPersonType interface, or the interface we just looked at that matches person type server-side object. We're going to do data binding to this property inside our HTML code in model template. It is a plain old JavaScript object, if you notice, even though we use TypeScript, but when all said and done, it's plain old JavaScript object or project. This is very critical point that makes our lives in Angular as developers easier, because we don't have to create some custom objects as we have to do in other frameworks in order to support data binding. The process data method simply sets this property. Process data is also called when we get an existing contact type by calling a service. When all said and done, no matter how we navigate to the screen, all we care about that we have a property populated with a person type instance that a user can edit. If we take a look at the template, we will see what we just saw in the slide. We use an ng model syntax and we bind into type name property of the contact type property exposed by our component. To complete the picture, we also want to implement functionality that navigates to contact type edit from the list via a new button. If we take a look at contact type list, we see that we added this new button that calls a method called new contact type. Now we see our routing in action here as well. We navigate to the same contact types route, and we specify that our parameter would be a 0, which will trigger our code to create a new contact type. Let's try to run this code. If we simply refresh it, we will see a list of contact type, and the new easily navigates to it, and we can see our input screen and our save button. If we select the edit, however, we get an error. And the error says, cannot read property type name of null. This is caused by the Angular binding system. It must have an instance of an object when binding to a property. This is done in order to help us troubleshoot hard to find errors when we, for example, mistype a property name or an object name. Because we have to call a service to update an instance, we're running into a race condition when our screen is processed before data is loaded into contact type property. The fix is simple. We need to add conditional processing to exclude our form from being processed until data exists. We accomplish that with a directive called ngIf. This relies on another functionality that is exposed in common module, which we do import. We will take a closer look at ngIf directive later, but for now, let's fix the issue. The ngIf directive would have to start with asterisk, and again it's following the same ng prefix we saw elsewhere. And what we need to bind it to is simply property contact type to specify the condition. In this case, we rely on the fact that JavaScript if statement can work with any object, not just Boolean object, to define if it returns true or false. So in this case, we want to exclude this form from DOM until contact type is populated. If we flip back to our screen and we go back to contact type and click edit this time around, we see that the error went away, but not only that, we know that our data binding also worked because we see type name input control populate. Sometimes we need to supplement our two-way data binding by subscribing to DOM events. An example would be when we want to use a control that is not native to Angular and we need to handle certain data binding use cases ourselves. We saw earlier how to create event binding. In this specific case, all DOM events are supported automatically by simply specifying the event name and a function to be invoked in response to a DOM event. $event is an Angular keyword that tells it to pass the original event argument from the DOM event into the event handler. For example, here's how we can subscribe to focus lost event or blur on the input control type text. And here's how handler would look. TypeScript comes preloaded with DOM event argument types. So we simply need to pick a correct event type, in this case, a focus event. We should only use DOM event subscription when absolutely necessary, trying to stick to plain event data binding as much as possible. In this video, we'll look at two-way data binding accomplished with ng model directive. We saw how to avoid common exception with data binding and how to supplement two-way data binding with DOM event binding. In the next video, we will add validation and validation error messages to our forms. See you then! Welcome back. In the previous video, we'll learn how to bind our models to the user interface. We need to ensure that the information a user submits via forms is valid, however. When a user enters invalid information, we want to present the user with feedback pertinent to correcting their mistakes. We also want to keep the user from submitting invalid information to the server. In this video, we're going to take a look at how we can ensure the user fills in minimum required fields. We want to learn how to conditionally show proper error messages. We want to make sure user cannot accidentally click on submit button prior to correcting the mistakes. User input validation is a necessary feature of any application. At a minimum, we want to achieve two goals. We want to keep invalid data from being persisted to the server. We want to provide user with visual cues to allow him or her to fix the mistakes as quickly as easily as possible. For example, if we know upfront that certain fields are required for an entry to be valid, there is no reason for us to round trip to the server to inform the user of this fact. Ideally, we would have validation on both server and the client. Server validation, of course, is a must, but client-side validation enhances user experience. We enforce server-side validation in our web API, and we already know how to do so via data annotations. Now let's see how we can incorporate required validation into our Angular forms. Angular comes with some validation out of the box, integrated with HTML. One such validation is required fields validation. We can activate this validation by simply using the required attribute, and all we need to do is add this attribute to our input control. Angular will automatically find this attribute and add the appropriate Angular validator to the control instance tied to the model to the control validated with this attribute. How do we tell the user that the error is present? We need to add a div with the appropriate error message. And we can do so by putting it right under the input control itself. Let's go ahead and add that. And all we need to do is simply generate an error message that is appropriate. In our case, we're gonna display type name is invalid message. However, we want to show this message only when a field is not filled in our case, a required field. We do so with a built-in hidden attribute that, if you recall, for any attribute binding, we need to enclose in square bracket. We leverage, in this case, native hidden HTML attribute. However, we turn it on based on a conditional expression. In our case, it's a type name.valid. If you recall what type name is a local variable that captures ng model that we tie to this input control. The ng model has one of the properties which is a valid property. And we want to hide it when this valid property is true. This will show our hide error message as appropriate. So let's save our changes and run our code. We just pulled up a contact type, a random one in the edit screen. As soon as we start deleting it, and we delete the entire contact type name, you see the type name is invalid error message came up, which means our code is working. Now we want to disable the save button as well when the data on the form is not valid. This could be accomplished by getting ngForm directive to give us the form instance that has the same valid property, except it applies to the entire form. Let's take a look at that. We're already capturing ngForm into the typeform variable. And now all we need to do is leverage built-in, again, disable attribute, and this time we're binding it to typeform form, which is the form group, and valid property, which will essentially interrogate all the controls inside that group and ask each one if it's valid. And if they all are valid, then form.valid is going to be true. In this case, we're simply negating that value and binding it to disable. Let's see this in action. You can see the button is enabled, but as soon as we delete it, we no longer can click on it. Finally, if we have a lengthy form, we may want to add the overall error message for the entire form. And all that should tell the user is that there is some data that is invalid on the form and needs to be corrected. We leverage exact same data binding, except we bind it to a hidden attribute on our overall form div. If we refresh our page and test that code, you can see that the overall form error message now works. And as soon as we start typing, both error messages disappear. By default, validation on input of type text in Angular 2 occurs after every keystroke. As a result, error messages immediately disappear as soon as we type in a single character. Another simple validation is maximum length validation, which is something else we want to accomplish with type name field. Before we do that, let's test our server-side validation. All we need to do is add max length directive, and we set it to 30 characters, which is our length. Before we do that, let's actually test without it. So all we need to do is type a really long name and click save. And as you can see, server-side message comes up telling us that we did something wrong. Let's see how we accomplish this task. In this case, we're putting the message into the service itself because it's just an alert dialog. Alternatively, we could propagate that handle error to our component and let component do that. What we do in the handle error function, we simply parse out the error message sent by Web API based on the format that we know exists. And if you have another format for your own custom error messages, you're free to do so as well, which signifies the fact that we still need to handle validation on the server. Now let's add max length validation. Max length validation is tied to built-in HTML max length attribute. If we refresh that and we try to type more than 30, browser itself will stop us from doing so. No validation, of course, will be shown in this case. The third simple validation that comes with Angular 2 is min length validation. For example, we want to make sure that the type name is no shorter than 3 characters. All we need to do is add min length and refresh our page for testing. And if we type just 2 characters, you see that the error message comes up. Both min and max lengths are applicable to alphanumeric input field. Congratulations! In this video, we'll learn how to provide simple validation and show appropriate error messages, as well as disable save button with Angular forms based on templates. In the next video, we will learn about building complex forms with reactive forms approach. Hello! In the previous video, we learned how to create simple forms with validation and error messages. We also saw how we can control submit button when data is invalid. Although we saw we could make forms work without configuration by using forms and ngModel directive, we need to handle more complex use cases with custom validation. Forms based on form groups could be constructed in code, giving developers a lot more control over the forms and validation. This approach is referred to as reactive forms. In this video, we will create forms based on form groups configured in code. We will add multiple validation error messages per single input field. We will create custom validators, both synchronous and asynchronous. We already saw that a typical form will consist of input controls, each one handled by ngModel class. Let's see how we can build a more complex form with the help of Form Builder. Form group, which is created by Form Builder, is an abstraction on top of the form consisting of individual form controls, each one representing a single input field. Let's get started. In order to use reactive forms, we need to add few imports to our specific contact module, in this case, where we're going to work on contact entry script. To do that, we simply need to import import forms and reactive forms module from Angular Forms, and then we need to add both modules to the list of imports, thus making them available in our contact module. Now that that part is done, we can start on contact edit component, and first thing we need to do is import Form Builder. Form Builder is located in Angular Forms module as well, and we can simply inject it into the constructor just like we do with all other injectables. We also need to store the form group, which is an abstraction as I mentioned, on top of a number of controls, into a property so we can bind to it in the user interface. We're going to call this group person form. Now we need to create this person form. We're going to do it in ng-oninit method. And I pre-typed it because it's a lot of typing. And this is how we do it. We simply call a group method and pass in a dictionary, or another term would be an object literal, in which each property name is the key, which will be mapped to a control instance. In other words, when we specify first name key, that tells form builder to create a form control and map it to a property called first name. The value of the property is an array that can have three parameters. The first one is the initial value for the form control. In our case, it's mostly null. Second value is the validator. And the third one is an asynchronous validator. Multiple validators could be passed in by using validators.compose method, which reduces an array of validators to a single validator that we could be passing in into our form control instance. To be sure, Form Builder simply provides a cleaner API on top of creating form groups in code simply using form control constructor, and then adding each form control manually to a form group. This could result in a fair amount of code, hence Form Builder is a simplified API we could use for the sole purpose of reducing the amount of code we have to type. Let's look at the individual field. For example, a first name field. We set a initial value of null, and the two validators that we passed in are the same ones that we define in our API, making sure that the first name cannot be left blank, and at the same time making sure it cannot be any longer than 30 characters long. In the next step, we need to bind our control group stored in person4 property to the form tag. In order to find this HTML, let's take a quick look here. And in this case, we want to use template URL instead of an inline template because, as you notice, our class is already quite long and we want to reduce the amount of code per file. So let's open contact edit. Unlike in the previous example where we use ngForm, in this case we use form group directive. And we're binding the form group via form group attribute to an instance of person form. If we flip back, just a reminder, person form is the property on our component, which is automatically bound to the UI. In the next step, we need to configure each individual control. The difference from the previous instance is that we use form control name directive to bind a form control located inside our form group to a specific input control. In this case, it's a select input control. If we scroll down to first name, this is just a standard text input control. And we tell it that the form control name we want to use is called first name, which will automatically map to this first name property inside our form group. Now, let's add our two validation error messages to our first name input control. If we take a look at the HTML that we use virtually the same ngIf that we used in the previous example, except in this case, we want to use another property of form control, and this property is called has error. The only parameter that it takes is the name of the validator. In this case, we have two validators required and max length. Has we no longer need to use ngModel directive, incidentally, to bind control itself to the first name property of the contact property that we also have inside contact edit. We're going to keep this contact here nonetheless because we will save it by passing it into a service down the road. If we write a custom validator, we still need to pass in the key in order to mark it with a specific name known to Angular. We know that Angular 2 comes with some pre-built validators, such as required min lengths and max lengths. In our sample project, we want to make sure that a user selects at least single type of a person when entering the content. If we want to know how validator is expected to work, before we write this validator that can validate any select control to make sure the value is selected, let's take a look at required validator for our example. In order to do so, we can use the feature of TypeScript that allows us to go to any definition. In Visual Studio, we hit F12. And as we can see, the signature for required validators is quite simple. It takes a single parameter of type abstract control or form control, which inherits from abstract control, and it returns a single value, key mapped to a Boolean. The key itself is simply the name of the validator that we can pass into our hasError function. For our drop-down validator, we simply want to know if a value is greater than 0, because in our project we use auto number field in a database that will start with 1. That would cover contact type table as well. So let's take a look at the common validator. We write in a method with the same signature as the required validator, as you could see. Its method is simply called drop-down valid, and if you recall, instead of abstract control, we use form control, which inherits from abstract control. And we want to return, the key part we want to return is the key, which is the name of our validator. In here, we do quite simple code. We simply ask our control for the current value using .value property. All values are string, so we're going to parse them into a decimal-based number, and then we're going to check to see if it's a greater than 0. If it is, we return undefined. Undefined is what's going to tell Angular 2 that our validator decided that the value passed in is correct or valid. Otherwise, we need to return the key for our validator, and this one I'm going to call drop-down valid. The value itself is not as significant. In this case, I'm passing a Boolean based on the signature that we just saw. Interestingly enough, data annotation in ASP.NET Core use similar scheme, where lack of errors is represented by lack of the return value, but the presence of error is indicated by the specific error object where the key is the name of the validator. Now we can look at HTML, and as we can see, our code makes more sense now. We use hasError method just like we did for first name, except we're passing in drop-down valid as the parameter, and that will automatically return the last value that was returned by our drop-down validator. This is quite useful technique when the data is all present on the client. What if we want to ask a server to see if the value entered by the user is valid? This is where asynchronous validators come in. It has exact same value as a synchronous one, except it needs to be wrapped, in our case, in a promise. What is a promise? We haven't talked about it yet. A promise simply represents a result of an asynchronous execution, and it has a number of methods you can see here. Let's write a validator that checks for duplicate last name for a content. In order to do so, we need to compare current last name against the database, excluding, of course, the current contact ID. We immediately see that this validator needs a state to store current person ID. We also need to pass in a service to make HTTP calls. Let's take a look how we can do that. We're going to write it into the same class, common validators, and the function is called lastNameExists. Again, the parameter is the same. It's a form control. However, instead of returning an object literal, we return the promise of the same object literal, where key again is going to be the name of our validator. The code itself just delegates everything to the service call. That, again, I wrote already. And what we do, we create the promise, and then we call the HTTP. Using Angular HTTP, we make a call to our API controller that checks for duplicate. We pass in a last name plus the ID. This call returns true or false, simply speaking. Then, once the call is returned, we check to see if it's true. And as you can see, when we resolve our promise, which is of the key boolean, we return the dupe, which is going to be our validator, is what it's going to return. And then its value is going to be true or false. And just like we did before, we resolve the promise to undefined if our web service call returned true. Now let's take a look how we can use this validator. If we take a look at contact edit, we inject this validator. It becomes our third parameter to the last name form control array. First name, as a reminder, is the value, which is null. Second parameter is synchronous validator. And finally, third parameter is our async validator, which in a sense is this function. Form level validation in case of reactive forms is quite similar to the one we used before in template-driven forms. We refer to it in our form group, and it has the same or similar in a sense property called valid. So in this case, we disable submit button by checking form group property valid. And this is how we do reactive forms. Sometimes we may have screens where users enter tabular data into a list using an array of objects. In this case, we can use a form array. A form array is the class that consists of an array of form controls. We would create form array using the same form builder class, but array method. Form array name is the directive that is placed into HTML, which signals Angular that all the subsequent HTML contains, say, within the div flagged with form array name, that the data contained to it is contained within a form array. Each item is a form array. In a form array is a form group, represented data entry block for a single item inside form array. You could think of it as, say, a spreadsheet where each row is the form group and the overall spreadsheet is the form array. In each cell, you will have a single form control that is contained within a rows form array. In order to bind each individual form group, we would use form group name directive, and its value is going to be an index of a specific entity inside the form array. And this is how form array names its arrays, its items within an array. This type of user interface is not common, so we're not spending much time on that. Both form array and form group take an additional parameter. They are synchronous and asynchronous validators, except instead of them being applied to an individual form control, they could be applied to the entire form group or form array. Congratulations! In this video, we'll learn how to use Form Builder to create more precise and complex forms, exercising more control over the entire process of data entry into forms. We learn how to write custom synchronous and asynchronous validators. In the next video, we will learn how to monitor the changes from the components and show notifications, informing user that an asynchronous process has completed. Hi, and welcome to section 9, Built-in Angular Building Block. In the previous section, we saw how to handle user input with Angular forms. In this section, we will become more acquainted with a number of building blocks included in Angular 2. We will discuss dynamic styling via classes and styles. We will talk in details about displaying lists of data. We will then see how we can suppress the display of elements based on various conditions. We will talk about options for change detection. Finally, we will discuss dynamic content in our application. Now, we move on to the first video of this section that deals with dynamic styling of our user interfaces. In this video, we will take a look at how we can assign one or more CSS classes to an element based on various conditions. Then we will learn how to use dotted syntax to assign an individual class. We will continue with dynamically assigning multiple style properties. Finally, we will learn about dotted syntax for styles as well. First of all, we need to define our CSS styles. CSS or cascading style sheets allow us to apply various effects to our HTML. We will not use CSS preprocessor in this video, such as sass or lets. Instead, we will use inline classes. Classes defining components, of course, are scoped to that component and not global to our application. In our component, we need to create some inline CSS styles or external styles, as well as global style sheets. Let's stick to inline styles for this demo. We will add a couple of simple effects to our contact edit page. For example, we want to change the border for our person type drop-down based on a person type selected. Let's add some styles. In order to add inline style, we simply need to edit the component, and we need to add an additional attribute to our component decorator. We could use styles URLs and point to a different style sheet, or we could use an inline style, which is an array of strings. In this case, all we need to do is simply use ticks, so we could use multi-line styles, just make our life a little easier, and we define CSS classes just like we would in a CSS file. So we write pretty familiar code. In this case, let's say for a friend, we're going to change border color, border dash color to blue. Well, I'm going to save some time and simply paste in some of the classes we pre-typed in advance. And in this case, we're going to add a handful. We're going to add friend, or which is blue, not friend, which is the default. And later we will try to color birthday date. In order to assign a style, we need to trigger it off some kind of a property in our component, or a function for that matter. Previous examples, we stuck to properties. Let's define a function in this case as our bindable data in our component. And we'll create this friend function. And all we want to do is simply verify that our component was properly bound, so it does have a contact instance. And then we're going to look at our form's person type ID, specifically at the value. And we kind of preloaded friend contact type with a value of 1. So at this point, we have something to bind our classes to. Now we need to bind a specific style inside our HTML, more specifically inside our select control for our person type ID. ng class is an attribute directive that we're going to use for this purpose. We assign it to an object literal. So because it's a directive, we remember we need to put the attribute directive inside our square brackets. And as always, we're assigning a string to it. In this case, it is an object literal that contains a key, which is a class name, and a value, which is something that needs to evaluate to a true or a false. Because we already have double quotes in here, we're going to add our names inside a single quote, and it's going to be bound to this isFriend function that we just wrote. Of course, we're not limited in this case to a single style. So in this case, well, let's add one more, and we're going to use our other style that we defined just a second ago called notFriend. And as we noticed before, because we can bind to function, we're also can bind to any valid expression, JavaScript expression. In this case, I'm going to negate function called isFriend and assign this specific style, not friend style, based on negating this function. The value of, in general, the value is simply a condition that needs to evaluate to some valid value. In this case, not necessarily true or false, because remember, the if statement in JavaScript is not limited to a Boolean value. So we can evaluate, for example, an object, and any object will evaluate to true, whereas null or undefined would evaluate to false. Same goes for strings. In our case, as I mentioned, isFriend function always evaluates to true or a false. Now let's run this code and see, based on our style and isFriend value, see if our styles are picked up. And if you remember, a friend style would be blue, and all other styles, all other person types would evaluate to a default kind of gray color. So I have my contact screen now pulled up, and I'm going to change the type to friend. And as we can see, our background changed to blue. The value takes effect immediately, which means the data binding on select type control fires as soon as the value is changed. If we only need to care about a single style, not the entire class, Angular 2 gives us a shortcut for such cases. Say we want to apply birthdate class, which we saw just a second ago, to our birthdate input control from a previous example on the edit page. All we need to do is open up our HTML, find our birthdate control, which is right here, And now we again would use ng class directive. However, inside the bracket, we will use the keyword class followed by a period and then the class name. In this case, our class name is called birthday. And we can actually copy it and paste it in to avoid any potential mistakes. Again, we follow by equal sign and the quotes. And again, this could be any valid Angular expression. In our case, we will simply use a constant. And to signify constant, we need to put it inside single quotes, which will evaluate immediately, just like any Angular expression. CSS styles could be applied to individual properties in CSS, specifically on a single element. Say we want to make certain that certain last names appear in bold because they're special to us in some way. Here's how we are going to use the new ng style directive, which differs from class, where we don't assign the entire group of styles or a class, but want to set a single CSS style property. Let's add that to our, say, last name, for example. We want to say when the last names are equal to Jones, we want to display it in bold. So what we want to do is come up to our last name and add the ng style directive to it. Let's see where our last name is, right here. And we're going to add it inside the input control. And what you would notice is that the way we describe ng style is quite similar to ng class. Again, we see a directive in square brackets. And after that, again, it follows the same key value object literal format, where the key would be the CSS, individual CSS property, in our case, font weight. And the value would be, again, an Angular expression. In this case, we use ternary expression, where we would say if the last name is equal to Doe, we're going to display it in bold. Otherwise, we're going to say font weight is equal to normal. Let's see that in action right quick. First of all, let's take a look to see how birth date is displayed. And indeed, we see a green border around it. Our name, last name is Jones, and it's not in bold, obviously. But if we look at the other contact with the last name of Doe, which is what we specify in our class, we see that the name appears in bold. How about the same kind of dotted syntax called style binding for ng style versus ng class, you ask? Let's see and how we can get that done. I'm sure you've guessed the syntax by now. Let's see how we can change the first name to, say, be of border red. So we're going to flip back to input control for the first name, and familiar syntax by now. Again, it's dot, where style signifies I want to set an individual style property, not a class. The property I want to set is a border color, and we simply hard-code it into another valid Angular expression of red. In single quotes again, because remember, if we remove single quotes for a set, we will get an error because property red does not exist in our component. So if we don't have single quotes, Angular will attempt to interpret this as a property. So let's flip back to our browser to verify our results. We're going to go ahead and reload our control, and we can see the border appears in red. Good work! That's about it for this video. We'll learn how to conditionally change our user interface by applying CSS classes and style, as well as individual class and individual style. In the next video, we will discuss in details how we can build user interface elements for items contained within a list or an array. In the previous video, we'll learn how to apply dynamic styling via ngClass and ngStyle directives. In this video, we're going to take a look at how we can display lists of data by applying the same HTML template to items in the list. We will start by duplicating the HTML area for each item in an array via data binding. We will learn how to show views for just a subset of items in an array. We will also discuss how to use iterator variables. We glanced over loops in previous section. Let's discuss the display of list of items in a little bit more detail. We will start by looking at ng4 directive. First, we have to create a template to apply an item in an array. In our case, we use contact types item component, which is defined inside our list item component class, which is this one, contact type list item. However, we could just as easily iterate and duplicate an individual item exactly the same way as we did by applying a separate component to duplicate. We see a familiar template inside of our ng4, which starts with an asterisk, an important item to remember. Then we define our iterator variable by using the let keyword and then the variable name. The of keyword is important, which indicates what we're going to enumerate over. And in this case, it's contact types property, which is defined inside of our component as well, and populated with a list of contact types. In our case, this local variable item is passed into the item component by binding it to an input variable inside our contact types item component, and it's bound to this iterator variable. In other words, each duplicated directive, one per contact type in the list, gets an instance of this iterator variable. Of course, we can just as easily, as I mentioned, use loose HTML by using IL tag directly. The actual data we bind into is exposed via contact types property in corresponding component populated via HTTP call. In addition to main loop variable, in our case called item, ng4 exposes other loop variables. Index variable contains zero-based index of the current item being bound inside ng4 loop. For example, you can easily know that you're showing the first item in an array by comparing the index to 0. Last is an indicator that you are on the last item in an array. Even the not variables are self-explanatory. One easy use of even not is to apply different styles to alternating rows. Let's see how we can accomplish that. First step for us is to capture our additional variable called even. In this case, what we would need to do is add the semicolon to start another code block, and in this case we're going to define a new variable called even, and we actually will bind it to the predefined even iterator variable inside of G4. If you want to disambiguate, you can call it even flag or something like that. All we're trying to do is capture the iterator into a local variable. What can we use it for? How about we apply an inline style with ngStyle that we learned in the previous video. The idea is that we can apply dynamic style based on data condition as we define them in HTML or in our data. How about we change the style font family style variable? All we need to do is add to our iterator, in this case context type variable. We're going to add one more thing to it, and the code that you see is quite familiar. It's a style and then a specific style property you want to change, and we're using this even variable that we capture, and all we do on even rows we use fantasy font family. Otherwise we're going to use the base one that is already used inside our page. Let's see if this code works. We're going to refresh our page to reload our script. Then we're going to go to types, and as you can see now, our odd rows, which starts of course with an index of 0 and then goes to 2, you can see that font family is obviously different from the even rows. At times we want to show only a few items in the list, maybe most relevant ones, maybe the top X. Then we want to, for example, click a button to show the remainder of the items. We're going to use slice pipe to support this functionality. First of all, we need to import the slice pipe. However, because it's part of common, there is really nothing extra we need to do, because our module already imports, just as a reminder, already imports common module, which will contain our slice pipe. Now all we need to do is use the slice pipe. And just a reminder, slice pipe takes a couple of parameters more specifically, and those will tell the pipe to take the subset of this context types array, and the subset is defined by first, which is the starting position variable, and if you recall, all the parameters are separated by colon. So our first parameter is 0, which says start with a 0 subset index, and go till, in our case, we're going to bind to a property defined in our components. Slice pipe essentially transforms the data on the way between component and the UI. So let's add this property to our component, and of course it's a number, and we're going to simply immediately set it to 2. In this case, when we run it, we should see that our number of items shown is only 2. So far we have 4. So let's reload our new page, and as we can see, only 2 are shown. I think we made a typo somewhere, so letter F is shown, which is right here. Now let's see if we can add a button that will set this variable to maximum value so that we can see all of the context types. So I'm going to, in this case, paste that in just below our UL, or we can even do it inside for that matter. And what we have here is just a button that calls show all. In this case, we also use ngIf directive, and we specify the condition to only show the button when total number to show, our property, is less than the overall length, meaning that they're only gonna pop up if we don't show all of the items. Now show all it does, it sets the total to show property to the maximum value, which is essentially the overall length of context types. And this is our function. Now let's reload this again. See if our button pops up. We made a little mistake. And so what is happening is that we hit in the length parameter before the data is loaded. As a result, our ngIf here generates an exception, because in this case contact type dot length has not been defined. So just to work around it, we can of course simply set in the initial value in the constructor, we can just simply set contact types to an empty array. Alternatively, of course, we could postpone the loading and say total to show would be contact types, for example, and total show less than length. In other words, we just need to find some way to avoid null reference exception. And in this case, we have 2, and as soon as we click show all, you see all 4 contact types are displayed. Cool. So in this video, we have drilled more deeply into binding of the list data from our components to user interface by duplicating each item in an array via a template via ng4 directive. In the next video, we will learn how to display the data based on conditions specified in our components. In the previous video, we looked at dealing with showing the list of data in the user interface. Sometimes, however, we want to suppress certain parts of the view based on conditions contained within our component. In this video, we're going to take a look at Angular directives that allow us to hide or show items based on true or false conditions, or even based on a specific value. We will start by looking at hidden attribute usage. Then we will proceed to conditionally remove data from DOM using ngIf and ngSwitch. Finally, we will talk about types of binding expressions that Angular supports. Let's get started. In order to hide the data without removing it from DOM, we can just use standard HTML attribute, hidden. This is new attribute in HTML5, but it is supported by all major browsers, including IE11. We can use attribute syntax, which comes within Angular 2, put in an attribute name inside square brackets. Let's take a look at that. As you can see here, I simply have my attribute followed by an expression. In this case, it's a type name, which, if you recall, our local variable defined by referencing ng model. In this case, when our type name model is valid, then a hidden attribute will be activated, thus hiding our error message from the user. ngIf directive, on the other hand, works somewhat differently. Instead of simply hiding an element from the DOM, it removes the element from the DOM based on the condition specified in the ngIf attribute. As a result, Angular will free up resources used by elements as well as the data, resulting in somewhat better performance. As with other directives, we will start with an asterisk followed by ngIf, and then by equal sign followed by the condition. Condition could be a property or a function, or in this case, simply a valid JavaScript expression, or TypeScript for that matter, that can be evaluated to a true or false value in JavaScript. As a result, it doesn't really have to be a Boolean value, strictly speaking. In this case, ngIf hides the show more button based on the fact that we show all the items that are available in the list of person types in our application. So far, we dealt with a Boolean expression. Angular 2 also has a way to show or hide elements based on a specific value. It is modeled after switch statement in many languages, such as JavaScript. Here's a typical example in JavaScript. However, the syntax is somewhat different in Angular 2. Let's implement a simple use case where we want to add a message to person type screen based on a type name. We put ng-switch with that expression that will be evaluated on the outermost element that we want to evaluate. In this case, our element is the div that contains certain messages within it, each one inside the paragraph tag. The expression that we put on ng-switch is simply our type name. Then we add ng-switch when conditions onto the inner element that we want to show or hide alongside the expression that will be evaluated true or false, thus showing or hiding an element. The elements themselves must be child elements of the outer element decorated with ng-switch. Of course, we want to make sure that all conditions are different. In this case, our ng-switch case is evaluated to a constant, which is a word friend or word enemy. Otherwise, we use ng-switch default, which is a catch-all condition not covered by a previous ng-switch statement. Of course, we can use any expression, but in this case we use constants. Let's take a look to see how it looks in the browser. We're going to pull up a specific type, and then just for the demonstration, as you can see, as soon as name is equal friend, friendly type message comes up, and as long as you use enemy type message comes up. Otherwise, we use our catch-all condition, which is the one that doesn't match all the explicitly specified ng-switch when, giving us an unknown type message. This is the ng-switch in action. We have seen many binding expressions in this course. Expressions are used everywhere in Angular 2 applications. They're enclosed in quotes and follow typically directives, events, or attributes. Function calls can be used in binding directives. They're indicated via parentheses. In this case, click enclosed in parentheses. Function calls can contain parameters. In this example, we're getting the original JavaScript event, but parameter can be anything, like a named variable, a constant, or a bound property. A constant are simply data enclosed typically inside single quotes, which themselves are enclosed in double quotes, just like any other Angular expression. They don't have to be strings. They could be other types as well. Any valid JavaScript expression can be successfully evaluated and is considered a binding expression. We see, for example, here a ternary operator that Angular 2 supports, just like many other languages support ternary expression. Properties on the components are probably one of the most common ways that you can create a binding expression. In this case, we use contact type, which is a property on our component, and we refer to a property on it called a type name. Of course, we can also use indexers. In this case, we use first name to index into a specific, in this case, object, or we could also do the same with an array. Great. In this video, we learned how to show or hide data using Angular. We also talked about examples of binding expressions that are used everywhere in Angular 2 applications, including in our conditional display. In the next video, we will discuss UI optimization technique, change detection strategy. We will also look at how to query application components. See you then! In the previous video, we learned how to conditionally display data in our application. In this video, we're going to take a look at how change detection and components queries work. We will start by discussing how to set change detection strategy to optimize performance. We will then look at Angular 2 capabilities when it comes to querying child components and also looking at the host component. Change detection strategy in Angular 2 is the part of the framework responsible for monitoring changes between components and user interface and making sure the two stay in sync. Change detector is executed in cycles, each cycle identifying the changes that occurred since the last run. Angular gives us an ability to decide what happens at the end of change detection cycle. We can either continue to check changes or maybe stop because we know that the user interface will remain static after a certain check. We can do so by specifying change detection strategy in our components. We can pick one of the two enumeration values. Enumeration value on push means that change detector will be set to check once during hydration process. This means that change detection can stop and not run anymore after the initial run. This means that UI will no longer be synchronized with an underlying component when changes occur inside that component. Default means that change detector will remain in check always mode, keeping responsive to the changes in the underlying component. Change tracking component can be in one of the many statuses. Besides the check once and check always that we already talked about, it can be in one of the following statuses. Check means that change detection will be skipped until the change detection mode will change to check once again. Detach means that the detector is not a part of the main tree and will not be checked. Error means that an exception occurred during change detection that must be addressed for change detector to work again. Finally, destroy means that change detector is destroyed or will no longer function. Let's see how we can implement this in our read-only component, an individual item component inside our contact list view. First of all, we need to import change detection strategy enumeration in our component. Because there are no capabilities for the user to edit our information on the screen, because it's a read-only screen, we can safely stop tracking the changes after the initial view is displayed. To do so, inside our component decorator, we need to set one more property called change detection. And in this case, we're setting it on push because it's our read-only component. Visually, we will not see any differences after we make this change because, as I mentioned, there are no editing capabilities. Now let's talk about child components. If we were to write a jQuery app, we would be able to query the user interface for certain elements. Components in Angular 2 make it easy to achieve the same goal without dropping way down the abstraction tree. This is where viewChildren and viewChild decorator come in. These decorators are virtually identical, but one can contain a single child component and the other one multiple. Both allow us to reach into the template of the current component and pull out child components in order to either examine or perform certain operations on it. Let's see how we can implement this in our person list component. First of all, we need to import the necessary parts from the framework. In this case, we need after viewing it, and then we need query list and viewChildren decorator. Query list is an observable collection of components. We can subscribe to its changes in order to be notified when this collection changes. In other words, when we have more child components in our view. Now we need to implement after viewing it, as well as define a property that will hold our child collection. So let's start with that. We need to define a property. We're going to call it view children, and it would be of type as we specified before of query list, which will contain our child component, and our child component is contact list item. Now we need to tell Angular that this property is responsible for containing child components. So to do so, we can decorate it with view children decorator, and it takes one parameter. It could be a string that finds the component in the DOM, or more easily, it could be the type of the component. In this case, our component type is contact list item. Now we need to find a way where we can safely query this child view. And this is where after viewing it comes in. First of all, we need to implement this interface. And now this interface defines a single method called ng after view init, which is a type void. It's more, you can think of it as simply notification function that will fire after the view's been initialized, meaning that our view children property has been initialized and now can be successfully either queried or examined in other ways. Now, just for the demo purposes, we simply are going to log the fact that we are in after viewing it, and then we just want to take a look at what our query list looks like. And we're simply going to echo that to console as well. Now, in order to see the results, we need to run the application. We're in our app, and I'm just going to refresh the page to pick up our latest changes. And as we can see, query list got echoed out immediately after viewing it. And if we want to take a look what this query list of component contains, we see our two contacts, as we see two of them in a list. And the results, which is our query list, will contain each of our contact list item, actual instance of the component that will contain, in our case, has a couple of properties, one in the actual contact that is displayed on the screen, and the other one is the internal property for the router, so we can navigate when the edit button is clicked. Well, that's now we can see how we can successfully subscribe to changes to child components rather than reaching into DOM. Alternatively, we may want to query our host component. Host is a component that is the outer element in which our component is injected. As a result, we can, for example, reach out into our parent and then look for sibling components, for example, inside the host's template. These decorators that you use, which is content children, content child, are very much analogous to view children and view child. The interface that activates them is called after content init. You can easily guess now that it has a single method, ng after content init, after which it is safe to query the parent component. Awesome. In this video, we'll learn how to optimize application through change detection strategy. We also learn how to stick to Angular abstractions instead of resorting to querying DOM directly in order to look at parent and child components. In the next video, we will learn how to dynamically determine which component should be loaded at runtime in a specific view. Hello, and welcome to Dynamic Component Loading video. In the previous video, we looked at how to optimize change detection and query components without having to directly refer to HTML DOM. In this video, we're going to take a look at how we can dynamically load the components at runtime rather than describing them at design time. We will create dynamic components using the same design as before and make them good substitutions for each other. That will plug in dynamic loading of one component or another and learn where dynamic component is loaded in the DOM. We are going to get started by creating a host component with a placeholder into which we want to load another component dynamically. I have created such component ahead of time. It is quite simple, and it has two couple of substitutable components that I called option 1 and option 2. Our host component will be the one to decide which of these option 1 or option 2 we want to select. For example, we use a very simple case. We will want to show option based on the fact if today is the even or odd day of the month. This use case is contrived, but all we're trying to do is decide which component to load and where. Next, we need to write a couple of simple components, which we have done before. Now we need to move on to the next step. I added some imports that we're gonna need. We're gonna need viewChild and viewContainerReference, as well as component factory resolver and injector. We're going to need all of those to dynamically load components. ViewContainerRef is simply a class that serves as an abstraction of the view container where child components can be loaded. Component factory resolver is responsible for creation of component factories, in turn responsible for creating components and marrying templates and the component definitions. We just saw how we can use viewChildren decorator. In this specific case, we want to use viewChild in order to specify where to load dynamic component by attaining a reference to a view container. Our container is marked in the view by #options name, which is simply a div which will serve as the host. Now let's define this reference. In this case, it is simply a property called dynamic component target, and I'll move it on to the next line. And this is the one that is of type viewContainerReference. And I'm using viewChild, which is similar decorator we saw before. In this case, I'm using a selector rather than a type. And the selector matches our #option, which is just simply an ID-based selector. And once we find that div, what we want to read is the viewContainerReference corresponding to that specific div. Now we need to add constructor so we can inject all the necessary components. And by components, I mean classes from Angular 2 necessary to do some work. We're gonna need a router because we would need to navigate off that page. We will also need our factory resolver, and we're gonna call it resolver of type component factory resolver. And finally, we're gonna need the injector. An injector is one of those required classes to use with a factory resolver, and of course it'll be type of injector. Now that we got all of our classes injected into our component, we can move on to the next step. We already discussed dependency injection in some details. Where do we want to perform this injection of the dynamic component? Obviously, we don't want to do it in the constructor. As a result, we want to implement onInit interface. So we can do it inside ng onInit function, which we define right here, ng onInit, which would be a function of type void, because we don't need to return anything. And here's we need to create our components. And in this case, it's quite a bit of typing, so I pre-typed it in. Our definition is quite easy. We just want to see if it's an even or odd day. The next line is the one we want to spend a little bit of time on reading this code. We use component factory resolver to create a factory. In this case, it's a method called resolve controller factory, component factory. And we're going to create one for either option 1 or option 2, which are one of our two components. And then we're going to create the actual component factory for one or the other. And the parameters to it are simply the necessary classes that the framework needs to create components. It's going to need the injector for dependency injection. Second parameter is any additional information or nodes. And we don't need any extra information, so we're passing in a null. And finally, we need to specify the location where the component is going to be injected into the view. In this case, we're going to ask viewContainerRef for its element. An element, of course, is elementRef, which is abstraction on top of native HTML element. In this case, the factory operates on native HTML. Hence, we're going to ask elementRef for its own native element. Now we need to add our dynamic page into our module and into our view. So the adding it to the module is pretty simple. Because option 1 and option 2 are also components, we want to add them to declaration in addition to our dynamic page component. Now we just need to add it to the menu. And this is simply going to be just a link that's going to redirect us to a route called dynamic, which is where our dynamic page is located. Now it's time to run the app and see what we ended up with. Let's refresh our page and see our result. We're going to move to our dynamic component. And as you can see, we got an error. No component factory found for option 1 and down below for option 2. There is one thing that we forgot to do, which is because our option 1 becomes sort of a top-level component, it needs to be added to the list of entry components inside our application module. And entry components, we haven't discussed much, but those are specifically for top-level components. Let's refresh our page and try again. We'll flip back to the browser, refresh the page, flip to dynamic component, and as we can see, our view got loaded, and today is the even day of the month. So the even option was loaded for us dynamically. Good work. Well, that's about it for this section. In this video, we'll learn how to dynamically load components at runtime versus design time, and which is the best route, and we followed it by the information that we'll learn in previous sections. In this section, we'll learn a number of building blocks included in Angular 2. We discussed dynamic styling via classes and individual style properties. We talked in details about displaying lists of data. We saw how we can suppress the display of elements based on conditions. We talked about options for change detection. And finally, we discussed dynamic content in our application. In the next final section, we will dive a little bit deeper into options that we use when talking to our server using HTTP classes. We will also outline the next steps that we are going to take in advancing our knowledge in Angular 2. See you in the next video. Hi, and welcome to section 10, working with server data and next steps to learn Angular 2. In the previous section, we saw built-in Angular 2 classes that help us build user interfaces. In this section, we will discuss RxJS or Reactive Extensions Framework and how it is used with Angular HTTP code. We will look at how HTTP calls are created in order to insert, update, and delete data. We will wrap up the section by talking about next steps in learning Angular 2. Now we move on to the first video of this section that deals with the Reactive Extensions Framework or RxJS. In this video, we're going to take a look at what is Rx Framework. We will see how event and data streams are exposed as observables. We will see how we can subscribe to events. Finally, we'll take a look at other Rx methods besides those that we use that may come in handy. Rx Extensions Framework is a JavaScript framework for handling events and other asynchronous programming tasks and expose that data as observables. When we query these asynchronous streams with many familiar LINQ or language integrated query like operators such as first, take, skip, etc., we can handle concurrency using schedulers that provide functions such as delays. You could think of observables as event or data streams that you can subscribe to in order to be notified when something interesting happens in your program. The observable class itself is a TypeScript generic class. Thus, it can contain items of any given single type. Because observables can be enumerated, we can perform a number of useful operations on them. Just to give us a taste of those operators, here are a few. Filter takes a predicate or a function that takes an item or an event inside the observable and returns another observable that is filtered by this predicate. Map operator takes a function that inputs an item but outputs another type of item, allowing us to do transformations on streams. Group by allows us to group data by some field. Take and skip operators allow us to take certain number of items from the stream or skip some. The key part to this is that these operators return observables, allowing us to create infinitely complex chained observable streams. We can call subscribe method on an observable, thus getting a subscription object back. It will allow us to unsubscribe from notifications when we want to destroy a component that subscribes to those streams. Other events or data will be pushed into our function or observer that we will be passing to the subscribe call. Let's take a look at some more operators. All the observables are not compatible with promises. We can easily, through RxJS, translate one to and from the other. For example, we can start with an observable from a static from promise method. The opposite is possible as well, convertible and observable into a promise. We could create observables from events attached to an HTML element using from event. This is compatible with many frameworks such as jQuery, Ember, and Angular. We have built-in error handling via a catch method. We can use windowing functions such as start with and take while and start observing from a specific element inside an observable stream. We would be using start with in this case. We can also observe while a specific condition is true using take while. There are many more operators available in the framework. Now, let's take a more informed look at the code that we saw a while ago when we looked at the fetch code for person type screen. The get method of HTTP class returns an observable of response object. As we can see from here, inside our subscribe function, we're passing in a function that takes a single parameter, which is a response. This response object abstracts the HTTP response call containing properties such as status code and JSON body. This is different from HTTP in Angular 1 that was based on promises. Promises are good for asynchronous programming, where you expect a single value returned as when a promise is resolved or completed. Reactive programming, on the other hand, unifies promises and events and callbacks into a single stream, enabling us to perform very rich composition. In this method, we start the call, then subscribe to an event stream, and observing the results in the function that is an anonymous function that we pass into subscribe. Then we process each result by pushing it into another event source that is very, very specific. In this case, it's our custom event indicated by subject type that contains a list of person types. This event source, of course, is created by us and is exposed from this service to a consuming component in our case. Thus, we can abstract the fact that we get the data via HTTP call from the component, and all the component should care about is the fact that there is a stream, in this case of a list of a person types, and the component will be notified as the stream arrives. Cool. In this video, we furthered our understanding of our XJS framework. In the next video, we will look into performing insert, update, and delete operations that call our Web API services from our TypeScript code. Welcome back. In the previous video, we learned that the basic functionality and advantages of reactive extensions over promises, and realized that HTTP functionality in Angular 2 relies heavily on our XJS framework. We will start this video by learning HTTP verbs supported by Angular 2 and HTTP REST standards they follow. We will then add insert, update, and delete operations to our Angular 2 injectable service. We will finish up by making sure that our error handling is a little bit more robust. Let's get started. The following HTTP verbs are supported by Angular 2. Get verb is designed to get the data from a service. If we follow HTTP standards, REST standards more specifically, these requests do not support body and should be done via URL alone. The result is contained within the body of the return message. Post verb is issued to create new data or handle inserts in our case. The data is transmitted in the body of the message. The return value should be updated or inserted object. Put verb is designed to handle full entity updates. The data is transmitted in the body, but the return value, if successful, should not contain the body, just a success status. The errors, however, can be transmitted in the body. Delete verb handles deletes, as the name suggests. The request, again, should not contain a body. The return value, if successful, also contains no body, just a status. The errors can be, again, transmitted in the body. Other verbs such as patch, add, and options are also supported. We would also use a request method on HTTP class. We could also use the request method on HTTP class, which accepts an entire request object. Let's start by adding an insert method for person type service. This is what our server-side code looks like, just as a reminder. In here we check in data for validity. Then we transfer the data from our business model into the data model. Then we commit in the data model using entity framework. And finally, we return in the saved object. In this case, because we use server-side generated IDs, it will contain new ID as well. And of course, we map in the data object back to our business object. In order to call this method decorated with a post event, which is suitable for inserts, we need to make HTTP call in Angular HTTP class using the corresponding post method. Here's what it looks like. Let's address this last parameter, optional parameter, request options first. Because our service expects JSON, we need to set default options for all of our service calls to contain the appropriate content type header. We will add a property to our service to hold the default options, such as this private property, since we don't need to expose it to the outside world. We can populate these options in a constructor. In this case, the only thing we need is default headers, which is headers class in Angular 2. We simply add in a default header for content type using application JSON. We see let keyword here, which is one of the newer JavaScript standards. It creates a locally scoped variable. It could be used pretty much anywhere where we use var keyword. Because our insert method takes body as a string inside Angular 2, as we write our insert method, we need to stringify the body. In other words, the method takes our person type object, but then it stringifies it in order to make HTTP post call to submit it to the server. At the same time, we using our default args that come from the service. Because this method, this post method, returns an observable, we need to subscribe to the result. We used an inline subscribe call for that, as well as the anonymous or inline function, or fat arrow function, as some people call it, because of fat arrow in TypeScript. Once we have the response object, we need to pull out the JSON method out of it. And this is how we do that. So in other words, we take the body and we pull the JSON as an object, which will automatically convert that for us into a JavaScript object. And then we push in the result into our custom event emitting object called content type edit. And as we can see, the type of that object is familiar subject type, which is essentially a stream of events, or in our case, stream of objects, of person type object, that we can communicate cleanly into our component by subscribing to it there. So, in our controller, in our component that uses the service, we just need to subscribe to content type edit. And if we take a look at content type edit component, that's exactly the code we're going to find. We're going to subscribe to content type edit, and we're going to do that for both inserts and updates. Let's take a look at the update method while we're on the topic. You will find that there are big similarities between an insert and update. And the key difference is instead of post, we use put method. And we use actually the same event emitter object, except the result comes from the same person type that was sent to us. And we could, of course, not do that, but this kind of simplifies the code inside our component by having insert and update looking the same. Now on to delete call. As we talked about before, all we need is the type ID if we want to follow REST standard. Then we create a full URL that contains our API plus person type ID. No body is submitted in this case, and default headers are also not needed since we're not submit exactly for the reason that we're not transmitting the body, and server doesn't need to interpret it where content type comes in. And again, we subscribe to response, which in this case just contains the status, and we push in a new event emitter, in this case, or event stream, more specifically, which is also subject, but in this case of a number. That way, the consuming component can know which specific type ID was deleted last. Now let's take another look at error handling. When our data is invalid on the insert, we actually get a JSON object with errors that comes from this model state object. In this case, we parse in this object by looking at its properties, and because we know what property contains, which is the error, it comes from property, and it contains any property can contain any number of errors. So we have a basic loop right here. We could also get plain text in a body, and it could be for a variety of reasons, like an unhandled exception. That's why this, just in case we wrap it inside try-catch block, and we're looking at, in a catch, we're looking at anything that is filled out. So we're looking for text first, which is the body of the message. If that contains no information, then we're going to look at status text. And finally, if that contains no useful information, we're going to look at the status code itself. What we notice here is that we already see similar code needed for all of our specifically services. This is the sign that we want to do one of the following. We could create a base class for all of our HTTP style services, or we could use composition and create sort of an HTTP request error handler injectable that we could inject into all of our services. And a final note, if we want to show a please wait message while our HTTP service call is in effect, we could always use the same toaster library we saw in previous sections and just add a toaster when a call is started with an informative message, then hide that toast when a service call completes, and finally show the new one with the status of our call. Good work! In this video, we have built out our services that we use to process the data on a server to handle insert, update, and delete operations. We also talked a little bit more about our error handler. In the next video, we will work on communicating events between child and parent components. In the previous video, we learned how to perform insert, update, and delete calls from an Angular 2 injectable service using HTTP. In this video, we will start using an event emitter to set up custom events in the child component. We will wire up the event listener from the parent component. We already saw how we could wire up property binding between two components using attribute binding, such as contact type. Another aspect of inter-component communication would be informing parent component from a child component when something interesting happens in it. This is where event emitter class is used in conjunction with familiar event binding and the output decorator. Event emitter is a class that extends subject of T, a class from our XJS framework we already saw. It adds a couple of methods, emit and subscribe. Ordinarily though, if you use standard binding, subscribe and unsubscribes are handled for you automatically by Angular 2 framework, which results in less code. In this specific example, in this video, we're going to wire up a functionality where contact type child component informs a parent where a mouse when a mouse is entered into its HTML DOM area. Let's get started. Let's add an event listener for our host in contact type list item component. We already saw this host level binding that is available to us in Angular 2. And we will add a host listener. In this case, we will sign up for an event called mouse enter, which again is a native DOM event, mouse enter, which will fire when a mouse enters the area above our component. And we're going to create a listener. We're going to call it on mouse over, for example. Now we need to define an event source, which will be a property of our component. In this case, we're going to call it mouse over, which would be our property, and the type is going to be event emitter class of the same kind of a model, which is person type. We do need to import this event emitter from the Angular core, which we can do that as we import all other necessary classes. Now, what we need to do is decorate it with the output decorator. This decorator is opposite to input decorator that we see right here. And we use it in exact same way at output. Again, we have to import output from Angular core. This finishes up wiring up our event. Now we are ready to wire it up in a constructor, which we have right here. So we have to create an instance of our mouse over event, and this would be a new event emitter of this specific type, person. Now that we created an instance of our event emitter, we could push an event into it, and we're going to do that by creating this onMouseOver that we specified before, a method. And it's just a standard void method because it doesn't return anything. And now we just need to push a new event, and we're going to use the emit method of this mouseOver property, and it takes a single instance of contact type, which is automatically assigned here in a property through the input event binding in this case. Now we just need to subscribe to this event inside our parent template. So let's flip back to our contact type list component, and in here inside of our contact type item component, we're going to add a new listener. MouseOver is the event that we defined right here, and onContactType MouseOver is simply our event handler inside our contact type list component. And to save time, I'll go ahead and just paste it in. onContactType MouseOver. $event that we see here is simply the event arguments that are going to be passed into MouseOver event are going to be automatically passed over to our event handler. Just a reminder, what our event args is the instance of the contact type. Now, this kind of concludes our code. Our code here, just for testing, we want to echo contact type to the screen. So let's run the browser and see this in action. We're going to refresh our page to reload with the changes. We're going to pop up our browser tools so we could see our method being called We're going to flip to contact types. And as you see, as I move mouse over the type, we see that our event args contain the specific person type that mouse was moved over. Good work. So in this video, we have added communication between components using events. We're using the output decorator and event emitter. In the next final video of this course, we will conclude our learning by laying out plans for further education using Angular 2. Hi, and welcome to the next steps in learning Angular 2 and TypeScript video. In the previous video, we learned how to communicate between two components using events. In this video, we will go over additional functionality that exists in all the frameworks we talked about. We will talk about testing, we will discuss command line interfaces, we will discuss environment choices, we will also talk about how to keep up with ongoing development in Angular and TypeScript as well as ASP.NET Core. We will also discuss the philosophy of keeping your components manageable. Let's start with the testing discussion. There are a number of JavaScript testing frameworks out there. Jasmine is one of the more popular ones, but there are others such as QUnit and Mocha. Angular 2 team tests their own code using Jasmine JavaScript testing framework, so it seems to be a natural choice when it comes to unit testing our own Angular 2 code. Of course, our choices are not limited to these three. There are other frameworks as well. Let's go over the steps of using Jasmine with Angular 2. First of all, we need to download Jasmine library npm package. We could use npm or we could even use bower. Then we need to get TypeScript library definition file for Jasmine. We could download them from GitHub or use Typin's tool that we used before. Typin's node module allows us to easily add type definition for any library. We can install Typin's itself using npm or node package manager as well. Then we can create an HTML page that will host our test files. We could use the one that comes with Jasmine itself or create a new one. Finally, we need to create the actual TypeScript file that will contain our test code referring to Jasmine test library. We need to import the component classes and any other reference module in order to test our component. Then we can simply write test functions using Jasmine API. We can look up that type of code in Jasmine homepage. We could create HTML test harness page, or we can use Karma to run our tests. Now let's take a look at CLI or command line interfaces for Angular 2 and ASP.NET Core. Angular 2 CLI has a number of features. It is also resides in npm and can be installed npm or node package manager. Then we can use ng command line to run its various functions. For example, ng new and then project name will create a new Angular 2 project. We can also build our project, including compiling TypeScript files. Also, command line interface supports building for production or development environment using Webpack tooling for screen bundling as well as tree shaking, which means removing some of the unused JavaScript, resulting in smaller footprint from both memory and download perspective. We can now compile HTML based on the component templates used in components themselves on the server, thus shifting some of the work necessary to create a live Angular 2 application in the browser to the build time on the server. We just need to switch from platform browser dynamic module to platform browser Angular 2 module for application bootstrapping. We can drive karma as well from the utility. We can also lint our code, checking for most common deviation from best practices using TypeScript and JavaScript. CLI is under continuous development, so likely it will get more features as time goes on. We already saw .NET command line utility in action. It allows us to drive various parts of development process and testing via our development command prompt. It has features that help you with your projects. It can, for example, restore all the NuGet packages. So if you download source code for our test project that comes with this course, you can use it to restore NuGet packages that are referenced. We can run those projects, which we saw already, type in .NET run. It can also have some scaffolding capabilities, allows us to generate certain files, as well as actually build our project for testing. Where do we go from here if we want to continue learning or just to create our first project? First of all, we need to set up the environment. We need to pick a machine. We need to pick an editor. Finally, we can use npm package to help us get started using Angular CLI to create new project, or simply follow Visual Studio project. So far, we stuck to Windows, but both TypeScript and Angular are supported on all three major operating systems. We can also deploy to Linux or Windows-based servers. Next step for us is to simply pick an editor or integrated development environment, or simply a text editor. Many choices are available, so chances are your favorite one already supports TypeScript. So far, we wrote a number of components that work together to compose user interface. For example, we had a shell component, inside which we had a list of contact types component, inside which we had individual contact type component. So our app is just complex tree structure composed of components. Our goal is to keep each component relatively small and hopefully reusable. Smaller components have fewer reasons to change. They perform just a few functions, hence they are easier to test. It would be important for us to find a happy equilibrium between a very large number of components in a very large app and relatively manageable component size. The video course is the start of a journey. We want to be able to keep up with future developments of all the frameworks we discussed. We could do so on GitHub, where all the projects we used reside. They all have learning resources as well as links, and here's the quick list of all of them that you can hit to keep up with them. Finally, we can find learning pages that each framework has. Also, if you want to, you can go to packpub.com and search for any frameworks you want to study. In this section, we took a look at reactive extensions and learned more about using them for making HTTP call and as an alternative to promises. We learned how to call, insert, update, and delete functions in our web services. We used an event emitter to establish communication channels between two components via events. Finally, we discussed how we can continue on our journey to continue learning TypeScript, Angular 2, and ASP.NET Core. As we work through our course materials, we'll learn TypeScript, a new language we're going to use to write Angular 2 applications in. We'll learn the basics of ASP.NET Core and wrote web services that can be used to persist data in SQL Server. We studied the key building blocks of Angular 2, writing a small application and an example. Now that we're familiar with Angular 2, let's go to work and use our newly acquired knowledge for greater good. Thank you.